Hello everyone, welcome to DevOps Full Course by Intellipaat. The days when people used to master one skill and work on it with the blenders for the rest of their lives are over. However, with DevOps, you can be the master of multiple skills. With over 206,000 jobs worldwide listed on LinkedIn and 13,524 opportunities on Indeed, it's evident that DevOps has become more than just a trend. It's a vital component for modern software development and IT operations. If you ask why, Deloitte reports that DevOps boosts developers' productivity from 30 to 40%. Companies like Netflix and Adobe see significant improvement with 74% of organizations already adopting DevOps practices to enhance their software development lifecycle. With this free DevOps course, we will be helping you guys understand the fundamental of DevOps. We have made sure to align the content of this course to DevOps job description, and we have also added some interview questions that are being asked in top IT companies. Here's what the agenda of this course looks like. In this course, we will cover the essential of DevOps, a methodology that integrates development and operation to enhance collaboration and productivity. We will explore how DevOps works and dive into the tools like Git for version control, Common Git command, and Docker for containerization, comparing Docker with virtual machine and understanding the Docker container lifecycle. We will also learn about creating a Docker Hub account, writing Docker files, and distinguishing between monolithic application and microservices. Docker Compose and Kubernetes will be introduced for orchestration. Along with that, YAML Files for configuration. The course will cover the Puppet and Ansible for configuration management, provide an introduction to the software development lifecycle, and compare DevOps with Agile. Finally, we will guide you on how to become a DevOps engineer, including tips for interviews. I hope I have made myself clear with the agenda. But before we go ahead and start learning DevOps, I would like to inform you guys that Intellipaat has just crossed landmark of 10 million subscribers. And it was only possible because of your immense support. To thank all of you and celebrate this achievement, we have come up with a super rewarding quiz challenge. You answer the quiz correctly in the comment section and stand a chance to win 500 rupees Amazon gift voucher. Remember that the top 10 comments with a correct answer will receive the reward from our end. So ensure attending the session properly and don't forget to answer those quiz questions. Having said that, without any delay, let's dive right into today's session.
In any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team and the second team is called the operations team. Right? Now, what is development team and what is the operations team? A developer is basically a person who develops the code, right? He would develop the code and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he's sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operation system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious, it ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps, right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking. and this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as you saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? And then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. Its release cycles and hence releases software in even lesser days or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for a year, what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool. It is not a software. It's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities, and if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase, where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you know, you're operating the software or you release the software for internal employees to see whether you know, the traffic, when is it doing good when it holds when it's getting traffic onto it, is it doing good when normal people are doing arbitrary tasks on your software. And then you are also continuously monitoring it to see if you know, your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys, is by automating this life cycle. Basically that means that now the developer does not have to give the code to the ops guy. It'll basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps life cycle actually works, right? So if you were to that infinity sign that we had, it, if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developer's side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developer's side to this side of the operator's side, and this is done using continuous integration. Now what is continuous integration we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server, now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work. right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version and at the same time it also holds on to the previous version so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN. And continuous development is an integral part of pushing code to your version control system. Okay. Now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, or it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares on system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system, it is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay. So let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now, continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version controls tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage, then we have continuous integration. Now, you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now, configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now, if you want to test your application on that system, what you have to do is, you first have to install all the softwares on it. Right, for example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python. All these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now, continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium for testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about. And this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? and this brings us to the DevOps Tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer and the developer was basically pushing code onto a version control system. This is a replica of that figure, and in this figure we have just replaced the tools with the life cycles. All right, so now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that on GitHub your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps. So let us get introduced to Git, but before that, let us understand, why are we only learning Git? Why not some other tool, right? Like I told you guys, there are a lot of distributed version control systems out there. Why are we only learning about Git? Right, so let me just compare it on Google Trends, and this is the result that I get. Right, so if I search for Git, Perforce, and Mercurial, which are actually the top 3 distributed version control systems out there, you can see that the Git tool is the most famous among them all, right? So that basically means that if you learn Git, you have a high chance that you might land up in a DevOps job more if you know Git than Mercurial or Perforce. Because Mercurial and Perforce, because the popularity is low, we can easily conclude that not much of the companies are using these two tools, right? So most of the companies are using Git. In my experience also, I've seen most of the companies do use Git, right? And that is the only reason we have included Git in our course, and that is the reason we are learning Git also today. All right, so moving forward, now let us see what Git is exactly. Right, so Git is a version control system. It's basically a software which falls under the architecture of distributed version control system, right? And it does the same things which any other version control system does. That is, it tracks changes, it keeps your files versioned, right? And because it's distributed, you have a local repository as well, and then you also have a remote repository. Now, in case of remote repository, you get a lot of options, guys. But in our course, what we are going to do is we're going to opt for a free option, which is GitHub, right? So you might know GitHub. GitHub is famous for all the open source tools which it hosts, right? So we are also going to work with GitHub, but for now we are going to just focus on Git. First, we're going to understand what Git is, and then probably later we'll see how we can use GitHub in conjunction with Git. All right, our next session actually is going to talk about the life cycle of Git. So we have understood, why are we actually learning Git. We understand what Git is exactly, but we do not know how it exactly works, right? We know the architecture, but we do not know how it works. So basically, we've divided all the commands that you could be used frequently or you will be using frequently among these 4 domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay, so let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first, whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is, let me just switch to my terminal. Alright, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called DevOps. Okay, so let me create a directory called DevOps and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano let me add a file called 1.txt. Okay, and let us say hello world in it. So this is our first file. Okay, now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added. Now let's save this file. Okay, so now we have two files which are there inside a folder DevOps. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now, for making it a Git initialized working directory, all I have to do is type in git init and hit enter. Okay, and now we have an initialized Git repository in front of us. Okay, so this is how you can initialize a directory in Git. So now you have created a repository in which you have your code, which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository, and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see like if my files are being if my files are saved in Git, what exactly is happening with my files. So what I'll do is I'll just type in git status, and I can clearly see that my files are right now untracked. Okay, why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding. Right, so basically we have made some changes to our file and now we want to add it into a repository, and for doing that all I have to do is just go back to my terminal and I'll say git add. I can either type in the name of the files, so say I want to track both the files, so I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter, and now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically would point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter, and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now, you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now. Right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it. Right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing, the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1 to over here. Let us save it and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there is a modified 2.txt file and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of git. Now if I want the 2.txt file to be saved, I have to stage it again and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our PPT now and let's go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a Git repository. Okay, so let me just jump on to my browser and then I'll show you how you can create a Git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side you will see a button called new repository. Just click on that, right? And now let's name our repository something. So let us name it as DevOps and hyphen course. Okay, so our repository name is DevOps course and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin and then the URL of my repository. So the URL is this. Let me copy that. This is the URL and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this git repository, my command line that is working on my git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it will ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter, and as you can see, it is pushing the files, and now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. Here are the files, so you can see the changes or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is now if I do a git status, you can see that there are 2 files which have not been added. So what I'll do is let me first let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged. right? So if I do a git status now, I can see that this file is now staged. Okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file, and all I have to do is git commit, and now I'll specify the message as modified 2.txt. Okay, so this is the message that I'm passing. I'll hit enter, and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added .2.txt. It still says hello from Intellipaat, and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It will ask me my username. I'll provide the username and the password. And now my files are being pushed to GitHub. It has successfully done that. And now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third repository file as well, which is the 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master. We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files, or you can sync your remote repository to your local repository. Okay, so this was the command for that. Let's move forward now and let's check whether this step I've already done. So basically you can see that I have now synced my local to my remote repository. I have as you can see in the browser.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Okay, now let's go ahead and see what our next step is. So our next step is to basically show you guys how you can clone a repository. Okay, so this is when I have basically I have pushed my local repository to my repos repository. Now say you are another developer who wants to work on this code. Now how can you work on this code? All you have to do is click on clone or download and just copy this link. Okay, copy this link, go to your terminal, right, and let me create a folder, say test over here, and let me create a folder called test over here, and let me go inside the test folder. Okay, now what I'll do is I'll type in the command git clone and I'll give the URL and I'll hit enter. Now what it has done, it has successfully copied the directory over here. So if I do an ls, I can see that the directory has been copied, or my repository has been copied to my local. Okay, and the awesome thing about this is, now if I go inside DevOps course, the directory, now over here I don't have to basically add a remote origin, right, because you have cloned the repository. So this directory automatically knows where if I push any file, where it has to go. For example, if I create a file, say I create a file nano4.txt, I say test file for clone. Okay, I'll say that, and now what I'll do is I'll add this, I'll commit this file, adding clone file. Okay, I'll hit enter. So my file has been committed, and now I'll do git push origin master. I'll give the username, I'll give the password, and as you can see, my file has now been pushed automatically. Okay, so if I do a refresh here, 4.txt has automatically been added, and I did not do a git remote add origin even if I am in a different directory. Okay, now let me show you what I exactly mean. If I create a folder, say I create a folder called test. Okay, test exists. Let me create a folder called hello. Okay, and if I go inside hello and if I do a git init, say I did a git init, and now let me say create a file called hello world.txt. Let me add any arbitrary text into it. Now if I do a git add dot, and if I do a git commit, and I'll say let's adding file. Okay, so the file has been committed. Now if I do a git push origin master, it'll give me an error. See, it says origin does not appear to be a git repository. Why? Because I'm in a separate directory right now. Okay, now if I do a cd, I go inside test, which was my first directory where I created all the files. So over here, if I do a git push, if I add a file, say, uh, let me first uh, pull everything. Okay, so because the git pull origin master. Okay, 1 second, guys. Okay, so I think this is now the repository. Okay, so the repository was DevOps. So let us go into inside DevOps, and let me just create, or let me just say git pull origin master. So this was the directory where we first created our code. Okay, let me hit enter. So now it has, as you can see, it has added 4.txt to it, because earlier we added in a separate folder, right? So now it has created 4.txt inside it. It has added 4.txt inside it, and if over here you can see I have not specified what origin is. It automatically knows what origin is. Why? Because DevOps is a git initialized repository. Okay, similarly, when I said that hello is a git initialized repository, but in hello I'll have to specify what is the origin of that repository, right? But if I do a git clone, as I did in test, right, I went into test and I did a git clone of the DevOps course. When I do a clone, it automatically copies the parameter as well as to what my origin repository is. Okay, any files that I add, if I push it on origin master, it will know where exactly it has to go. Okay, so this is how git clone can be helpful to you. All right, coming back to our slides. So now we know how to clone a repository in Git. We also saw how to pull files in Git, but let me show you again. So basically what we want to show you is that say you are inside this folder, DevOps course, which is the same repository as what you have. Let me just duplicate this session. Alright, so this directory, which is DevOps, is pointing to the same repository as DevOps course. Okay, now if I do an ls here, I can see that there are 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. Similarly, over here, I have 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. What I'm going to do is, let me add a file from here. So nano 5.txt, and let me say test file. Okay, I've added it. Let me say git add dot. So I've staged the file. Let me commit the file. Test. Okay, I've committed the file, and now let me push the file to my remote. So I'll enter the username, the password, and now my file has been pushed. Okay, so if I have updated my remote repository, this local repository of mine will not get automatically updated. As you can see, it will not get automatically updated. If I do an ls over here, I can see there are 5 files, and if I go here on my remote repository, if I refresh, I can also see here are 5 files. But imagine this to be one developer and this guy to be another developer. Now this developer will not have the updated files till he does a git pull. Okay, so if he wants also the updated files which have been put on my remote repository, all he has to do is he has to type in git pull origin master, hit enter, and now
Let's check our quiz question, guys. Which tool is commonly used for continuous integration and continuous deployment? The options are A. Jenkins, option B. Docker, option C. Ansible, option D. Git. Hope you have written your answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
The files will be updated in his system. Okay, so if I do an ls now, you can see that 5.txt file has now been added to this directory as well. Okay, so for coming back to our slides, so git pull helps you in updating your repository to the latest commit which is available on your remote repository. So that is what git pull is all about. And the difference between git clone and git pull is, like I told you guys, git clone is basically used when you want to copy the whole repository at your local system. But if you want to update repository when you're working in it, if you want to update all the files which are inside it, you can use git pull. In that case, git clone will not serve the purpose. Okay. Moving forward, now let's talk about branches. Now, as you can see, now we are talking about parallel development. Okay. And as we learned in our previous topics or previous sessions, that if you want to do parallel development, or if you want to assign code to multiple developers, you basically branch out, right? You create a branch in your repository and you assign that branch to the developer who would be working on the code. Okay, so let us see how you can create a branch in Git. So for creating a branch in Git, this is the command: git branch and then the name of the branch. Okay, so let us see if we can create it over here. What I can do is, let me just clear the screen. Okay, and let us say I create a branch which is something like this: git branch, and say I create the branch feature 1. Okay, so the branch has now been created. Now if I want to list all the branches which are there, I'll just have to type in git branch, and I can see there are 2 branches in my repository now. One is called the master branch and the other one is called the feature branch. Okay, now any developer who wants to work on this code can basically work on this branch, and when he feels that his work has been finished, he can basically merge this branch to master. And merging means that whatever code you have added to feature branch will also be added to the master branch. Okay, don't worry if you're not understanding as of now, you'll understand as we move along. Okay, so I have added a branch feature 1. Now if I want to delete a branch, again all I have to do is git branch -d and then feature 1. Okay, so it says deleted branch feature 1. That's it. Okay, so now your branch has been deleted. Okay, and this is exactly what we wanted to do. Moving forward, now if you create a branch and you want to switch to that particular branch, the command is git checkout. Okay, so now let me create the branch again, git branch feature 1. So I've created a branch, and what happens when you're branching? Basically the last commit of your master becomes the first commit of your feature branch, whatever you have created. Whatever branch you have created, the last commit of your master becomes the first branch of your branch that you have created. Okay, so for example, in my master you can see that there are 5 files. So now if I go inside, if I do a git checkout into feature 1, so basically now I have switched to the branch feature 1, and if I do an ls over here, you can see there are 5 files. Okay, now what I want to do is I'll add a file. Say I add a file 6.txt over here. Okay, and I say hello world. Okay, and what I do is I save the file, git add dot, I stage the file, and now I commit the file, added to feature branch My file has been committed, and now if I do an ls, I can see there are 6 files now. But mind you guys, this is not on my branch manager. Now if you want to see which branch you are on, just type in git branch, and you can see you are on the feature branch right now. Okay, now what I want to do, I want to check if my master branch also has these changes. So what I'll do, I'll just switch to my master branch, git checkout master. I'm on my master branch now, and if I do an ls over here, you can see that the 6.txt file does not exist here. Okay, reason being, my feature branch is isolated from my master branch. Whatever changes I'm doing on my feature branch, it will not get reflected on the master branch, whatever I do. Okay, and whatever I do on my master branch will not get reflected on my feature branch. It works vice versa. Okay guys, so this is a feature which you basically use when you want to do parallel development, so that no branch is it is interfering with each other. So now I don't care what my developer is doing on feature 1. When he says that the feature is complete, I'll ask him to show me, and when he shows me the feature and I feel it's right, what I can do is I can merge it with my master so that it becomes available to the world. Okay, all right, great. Now if I do a git status here, git status, one second, git status, it says on branch master, nothing to commit. If I check out to feature, yeah, so if I have switched to feature now all I have to do is I will type in git status, and it again says on branch feature 1, nothing to commit. Why? Because I've already committed 6.txt to it. Now what I want to do is I want to push these changes to my remote repository. So what I can do is git push origin feature 1. Why? Because now we are pushing the feature 1 branch. We are no longer pushing the branch, the master branch. We are pushing the feature 1 branch, right? And I'll hit enter. So it'll ask me the username. I'll hit that. It'll ask me the password. I'll put that, and I'll hit enter. And now you can see my files are being pushed. And now you can see that feature 1 branch has now been pushed to feature 1 branch of my remote repository. So if I go to my browser now and I refresh it, you can see the 5.txt is still not visible here. Why? Because I'm on my master branch. I'll click here. I can see that I have a feature 1 listed over here. I'll click on that, and now I can see that the 6.txt file is visible here.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
And with my commit message, which was added to feature branch. Okay, so I can again switch to my master branch, and I can see that my master branch is clean. If I switch to my feature branch, I can see that my feature branch is having the 6.txt file. Okay, let's come back to our slides. Alright guys, so we now know how to switch to a particular branch. Now let's go to our next slide. Now we probably know all the commands through which we can probably start working on Git, right? This command is a very important command, which is git log command. Now what is git log command? Now git log command helps you to see the history of your repository. Like what all have you done on your repository. Okay, now to see the history of your repository, the command is git log. Now let us go back to our terminal and let us just clear the screen. Now if I do a git log here, I can see the history of all the commits. Okay, so I can see that I am on my head is on the feature branch right now, right? And I can see that the last commit was this, when I added 6.txt to the feature branch. Before that I had a test commit. Before that I had a clone file that I added. Before that I had some other commit, 3.txt, 2.txt, right? So similarly I get everything. I get a history of everything that I've done so far, right? And these are all the commit IDs, guys. This is what we studied earlier, right? So if I want to say revert to this commit, all I have to do is just copy this commit ID and I have to type in git revert along with this ID, and I'll be able to revert to this particular commit. But we'll do that later. We're not doing that right now. We'll do that later. But this is the history of your branch. Okay, now if I want to see the history of master, this is the history of feature 1. Okay, let me just clear the screen and let me see where I am right now. So I'm on feature 1. So if we go to git checkout and then master and then clear the screen, if I do a git log over here, you can see that the head is now on the master, and only the log of the master branch I'm able to see right now. Okay, I cannot see the log of adding the feature file. Why? Because I'm on the master branch now. So whenever you do git log, you always see the log of what branch you are on. Okay, so right now I'm on the master branch, and that's why I can see all these logs. If I am on the feature branch, I can see all the logs of the feature branch along with the logs of master branch when the branch was when basically the moment I create a branch in my repository, it gets created from the master branch, right? So say I did 3 commits before I created a new branch, those 3 commits will also be a part of my new branch that I've created. And if I go inside that branch and if I do a git log, I would be able to see those 3 commits in the log as well. Why? Because those 3 commits are also a part of those of that particular branch. Okay, so but the moment I do any other commits on master, those logs of that commit will not come in my feature branch. Reason being, now my feature branch is separate. All right, so I hope this is clear. All right, coming back to our slides, guys. So we now know how to see the history of our our git operations. Our next command deals with git stash. Okay, so what is git stash? So whenever you're working with multiple branches, there could be a point where you don't want to basically commit the file is basically still not complete, right? But you want to switch to another branch because you want to probably fix something in some other branch where you're having a problem, right? So basically it's about multitasking. It's about putting on hold the work that you're doing right now, completing the work over there, and then coming back here again and then starting with your work, right? So let me exactly first show you why do you need the git stash command. Okay, so if I'm over here right now, let me just clear the screen. Okay, so let us create let us see where we are right now. So if I do a git branch, I can see I'm on the master branch right now. Okay, so what I want to do is I want to create, or let me just switch to my feature 1 branch, and let me create a file called 7.txt. Let me name it as stash file check. Okay, so I have created a file, but this file is still not staged. It is not committed yet, right? So I am on my feature branch right now. So if I do an ls, I can see 7.txt is here. Now if I change my branch, what will happen? Let us see. So if I do a git checkout master, and now if I do an ls, you can see the 7.txt file over here. Why can you see the 7.txt file? Because this file is not being tracked right now. It is not a part of any branch, right? Because it has not been saved yet, correct? So what I can do, so let me just come back to my feature branch. What I'll do, I'll just add, or I'll just stage this file. So let's see what then happens then, right? So I'll do a git add dot, right? And now the file has been staged, but it's still not committed, right? So if I do an ls now, it has all the files. Now if I check out to my master, and if I do an ls here, I can still see this 7.txt file. Now this can become a problem, or this might cause a confusion when you're working within branches or when you're working with production code, because you don't want this file to be here when you're on the master, right? Because you don't want your code to go haywire or cause a problem because of an extra file, or probably you changed something in 5.txt. Let me give you an example. Let me check out to my feature 1. Okay, and let me go to 5.txt. So this is my 5.txt, and it's there in the master as well. Let me change the contents of this file. Okay, so I've changed the contents of the file. I'll stage it. Okay, and I'll do a git checkout master. Okay, I'm on my master branch now. I'll do an ls, and now if I do a cat of 5.txt, can you see these changes are also there in the master? I don't want that. I don't want that to be reflected over here because my feature branch should be different from my master branch. Now to avoid this confusion, although this file is not saved on the master yet, right? It is just being reflected over here. Reason being, these files are not committed to your branch in your respective branch where you were working. Okay, so how can you avoid this? Now the way to avoid this is you would just check out or you would just check out to your feature branch where actually you want this file to belong. Okay, and it tells you that these two files are there which this has been modified and this has been added. Okay, so it gives you a notification, which is good. Now what you'll do is you'll say git stash. You'll just say this and hit enter. Now what will happen? Now if I go to my master, git checkout master, okay, and if I do an ls, I can see the 7.txt file is no longer visible over here. Okay, and also if I do a cat on 5.txt, I can see this is the original file that the master should have, right? Now say I wanted to do something in my master branch. I'm done with that work. Now I want to get back to the work that I was doing in the feature branch. So what I'll do, I'll just do a git checkout feature 1. I'm back here. I'll do an ls. So right now the files will be not saved. So if I do a cat.5.txt, it will still be the test file. It will still show me the committed version of the file. I mean, if I want to restore the files that I was working on, all I have to do is git stash and then pop. This is the command to basically come back to your working state. So I'll hit enter, I'll clear the screen, and now if I do an ls, I have 7.txt, and if I do a cat on 5.txt, I can see this is the modified 5.txt. So I'm now again in my working state. If I do a git status, it will show me that my files have been staged, but then they have to be committed now. Okay, so now all I have to do is I'll say git add dot, and now I'll commit these changes, committing stashed changes, and now these changes have been committed to my feature branch, right? And now if I do an ls, if I do a git status, I can see that my branch is clean, and I can now easily just go back to my master. I don't have to stash anything anymore. And if I do an ls, it is still isolated. Reason being, everything is committed to the branch now, and there is no dangling files here and there which could confuse me with the files that I'm working in whichever branch I want. Okay, and this is why we use the git stash command, so that we don't have any confusions. The files don't get mixed up with the files of other branches and we don't get confused. Okay, so guys, this was the git stash command. Let's see what our next command is. So our next command is git revert. Okay, so this is an awesome feature of git. So let us come back to our terminal. Okay, so what I want to do is I'll just do a git log, and I have all these commits over here, right? So I want to go back to my first commit where I just had my 1.txt and 2.txt. Okay, I want to go back to this commit. So all I have to do is I'll just click, or I'll just copy this commit ID, right? I'll clear the screen. I'll do a git revert, and I'll just paste that commit ID, hit enter. Alright, so let's go back to our terminal. Alright, so now for doing this, let us first see where we exactly are. So we are on the feature 1 branch. Awesome. So now we want to revert the changes, right? So for reverting the changes, the first thing that you do is you see the log. So right now the logs is that the last commit that was made on which the head is right now is this commit where we added these stashed changes. So this caused a problem in my code, and I want to revert this. So I want to revert this commit. So whatever changes I'm doing in this commit will be undone, right? Now for doing that, all I have to do is I'll copy this commit ID, okay? And before just doing everything, let me just do an ls, and I can see that I have 7.txt which I added in my stash changes, right? So what I'll do is I'll just do a git revert and I'll paste the commit ID, right? So let me just take the commit ID from over here, done, paste it here, hit enter, and now you can see it will say your 7.txt will be deleted, and we modified 5.txt, remember, right? So my file which was modified 5.txt will also be reverted. So these will be the changes which will be committed once I revert from this commit. So I'm like, okay, so I want to do this. So I save it, and now if I do an ls, I can see that 7.txt has been removed, and my file also which I had modified has now been changed, and you can see the changes over here. So that 2 files have been changed, 1 insertions and 2 deletions, and this is it, right? This is what just happened. And if now I do a git log, you can basically just see that when I did git revert, it basically committed a new thing on my feature 1 branch. It committed a new file on my feature 1 branch with the message revert of committing stashed changes, right? And it says this revert commits 9A60 90. So basically it undid the changes which I did in this particular commit. Now if you still want to go back to this commit and see what changes have actually been done, what you can do is, if I want to go to this commit, all I have to do is just copy this commit ID, and now I'll type in git checkout and then the commit ID. Okay, so now I'm in the stashed commit, right? So now if I do an ls, I can see that 7.txt is present, right? Now what I want to see is what all things did we modify. I think we modified 5.txt, so let's do a cat on 5.txt. So I can see it says test file 12, and here is my 7.txt, which if I do a cat, it will say stash file check. Okay, now what I'll do is I'll say git checkout feature 1, so it will again return to the latest commit on my feature 1 branch. So I'm returned now. If I do an ls, I can see that 7.txt file is not there. If I do a cat on 5.txt, I can see that it has again returned to test file. So my changes which I did over here, that is I changed file in my commit of stash changes, that is I changed the file content to test file 12, and I created a file called 7.txt which I had stash file check. I had reverted this commit, and reverting means undoing the changes that you did in that commit, right? And it undid the changes that I did in that commit. So I no longer have 7.txt which I created, and I no longer have the contents of 5.txt to be the same as what was there in that particular commit. Okay, but remember guys, you still have that commit in your logs, and if you want, you can go to that commit and see what all things you want to fix, right? It's right here. But the head of the feature branch has now changed to a new commit which basically has undid changes or undone changes of what was there over here. Okay, sounds great. So this was all about git revert. All right, moving forward, the next command is git diff. Now git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits? What are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash. So we can do that. Let us see how we can do that. So I'll type in git diff, okay, git diff, and then I'll type in this commit ID, which is my head right now, and this commit ID which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, what content was changed and what content was added, right? So if I am comparing the the head with my previous commit. It says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm gonna do now is I'm gonna say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 12 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my feature1 branch. What I'm gonna do is I'm gonna change something in 4.txt file. Okay, so what I'll do is I'll do a git, I'll do a nano 4.txt and let me change the file content to test file for diff. I'll save it. Okay, sorry. So alright, so let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I'll do an ls. So now my 4.txt file has changed and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current current in my current directory? I have not committed or I have not staged the file for changes, right? My current directory is different from what is committed on the git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now. Awesome. So let us come back to our slides. So guys, this brings us an end to all the common git commands that you could be using in your day-to-day life while you're using git, right?
So guys, Docker was essentially a need which came out of the problem that we're going to discuss just now. So imagine yourself as a developer and probably you're just creating a website on, say, PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else. Right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code, right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution. But the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable. We needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not. Right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So, what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you've installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu, and what would it do? It would basically download the Ubuntu container. Then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay, so if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software, and on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries, and on these you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay. So this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Alright, so because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. Alright, so guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss. So we have understood why do we need Docker, and we have understood that what Docker is exactly. Right, now let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to go along with the video as we are performing the hands-on. Alright, so if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac, and once you have the Docker toolbox, it'll basically install everything. It will install Compose, it will install the Docker software, it will install the other components of Docker, so you don't have to worry about what component is what, but basically just go to this particular link, download the Docker software, and once you have the Docker software, just come back to this CLI and just pass the command Docker version, and if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm going to do is I'm going to install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm going to pass is sudo apt get update. Once I've done that, the next command that I'm going to pass is sudo apt get install docker.io. Alright, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. Right, so if your internet is fast, it will hardly take a minute to install Docker, and once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker --version, and as you can see that the Docker version is 18.061 CE, and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. Alright, so we have installed Docker on our system, guys, and I hope you guys are also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on, so that you get the maximum knowledge possible from this session. Alright, so the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. Alright, so basically this is how this is the whole lifecycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, that is again a lifecycle state, that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. Alright, so whenever you want to find out what version of Docker that you're working on, you can simply pass this command, Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal, because I feel that this color is a little dull, so that it becomes better for us to see. Just give me 1 second. Alright, much better. So when we pass this command, Docker version, you get the Docker version, the current Docker version that is installed on your system, along with the build name. And this is exactly what this command does. Alright. The second command that you can go ahead and try is Docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. Alright, so and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. Alright. Okay. So we'll type in docker pull and then the image name. So this is the image name, and we'll hit enter. Alright, so sorry about that, I forgot to use sudo. Alright, so sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image, we have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that, so sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on is, I think, around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run, and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is -it, which basically means make the terminal interactive. -d, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what -d does, right? So the command would be sudo docker -it. It means make the container interactive in the terminal so that I can also pass in commands. -d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container. Right, so this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run -it -d, and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps -a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are going to work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running, so if you do a docker ps, you can still see the container running in your docker ps space. Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet. Right, so if you have the stopped the container but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the lifecycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. Alright, moving forward, now what to do when you have to remove an image. Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right, so this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right, so guys, this is my Docker Hub account, and as you can see, I have some personal containers that I uploaded over here, and I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this. And always remember, guys, remember your user ID, because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step mean? So this step basically means that if I am on my system and say, I run my Docker command, say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps, this is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is, let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys, if you want to remove or delete a container which is running, you can pass in the command sudo docker rm -f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm -f and then the container ID, and this would remove your container. Alright, so I've deleted my container now. And if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container, and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. Alright, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. Alright, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is.
Let's check out our quiz question, guys. Which git command is used to view the commit history of a repository? The options are A. Git status, option B. Git log, option C. Git add, and option D. Git push. Hope you have written your answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
There now. Alright, I'll just exit the container. I'll do a sudo docker ps. I can see this is the container ID, so I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. Alright, so with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. Alright, and now I can run a container on the image test, and all I have to do is sudo docker run -it -d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present, and this is how you can create a custom container. So I, for demo purposes, just created a folder. You can also install softwares inside a container, like for example, you install Apache, you install MySQL, or any other kind of software that you want. then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than 5 or more than 3 containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command, that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right, so this is the shortcut that you can use while working with Docker. All right, so my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right, so my container is now running. The next thing that I have to do is install Apache server on this container. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. All right, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. The service Apache 2 start, hit enter, and if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now. And let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. All right, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right, so sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshr/apache. You should also notice that now my size of the container is 212 MB because I've installed the software the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, that is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80, right? So on containers port 80, Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container. This is the command to do that. -p space port number that you want to specify, colon the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. All right, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that Apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. All right, so let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server. It is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right, so for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container, and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys. And the first thing that you would have to do is you would have to log into your Docker Hub from your console. And to do that, you will have to type in the command sudo docker login. Pass in this command. You'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/Apache. This was the image name, right, that we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo, your image listed over here, just do a refresh and just go to the last page, and you can see this is the image that I just pushed to the repository, which is hshar/Apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command and that should be it. All right. So our next topic now is introduction to DockerFile. And let us go ahead and learn what is DockerFile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker Hub. This is what we have learned. Now, the next step is what is a DockerFile. So a little introduction about a Dockerfile. So you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this. When you're working on production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Dockerfile, right? So we're going to discuss what a Dockerfile is now. So let's go ahead and start with this topic now. So a Dockerfile is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Dockerfile. Now, a Dockerfile is very easy to write. And there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it will only be Dockerfile that you would be using rather than doing everything manually. Alright, so let's go ahead and see how we can create a DockerFile. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a DockerFile. Now, the first line of a DockerFile is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Dockerfile, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area uh, of your presentation will basically tell you the Dockerfile content. So this is exactly how the content of the Dockerfile should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt-get update and apt-get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Dockerfile, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt-get update and the second is apt-get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Dockerfile, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. Alright, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker run -it-d and then the image name. Now after the image name, you can also specify a command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Dockerfile, this command will be running when we are starting the container. Otherwise, whatever command we specify in the docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service Apache 2 start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd Apache CTL -d foreground would do nothing but run Apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the Dockerfile. Alright, the next command is entry point. Now entry point is exactly the same as CMD, that is it runs at the starting of the container, but the only difference is CMD will not run if you specify an argument in Docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. Alright, so CMD and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. CMD command will get skipped if you specify an argument after the Docker run command. Okay, so in our case we use the Apache CTL-D foreground with the entry point command. The next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case I specified a variable name which has the value DevOps Intellipaat. Alright, so these are some of the commands that you can use to create a Docker file. Now let us create this Docker file on our system as well. So what I'm gonna do is I'm gonna go to my putty software and I'm gonna specify nano and then DockerFile. So let me just create a directory first. So let me create a directory called DockerFile itself. So mkdir DockerFile. Let us go inside it. So cd DockerFile, and now whenever you are creating a Dockerfile, the name of the file always has to be Dockerfile itself, right? So I'll specify nano and then Dockerfile. We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y. Install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground. That is, run it. So Apache CTL -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as, say, new underscore DockerFile. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod hyphen a and g, and then docker, and then $user. Enter, and now all I have to do is just re-login into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Docker file. Okay. And now I want to build this Docker file. So docker build dot hyphen t new underscore Docker file. So you can see the Docker file is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore Docker file. So let us run this new underscore Docker file. Docker run hyphen it hyphen d. Also let us specify the port number. So let us open it at port 84, and then d new underscore Docker file, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being open on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec hyphen it container name, and then bash, and let me just clear the screen. Okay, and let me compare it with my Docker file. So the first thing that we did was apt-get update apt-get -y install apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the 1.html file has been added, and at the same time DockerFile was also added. So inside the directory we had these two files, right? 1.html and DockerFile. So both of these were added inside the container. Now to not have DockerFile inside your container, what you can do is, instead of dot, specify dot slash and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the Docker file. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Dockerfile. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Dockerfile in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a Docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a Docker push, and you should be able to use it, but I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. Alright, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore. Right, so that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you do, you delete the container and you launch it again, but with that what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. Alright, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Dockerfile directory, right? So what I can do is I can map this Dockerfile directory inside a container. Now to mount this particular Dockerfile folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /ubuntu/home/ubuntu/dockerfile. Now this is the location of my folder, and then what is the mount point of inside my container. So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter, and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now, these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session, let me just duplicate this session. So I'll just go inside the directory Docker file, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. All right, so this is called bind mount, but there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home/ubuntu/dockerfile is not going to exist, and that is where it is going to give you an error and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system, it will be a little different. For Windows, it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now, what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the Docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount, it is a little difficult to basically migrate the data. In volumes, it is very easy. You just take the volume up and then just put it on some other system and it will work. But in case of bind mounts, you will have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume. Right? So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay. So this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. Alright, so the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically, if I were to give you the syntax, This is the syntax for mounting a volume. So docker run -it -mount source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? And then -d and then the image name. Alright, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session, and what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new_dockerfile. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source say is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm going to do is I'm going to launch docker run -it, and then -mount source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new_dockerfile. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache and target would be say /app, and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container, var/www/html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file and then I specify that HTML body h1. This is the new HTML file. Close the header, close the body, close the HTML, come out. Okay. Now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp ./2.html and then /var/www/html and then the container ID. /var/www/html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore DockerFile container, docker rm-f, delete. Okay, so ideally, if I now launch a new docker run -it -mount source is equal to Apache, target is equal to /var/www/html. Okay, and -p also we specify that we want 81 port to be exposed, and -d and then the image name new underscore dockerfile. If I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore dockerfile. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address but on page 82, you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the Docker file, right? For volume, we have it attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome, guys, we have successfully understood what Docker volumes are. All right, so with that, guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first, let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean, right? So if that is the scenario, what will happen, that if I want to change code in notifications, I will have to pull the whole code base. I have to pull the whole code base. I will have to go to the notifications file and I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now. Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is, that you had to submit the whole code base, even if you had to change the minimist thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail if the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the modules, so all of these small things like notifications, mail, payments, passenger management, customers, these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is, the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application, because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. all of your modules that you're defining, all of the features that you have defined have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was. Now to solve this, we came up with the microservices architecture. Now what is a microservices architecture? Each and every module, that is a customer services function or the notifications function or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab. Right? So still communication has to be there between these two components. That is, the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program. They can communicate through probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab because booking of cab is nowhere related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down. Right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether, the downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now, you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs, wherein values are separated by commas. In JSON, you have a structure, right? Any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of barrier restriction, of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he, or which modules of the program should that particular program that he is developing communicate to, and that's all. That all he has to know, and of course the code of his own function as well, right? And of course, if he makes any changes and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay. I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservices which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course, you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we were to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker Run or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers, that is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now, a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end. And of course, you'll have to configure the DB password and everything inside the container as well, right? Now, one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now, this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3, and there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we're trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is DB underscore data, and this is the target of the inside the container where it should be mounted. That is var lib MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself, right? So inside this container, these are the environment values which will be configured. And then, so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download. So it's WordPress, and that to the latest version. The ports that we want to expose. So inside the container, the WordPress is available on port 80, and we are mapping it on the host with port 8000. Okay, and then the environment variables, we specify that the WordPress DB host is DB:3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it, and MySQL is always available on 3306 port number. So that we specify over here. Then we have the WordPress DB user. So we specified the DB user, that is the MySQL database user, as WordPress. So that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay. And what else? So this is it. And after that, we specify that the volume which has to be created is DB data. So this is for the whole YAML file. That there's a volume which is being created, which is called DB data. Now this is a YAML file which will create 2 containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not, right? So Docker, when you install, it does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker.
Let's check out our quiz question, guys. What is the key difference between Docker and a virtual machine? The options are A. Docker containers are lightweight, while virtual machines are heavier. Option B. Docker requires a hypervisor, while virtual machines do not. Option C. Docker provides hardware virtualization, while virtual machines provide OS level virtualization. Option D. Docker is primarily used for development, while virtual machines are used for production environments.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you that Docker Compose is not present. So Docker Compose -version. So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl the file. So the file has been curled now, and then we'll have to change the permissions for the file which has just been downloaded to be converted into an executable file, and that's it. And now if I run Docker Compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file so let me first create a directory. So it would be compose. Let's get inside compose, and now let's create a YAML file for WordPress.yaml. Okay, and if you basically, this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper, has to have a proper name. For example, if I pass the command Docker Compose for basically running your Docker Compose YAML file, the command is Docker Compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, dockercompose.yaml or dockercompose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be dockercompose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically, and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So db container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter. And here you go. So website is up and running, and if I go on continue, I'll just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well, password would be Intel123, and then your email, so it would let it be something random, intellipaat@intellipaat.com. And we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we gave, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. This is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a Docker PS, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Alright, so a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f, and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. All right, so this automation led to what we today known as container orchestration. Now there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker Swarm up and running. Now, how does a Docker Swarm basically work? So a Docker Swarm basically works like this. So a Docker Swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker Swarm on a single machine which can automatically repair containers, but what happens if the machine goes down? Right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them. Right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system. Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay, so while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is Docker Swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log in to this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. So let us connect to our worker, and let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do,
I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command and paste it over here, right? And also while we are doing that, I'll have to open the ports for these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter. And you can see it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will, in a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say -- force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker, and it will work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. Just specify that, hit enter, and then copy this command and pass it on the worker. Okay,
and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answers in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So, alright, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83, right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It will run 5 containers. It will verify if everything is running fine, and once everything is running great, it will exit. So now if you want to see what all services are running on your Swarm cluster, all you have to do is say docker swarm service ls, docker service ls, and it will show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address, either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a docker ps over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale Apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it'll basically scale down to only 2 replicas. Now if I do a service ps, docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it will remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. Alright, so this is how you can deploy an application on Docker Swarm. Alright,
Kubernetes. So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys, and this is exactly how our applications used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber, right? So you have features like location services, then you have customer service, notifications, mail, payments, and passenger management, right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now earlier all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server. Right now, this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base. Right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependencies. So say, for example, tomorrow my passenger management code fails. So that would lead to all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now, what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now my customer service is deployed separately. It's in a separate code base. My notifications have been deployed separately. It's in a separate code base, and all of them, they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message, which the other service will decrypt, and then it will try to read it, and any response which has generated is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services. It was only API calls that is using JSON, that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service, the customer service module might not require that much of power that is there in one server, right? But still my customer service module is occupying the whole server, and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue, you can also upscale it, but upscaling would also cause the same problem. That is, say, your server is able to handle 10 replicas of your customer service module, or say, let's your customer service module is being bombarded with requests, and it peaks your CPU to say around 85 to 90% of its usage. Now what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now, how did we solve it using Docker? Now, Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different, and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in messaging without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help, right? Now there are many container orchestration tools, and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today, right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of a feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized or your container has died because of some reason, then in that case it was manually updated that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. Is if there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those then all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing which whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system, right? It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. Right? So this is how Kubernetes actually works from the outside. There are a lot of ways to install Kubernetes, guys. We are going to discuss all those ways, right? And out of that, we're going to choose one way which is going to be preferable for all of us. So let's go ahead and start with the session, guys. So guys, now Kubernetes is basically, like I said, can be installed in a lot of ways. So you can install it by kubeadm, you can install it by Minikube, you can install it by KOps, or you can also use Kubernetes on GCP. So these are the most popular ways of installing Kubernetes. Of course, you'll also have the option of installing Kubernetes on Azure or other cloud platforms. On AWS, for example, there is also a dedicated service called EKS, which is Elastic Kubernetes Service. So we're not getting into it. Reason being, once you understand what Kubernetes is, it'll be very easy for you to basically understand those aspects of Kubernetes as well. So basically, first we should understand the core of Kubernetes, how we can start working with Kubernetes, and then we can explore the other options as well, which are available on other clouds. Okay. So the first method of installing Kubernetes is kubeadm. Now guys, kubeadm is a method using which we can install Kubernetes on any bare metal server. So it need not have to be on premise, it need not have to be on cloud, on AWS, on or Azure or on GCP. It can be any generic server, right? It could be a server on Google Cloud, it could be a server on Azure, it could be a server on premise. On all the systems, this installation will work, right? It could be a VM also, which is running inside your computer. On that also, this bare metal installation will work, right? So that is kubeadm. The second way is Minikube. Now guys, Minikube is basically a virtualized environment in which you don't have to create any slave nodes or you don't have to create any master node. You just download the Minikube software and it will virtualize an environment of Kubernetes for you, right? It's a great way for basically practicing Kubernetes, but it's not so great if you want to learn Kubernetes in depth as to how it works, what happens if you play around with different components. If you want to get into all those details, then Minikube is not that of a great choice. But yes, if you want to practice Kubernetes commands and everything, then Minikube is going to be helpful for you, because you can basically get started by having installed Minikube on your system, and you don't have to worry about any cloud or any virtual system as such. Okay. Then our next way of installing Kubernetes on AWS is KOps. So guys, KOps is basically shortcut for installing Kubernetes, but it's exclusively only for AWS, right? So if you want to install or want to get started with Kubernetes on AWS, you can use KOps. But the problem with KOps is that by default, it deploys the instances to be of T2.medium or T2.large. I'm not sure, but those instances, they do not fall under the free tier. All right. So because they do not fall under the free tier, it diminishes our perspective of how we want to learn tools, right? So all the tools that we have learned so far will absolutely work on the free tier of AWS. But if you are installing Kubernetes using the KOps way, then in that case, you will not be able to utilize the free tier of AWS. Okay. Then we have our next way of installing it on or having it set up is Kubernetes on GCP, right? Now, like I said, Kubernetes is a product of the Google Cloud or the Google company, right? And Google company also have their own Google Cloud platform. So on that platform, Kubernetes as a service is also available, right? And you don't have to get into all the details of how to install Kubernetes and everything. Everything is set up for you automatically. You can just get started by using or by throwing kubectl commands on your GCP server, and it'll work like a charm. But again, in that sense, it would not be that much beneficial for people who basically want to set up Kubernetes in their company, or they are probably a DevOps architect or a DevOps engineer whose sole responsibility is to manage the lifecycle, and he only has to deal with setting up all the tools in his company. So for that kind of a person, it'll be half knowledge, because he will only get to know how to use Kubernetes and he will know how to set up Kubernetes from scratch. Okay, so guys, these were all the ways or all the popular ways of setting up Kubernetes to get started with it. But like I said, we are going to use the kubeadm way, because I guess that will be the most beneficial for all the people, right? Whether it be a person who wants to understand how Kubernetes works from scratch, or a person who is a DevOps engineer and whose job would be to set up the DevOps lifecycle. And also, I guess it will be beneficial for people who only just want to work on Kubernetes, because even then, this knowledge is going to be helpful for you in the future. All right. So let's start with the installation, guys. So what I'll do is I'll jump onto my AWS management console. Let's start from way scratch. We don't even have our instances ready. So what we'll do is we'll click on launch instance, and let's select our OS to be Ubuntu. Okay, and then we'll choose the t2.micro instance. We'll click on configure instance details, and let's launch 2 instances over here. Let's just specify the number 2, and then just move on to security groups and specify a security group which you basically want your instance to have. So in my security group, I have defined all traffic enabled, so that there's no problem between the clusters to or the nodes to interact with each other. What you can do from a security perspective is that maybe both these instances could have different security groups. So what you can do is you can allow all traffic from that particular security group which is going to serve your slave, and all your slaves could basically be a part of that particular security group. Okay, that is a way that you can do. I'm just doing this way because our purpose is to learn DevOps and not get into the AWS details. Okay, so we'll click on review and launch now, and you can review all the details that you have configured over here. And once you've done that, let's click on launch, select the key pair that you have on your system, and click on launch instances, right? So this will basically deploy your instances on AWS, right? So your instances are now getting deployed. Let's tag them as kmaster for Kubernetes master and knode for Kubernetes node. Okay, so our instances are now getting started, guys. So knode is now in a running state, and if I refresh it, I can see both of these are now in the running state. So I'll choose kmaster, I'll choose the IP address, and let's try connecting to this instance first. So we'll click on yes, and this will basically bring us to the login page. So we'll log into this instance. Yes, we are in. Alright, so we are on our kmaster. Let's similarly log into our knode as well. So this is the IP address for knode. Let's open a new session on Putty for this, and let's color code it so that we can differentiate between the master and the slave. Okay, so my slave is orange in color, guys, so we'll remember that for our future references. Alright, awesome. So we have logged into both our master and on our slave. Alright, now although you will be having a document in your LMS, but the way I prefer to install Kubernetes is by going to the official documentation. So you just have to type in install kubeadm, and then you will have the official doc over here. Just click on that, and let me walk you through how you can use this particular documentation. Okay, so I've read all of this, so I know what is written everywhere. If you have a setup like mine, wherein you have an Ubuntu OS, right, and you want to install Kubernetes on it, you can straight away jump to installing the components. But before these components, you will have to install Docker, right? So let's install Docker, guys, on both our systems. So as we studied in the architecture that Docker is a common component among the master and the slave. So let's update the machine that we are going to work on first. Sudo apt-get update on master, and similarly on slave as well. Okay, so master is updated. Now let's install Docker on it. Sudo apt-get install docker.io. So Docker is getting installed on this system. Similarly, let's install Docker on our slave as well. So sudo apt-get install docker.io. Okay, so Docker is getting installed on the slave as well. On the master, it is installed. Now, once you've installed Docker, your job is done. Just follow the documentation now. So the first step would be to execute these commands. And these commands, as is mentioned, is for Ubuntu, right? So if you're using some other OS like CentOS, or if you're using a container for Linux, you can use these respective tabs. But I'm using it for Ubuntu. So hence I would use these commands. And all these commands have to be run as sudo, guys. So let's sudo up. And now let's copy these commands. So let's execute the first command. So it's being executed, and let's run it on the slave as well. So let's sudo up on the slave as well. And now let's copy this command and run it. All right. So I guess our master is ready. So let's copy the second command now. On a master, we'll paste this command. It's done. On a slave, we'll paste this command. Now let's move on to a third command, which is all these three files, or all these three lines will go along each other. So let's copy these lines, paste it on our master. It's done. Paste it on our slave. It's done. Awesome. Now let's update our machine. So we'll copy this command, run it on the master. So it's getting updated. Similarly, run it on my slave as well. Okay. Awesome. So on my master and on my slave, I have to run all these commands. So once we're done with the update, we'll start by installing Kubernetes. So let's install first it on our master. So it's getting installed over here. Similarly, let's install it on our slave as well. So it's getting installed over here as well. Okay. So once these components are installed, like it's installed on my master successfully, our next step would be to basically initialize Kubernetes. So Kubernetes is now successfully installed on your master and slave. But what do we do with the installation? We'll have to initialize it so that the slave and the master both are connected to each other and there are no issues. Now, in order to initialize the Kubernetes cluster, now you don't have to worry about the slave. The slave would only be once used just to connect to the master. Other than that, all the commands will now run on the master. Okay, this basically step would be only used if you're not using Docker and you're using some other container software. If you're using Docker, you don't have to worry about this, right? The next step is to basically create a cluster, that is initialize a cluster using kubeadm. So click on this, and then this would be the documentation for the second step. Now in our second step, guys, what we have to do is just jump on to initializing your master. Okay, so now we'll be using kubeadm init command to basically initialize our cluster. So I'll type in kubeadm init, and this is my master, guys. Kubeadm init. Next command would be API server advertise address. Copy this. So this basically requires your IP address for master. So you can give the private IP address as well. So we'll give the private IP address, which is this. Let's copy it, paste it here. Once you have the API server advertise address, the next step is to basically have the pod network CIDR. So I told you while we were discussing the architecture, guys, that on Kubernetes basically works on its own network. It has its own network on which it will work. So this network is called the pod network. Okay, and in this particular command that is using pod network CIDR, we basically define the range in which the IP addresses would be allotted for the Kubernetes network to function. So the range that we want to specify is 192.168.0.0. Why? Because the Kubernetes network, when it works, it needs a plugin for that network to get installed, right? Now there are a lot of plugins that you can choose from. So if you go back to our documentation, you can just scroll down and you will see that you have these plugins. So these plugins are basically your network plugins that you can use. So you have plugins like Calico, Canal, Kilium, Flannel, KubeRouter, Romana, ViveNet, Juniper, right? So what I prefer, my preference is Calico. And for Calico to work, the pod network CIDR should be in this range. 192.168.0.0/16, right? So if you want to install Calico as your network plugin, then you would be defining this particular range, and that is why I'm defining this range on my master as well right now. So 192.168.0.0/16. So once you've specified this, guys, just hit enter, and now you will get a warning. Warning would be error in the number of CPU. The number of available CPU is 1 less than the required 2. So on the Kubernetes master, by default, you need 2 cores for your master to run successfully. But since we are basically just practicing on Kubernetes, what we can do is we can ignore this check. We can ignore this pre-flight check. So we'll type in ignore and then pre-flight errors. Okay, and then you specify the name of the error. So the name of the error is num CPU. Okay, let's copy that. That's it. That's all you have to specify. Let's hit enter now. So as you can see, the process has now started. So basically your Kubernetes is now getting initialized on your master. And once it gets initialized, like you saw in Docker Swarm, the moment it gets initialized, it gives you a token command, which is basically used to connect any node on the network to connect to the master so that it becomes a part of the cluster. Okay. Similarly, you will get a command over here as well when this particular initialization is complete. So what we'll do is we'll just take that particular command and we'll paste it on a slave, which will basically just then connect to our cluster. So let's wait for this command to get completed and then we'll move forward. Alright guys, so our command is now complete. Okay, so this is the token that we have got. So this is the token that we will be basically passing on or executing on my slave so that Kubernetes runs or it connects to my master. Okay, now in order to run this command, just copy it. And now let's go to our slave. This is my slave, guys. Again, because it's a kubeadm command, we'll have to run it in root. Copy the command and let's hit enter. So it says this node has joined the cluster now, and we can see the nodes over here. But right now, for any command that you want to now use on Kubernetes, you will be using kubectl. So kubeadm's work was only till over here to basically set up the cluster for you. Now because the cluster is set up, now the only commands that we will be using is kubectl. Okay, now in order to use kubectl on the normal user, what you have to do is I exit it. Now I am on the dollar prompt. Now if I use kubectl right now, you will get an error. Let's see what that error is. Right, so it says that type the command kubectl get nodes. Correct, so let's type that command kubectl get nodes. If I hit enter now, you will get an error. The connection to the server localhost 8080 was refused. You always get this error when you have not configured your server properly. Now how can you configure your cluster properly? Now you got this kubeadm command, right? When basically your command was successfully executed. So along with that, there were several other instructions which came over here, which we did not read. So what are those instructions? Your Kubernetes master has initialized successfully. So start using your cluster. You need to run the following as a regular user. So you have to run these 3 commands as a regular user, and only then you will be able to work with your clusters. Let's copy these commands. This is the first command, this is the second command, and this is your third command. So let's copy these commands. Awesome. So now, since you have executed all these 3 commands, if you type in kubectl get nodes now, you will get all the 2 nodes which are there on your cluster. But as you can see over right now, the status of these nodes is not ready. The reason for that is that we have not installed the network plugin. So there is no network on my cluster right now. It's just the master and the slave which are connected to each other. Now for installing the network, what I'll do is just take these commands, kubectl apply, copy these and run it on your master. So this is done. Similarly, you'll run this command, run it over here. So it's done. Now your network plugin is getting initialized, and how you can check the status, you can just type in the command kubectl. So everything in Kubernetes which is basically running is running as a pod. For now, if you want to check the status, just type in kubectl get pods and then -- all namespaces. Okay, you type in this, hit enter, and now you can check the status over here. As you can see, all the pods are in the status running state, and all of them are running 2 out of 2, 2 out of 2, 1 out of 1, 1 out of 1. Every pod is running. That basically means your cluster is now ready. So if I type in kubectl get nodes now, if I hit enter, you can see that both my nodes, that is this node and this node, is in the ready state. Okay, so they are in the ready state. That means my cluster is now ready to accept commands to deploy applications on it, right? So we'll do that in a little while in our further sessions. For now, let's come back to our slides. All right, guys. So we have successfully installed Kubernetes. We have configured Kubernetes so that it's in its prime state to basically accept any kind of commands, any kind of deployments on it, right? And that was our purpose in this particular session. So thanks a lot for attending today's session, guys. In our next session, before starting to work with Kubernetes, we'll basically understand how the resources, or what are the resources that we are going to define on Kubernetes so as to our application gets up and ready.
Introduction to YAML. So what basically YAML is YAML is abbreviated as YAML ain't a markup language. Now that's a very funny name, whoever thought of it, that we'll name YAML and we'll put full form of Y as YAML itself. So YAML ain't a markup language is the full form of YAML. So it is data serialization language which is designed to be human friendly and works well with programming languages for everyday tasks. So it is a very simple looking file. The only thing you need to take care of while working with YAML file is the indentation, because it takes indentation very seriously. By indentation, I mean the spaces that you provide between the two constraints that you have, or the list form of the object file. We will be discussing that later in this section itself. So while creating that, just take care of the spaces. I mentioned it now just before starting it, because I make those mistakes all the time and it says that something is missing and it's not properly configuring and something like that. So please take care of the spaces when you are working with the YAML files. Now YAML includes a markup language with important construct to distinguish data-oriented language with document markup language. So the design goals and features of YAML are very straightforward. So YAML data is portable between programming languages. So you can take a YAML file from here to there. It is basically a subset of JSON file. It is mostly used for giving out configurations and information related to configurations and stuff like that. So it is a very portable kind of information that you can pass on between different programming languages. There is a very much ease of the implementation and usage. So it is very easy to type up. It's not that difficult. Only thing is that the spaces thing is very important to make sure of the spaces that you are using. For that, I would recommend you to use something like a Sublime Text or something where you can get the information in properly indented form where your data is going, instead of directly writing inside of, let's say if you use sudo nano and you try to write it inside of your bash terminal. Instead of that, I'd recommend you use Sublime and then copy paste it. I found it to be much better, but something suits some people, something suit the other people, right? Moving forward, it includes data consistent data model. So it has a data model which is very data consistent. So the way you write things is very consistent and you define things in a very particular way, and that's why it is very easily readable. So if you are a human, if I show you a YAML file right away, you'd be able to tell me what is going on inside it, probably, if you know a little bit here and there. So that is how we'll be learning to create a YAML file. Although when you're working with Kubernetes, there are a lot of different things that you need to learn to define a YAML file. We'll discuss that right now itself, and we'll give you a list of things as well, of the versions and stuff like that you need to keep in mind while creating a YAML file. So a different kind of data model works with different kinds of things. So let's say okay, we'll give you an example, then I'll show you. So YAML is a superset of a JSON file. As I mentioned earlier, this is very similar to the JSON file. So when you're making an API call, what you basically do is you have your configurations in your YAML file. So when it is making that API call, it will convert your YAML file to a JSON file, right? So there are two types of structure inside the YAML that you need to know. First is maps and second is the list. So there are two different kinds of structures that you need to know about, because that is how you define things. There are maps and lists inside of it, right? So when we map a key to a value in YAML, it is termed as map. So if you have a key value pair like let's say name, Intellipaat, course, Kubernetes. So this kind of thing is called mapping, where you have a key and you have a value. So you map your name as Intellipaat. So when I search for, let's say if I've created this YAML file and I have this as working, so if I just search for the name, it will give me, if I just, instead of writing name, instead of the names of the name section, if I just put Intellipaat, it will work for me. So because you have defined the name as Intellipaat. And then there is a list kind of things. Now list has an arguments inside of it. All of these arguments are started with a simple dash between them, and there is a space between the dash, which we have not mentioned here. So there is a kind of a gap between them while creating them. So as you can see an example here, the first is the argument. It asks you to sleep for 1000 seconds, and then you have the second argument, which is the message which you will be giving, which is Kubernetes test. So this is like a list format. So this is very different from the maps format, where you define something with the help of a key value pair. Inside of this, you can can have multiple arguments in a list kind of manner, where it is a sequence of objects one after the other that you want to define, right? So that is how you define the list kind of things. So this is a sample YAML file. As you can see, version services, but this is not very helpful. So I will show you a real life deployment file of YAML, which we'll be using in the next module, but I'll show you right away so that you understand how important the YAML files are. So we'll switch to Sublime for a second, and so you can see I have a deployment of an Nginx here. So Nginx is basically something similar to Apache servers or Tomcat if you have used. So it helps you host things on local host for exposure. So Nginx is that. As you can see, this is right here is key value pair, which is a map, right? I have defined a name, a key, and it has a value version 1. So while creating YAML files, you have to define the API version. Some will have apps v1, some will just have v1, some will have apps beta v1. I'll give you a list of things because not all of these support, like this has the kind deployment. Since this is a deployment, I'm defining this as a deployment. This is under this API version. So when I'm making the call, this API version has this defined inside of it. But not everything has everything inside of it, right? So if I were using, let's say, ingress, or I was creating a kind of a service or a kind of volume or a secret or whatever, this will change accordingly to that. We'll give you a list of things like that. So when you are creating these files, you can find most of them mostly online. You can just search for it. If you're looking for an Nginx deployment or something, you can find most of the YAML files online itself. But when you're creating by yourself, you need to know some rules, and it'll give you some errors also. I'll show you that also. If I just change it to v1 or something, it should give me some errors in that. So here I have metadata. Now inside of metadata, I have defined the name of the application as Nginx deployment. So if I have to call this deployment, I have to use this name, Nginx deployment. It has few labels inside of it. Now labels and specs and everything, spec we have discussed early on, right? So spec is something where you define the ideal condition of what you want your cluster to be in. So the ideal position of this deployment is to have replicas 3. So I should have 3 pods which are running this deployment, which is the Nginx deployment, right? So this Nginx should run in 3 points, which is the 3 replicas in it. So I have a selector which matches the labels of app name as the Nginx. So if I'm looking for the app name, so here the app is the Nginx, then there is the template metadata, and then there is again, I have defined another specification where I have defined the containers and what image it is pulling. So this is pulling the image of Nginx 1.15.4. So 1.15.4, it is pulling that image. You can define different images that you have created in your Docker. So let's say if I had an image named as Intellipaat rocks, so I can put that here, but with its version properly, then it will pull that image inside of that container, right? And the container port is just 80. So this is how we define a deployment or deployment YAML. So this is a YAML. I'll show you how it works also a little bit, but this is just don't take it for like that you don't understand what is going on. I'm just showing you how this YAML works. This is a deployment. We'll be covering deployments in the next future modules where we discuss it in further. This is just how you define a deployment. Now, why I was saying that you can use something like a Sublime text is because of this line. You see this line right here, it contains 2 spaces between it. So every time you have something lining on and two spaces you want, you can do it like that. So while defining a YAML file, you need to put 2 spaces between anything which is defined inside of something. So inside of metadata, I have 2 different things, right? All of these inside the metadata will be separated between 2 spaces. So if I put backspace, this is 1 and 2, right? 1, 2. 2 spaces should be there. Similarly here, this is also inside 2 spaces. Now this is 2 spaces inside of this. So while I'm defining anything inside of anything, it should be separated with 2 spaces. And when you're defining something with like a hyphen, like an argument, then it has to be 1 space. See, 1, that's it, right? So inside of an argument, between a dash and the whatever the argument that you are defining, there should be 1 space. And in the mapping, while you are mapping, you need 2 spaces in there, and you should keep a space between the key value pair. So here there will be a space. So that is something you need to take care of while defining this. I'll copy this entirely. I'll show you how it works just for the sake of it. So we'll go to our, so here I'll write nano, which is create to open a file. So nano, this is my deployment 1. So I'll name it as dp1.yaml, right? Inside of here, I want to paste the details of this particular YAML file. So I'll just copy it. So I'd recommend you to make something like a YAML file right here when you're typing. Just make sure of the spaces. It is very important. Now we'll go to our back here, paste it, and then we'll have a look at it. And then we'll just Control X and exit. So we'll look at it once again. So see, the spaces has been made properly. The image is defined, the container poster is defined, everything is working. So my YAML file is now created. Now you can just type kubectl create -f, now the name of the file, which is dep1.yaml. Now what I'm expecting here is, since the kind is deployment, it should say that this deployment was created. So let's hit enter and see what happens. And you can see the apps nginx.deployment was created. Now if I do kubectl get pods, now I have a deployment. I should get, since I mentioned 3 replicas here, I should get 3 pods, right? So if I do, see, 3 pods of the same deployment of the nginx deployment are running. Each of these are running. You can use kubectl describe pods to see in further details about the pods. Let's look at it. So you can see in-depth details here of all the pods, like this is the name, this is the namespace is default. So this inside of default, it has this particular IP and it is a replica set. It is controlled by the replica set and its IP, its true status and everything. You can get all the details inside if you want, using this kubectl get describe pods. So just we'll do it once again, kubectl get pods, just to show you now how this is working, right? So so here the API version was 1, kind of deployment here, and nginx deployment and whatever it is deployed here. Now you can see I've mentioned 3 replicas here. That is the reason why there are 3 different pods running of the same. All of these are the nginx deployments of the same time. All of these have the same image and same everything, just there are 3 different instances of it running. So if I have a load balancer, if I hit the pod named nginx, if I hit the deployment, which is the nginx deployment, I have 3 pods running, right? So when I hit it from the outside, I just hit I want the nginx to work. I want this app to be running. Now inside that app, we have 3 replicas. Now whatever the status of these is, the load will be distributed in a round robin fashion. And whoever is free, the data will be directed to that. That is the job that the replicas do. It helps you balance the load out. You have different replicas which are running constantly. Now what I want to show you all is, like I was saying you, that the API versions, if it is not perfectly defined, that will create a different problem. So what we'll do is we'll create another deployment file, and that should not work. So what we'll do is we'll just change this to v1, okay, and just copy it entirely, and we'll create another nano file. We'll call this, let's say, not working .yaml. This should not be working, right? We'll just paste it. We'll Control S to save it, Control X to exit. Then we'll create the same kubectl create -f, name of the file, which is not working .yaml. Now this should not work. See, unable to recognize the YAML file, not working YAML, no matches for the kind deployment in v1. So this is the very important part. Let me just this is the no matches for the kind deployment in version 1. So there is no API version named version v1 which has the kind deployment specified in it. So this is very important to match the APIs with the kind and whatever the data inside of it is. If these two are not matching, your deployment will not work, or whatever it is, your service or whatever you are trying to deploy will not work. You need to have proper API versions so that you have a proper kind of thing that is working. Every different thing is defined under certain things. So you have to get that spot on in order to work. That's why the original part was working, because it was apps/v1. If we just nano it, not working.yaml, if I just write again, it was apps/v1, right? Apps/v1 or app/v1. I think it was app. And then we try again to create this file. Okay, it was probably apps. We'll change it to apps. Or we can just check it out from the previous YAML file. Oh, the Nginx deployment already exists. Now, the name of the container. So while creating this deployment, the problem is I have already specified this name, Nginx deployment. So there cannot be two different deployments with the same name, right? So if I call a deployment, if I'm just like, if I type kubectl get deployment, and then I mention the deployment name, which is Nginx deployment, then I'm specifying a name of a deployment, and it shows me the details of that deployment, that it has 3 different pods which are running inside of it. All of them are up to date and all of them are available, and they have been created 5 minutes 34 seconds ago. The problem with creating not working YAML here is it has the same name, so you cannot have 2 different things being called from the same name, right? If I have 2 different services which have the same name, how will my system know which service to respond to? That is why your YAML file is very important. You have to define everything properly in here. So that's why we made that mistake. Now we'll go back to the nano not working.yaml. We'll just change it a little bit. Instead of Nginx deployment, we'll name it Nginx test, right? You can name it whatever you want here, and then we'll come back here. And now we'll try to deploy this YAML file again. Now you can see this is created. Now if I do kubectl get pods, I will have 6 different pods, right? Kubectl get pods. It will show me 6 different pods. 3 of the type test, because I have 3 replicas here, and 3 of the type Nginx deployment. Now what I can do here is I can change the number of replicas, and the replicas which we'll be creating will be different here. So we'll do that as well. We'll go to nano again. We have to create another one, right? So we'll copy this. We'll just copy this again. We'll create another deployment, and we'll call this just not.yaml because I don't want to type. Not.yaml I've opened. I've copied this here with Control C. I've gone back to my terminal. I've just pasted it in here. Control X, then I'll open it again for better readability. And I have to mention here apps/v1, and the name will be Nginx deployment replica test. So we'll call it Nginx rep, and inside of replicas I'll change the number of replicas to 2. So this should create another deployment which has 2 replicas, right? So it was called not.yaml, right? The importance of YAML files, so that when I am working in future on different YAML files, you create those YAML files with me. You type those out, even though I would be copy pasting just to save time, because if I type everything and go about it, it will take a lot of time for me to explain and a lot of time for you to watch. You can just see it and start typing so that you get better hands-on on it. Also, you can either just go and copy paste. It's your wish, totally up to you, but I'd recommend you type it out a couple of times, right? Okay, then now we can go back and move on to our...
Alright, so before starting the session, I would just like to tell you guys, if you guys have a cluster on Minikube, if you have a cluster on Google Cloud, AWS, anywhere if you have a cluster, all the commands that we're going to run right now are going to run the same, right? Most of you guys must be working on Minikube. What I'll be doing is I am basically working on an installation on AWS, right? So I'm not going to discuss how do we set up the Kubernetes cluster in this session. Probably I'll add a new session for that, where I'll discuss different ways you can set up a Kubernetes cluster. In this, I've already set up a cluster. So let me just quickly go to the terminal to start with our hands-on. Alright, so our terminal is here. Now over here, the cluster is up and running. Now the way you can see that the cluster is up and running is by checking the number of nodes that are joined on the cluster, right? So for that, if I type in kubectl, which is basically kube control. So the kubectl is the command with which you control the whole Kubernetes cluster. So the first thing that I want to see is the number of nodes which are running on my system, right? So the number of nodes running on my cluster are kubectl get nodes, and these are the two systems which are there in my cluster. This is basically my master. So all my applications will be deployed on this. That is my worker node, right? And both of them are in the ready state, right? Now you can also see what all pods are running on your system. To see all the pods which are running on your system, all you have to do is type in kubectl get pods, and then hyphen hyphen all namespaces. This will basically show you all the pods which are running throughout your cluster, right? And if you want to see where exactly your pod is running, so all you can do is just go again here and type in -o wide, right? So here are all the pods which are running on your cluster, and some of them are running on one node, some of them are running on the other node. Your master is basically 172.31.44.86. So all the 86 IP addresses that you see here are running.
Let's check out our quiz question, guys. What command is used to list all running Docker containers? The options are A. Docker list, option B. Docker show, option B. Docker ps, and option D. Docker display. Hope you have written the answers in the comment section. So now we will move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
On the master, so this pod is running on the master, and this pod is running on the worker, right? Then you have IP addresses like this, wherein you have 192.168.1.2. All these IP addresses are basically the IP addresses of the container. So like I told you guys, Kubernetes works off their own network, right? So if one container on or one pod of your cluster wants to interact with another pod, they can interact through these IP addresses. But these IP addresses are only valid inside the Kubernetes cluster, right? They are not valid outside. So if you type this IP address in your browser, you will not get anything. So let us try that. So if I go to my browser and I type in Control V, you'll not be able to see anything. Reason being that this is a private IP address, right? This is only visible to the cluster which is basically working over here, right? Now the first thing that we want to do is basically deploy pods. Now we have to create a deployment. Now in order to create a deployment, you have to write a YAML file. Now what is a YAML file? A YAML file is basically a file in which you specify all the specifications of your deployment. For example, I want a deployment which goes by the name of Nginx, right? The specification of this deployment would be that I want 3 replicas which should be running, right? And the containers should have the image Nginx 1.7.9 running on it, and the container should expose the port 80, right? Now this is the deployment that I want to run. Now say I want to change the number of replicas to say 5, right? So I'll specify 5 over here. I'll save and exit this file, that is deploy.yaml. And now in order to create a deployment, all I have to do is kubectl create deployment and then specify this file, which is deploy.yaml, hit enter, and now it should create a deployment for me. The reason it didn't create the deployment for me was this. Alright, so kubectl create and then you specify -f space and then deploy.yaml. Now this should correct the error. So let me first clear the screen. So clearing the scene, and now in order to create the deployment, there are 2 ways of doing it. Either you can specify create deployment and then the name of the deployment, that is Nginx say 1, and then the image of the deployment, which is Nginx :1.7.9. So if I do this, it will create a deployment called Nginx 1. So like you see, it has created, and now what you can do is you can basically see the pods which are running for your Nginx. So since you didn't specify any number of replicas, there's only one pod which is running for this particular resource, right? And it's nginx1. Now let us see how we can create it from a file, that is deploy.yaml. In order to create a deployment from a file, all you have to do is kubectl create and then -f and then specify your file name, which is deploy.yaml. Now if I hit enter, all you have to do is see kubectl get pods, and you can see that there are 4 replicas of nginx running over here, right? It's not 4, it's actually 5 replicas of nginx running over here, right? And now if I go to my deploy.yaml, I can actually see how much of replicas I've specified. So I specified 5 replicas, and hence I have 5 replicas of nginx running over here, right? So these are all pods, and like we discussed in the architecture, so let me quickly go to the architecture. So here is the deployment, and it has the number of pods specified inside it, right? And this is what exactly what we have done. We have created a deployment, we specified the number of replicas, and these are the pods being run for that deployment, right? And all you have to do for deleting all the pods, all you have to do is delete the deployment, and it will delete all the pods which are running inside it, right? For example, I created the nginx1 deployment, so all I have to do is kubectl delete deployment and then specify the name, which is nginx1, right? Hit enter, and now nginx1 has been deleted. So if I do a kubectl get pods, I can see that there is no nginx1 pod running right now. There's only nginx deployments pod which are running, right? So we have deployed a deployment which has number of pods which are running inside it. Now in order to access these pods, now what is running inside these pods? So if you want to see, like I said, where exactly your pods are running, all you have to do is kubectl get. So let me first clear the screen. So kubectl get pods -o wide if you want to see where your pods are exactly running, and your pods are all running on the node, right? So this is the IP address of your master, which is 172.31.44.86, and all your pods are running basically on the client, that is on the worker node, which have the address 172.31.38.140, right? Now you can check if these pods are running as containers on your worker by going over here. This is my worker, right? So if I specify, say, docker ps, I can see that these are all the containers which are running right now, and all these containers are basically the containers which are running inside this pod with the system containers which are running for Kubernetes, right? So my pods are now running on my worker. The next thing that I want to do is being able to access these pods. So if I go to these IP addresses, I'll be able to access these specific pods, right? But only inside the cluster. For example, if I type it in the browser, I'll not be able to see anything. Let's try that. So if I go to my browser and I type this IP address, obviously I can't see anything, right? But if I type the same IP address over here, I'd be able to get what is there inside the pod, which is basically my nginx file, right? So I am able to access the pods on the cluster. Now I want to access it outside. Now for that, what we discussed in our diagram was we need a service. We need a service in order for us to basically interact with the pods. Now let's create a service. Now for creating a service, all you have to do is type in kubectl create service and the type of the service. Now there are 3 or 4 types of services that you can deploy. Right now we have to deploy a service called nodeport. Okay, what all different type of services are there? We're going to discuss this in our coming sessions. Right now, let's just focus on creating a service which is of type nodeport, right? Once you specify the type nodeport, the next thing that you have to do is specify the name of the service. And remember guys, the name of the service should always be the same as that of your deployment, right? So for our case, our deployment's name was nginx. We'll specify that. And now let's go ahead and specify the ports where your service should basically point on, right? So the 80 port of your service should basically point on 80 port of your pods, because when you created the deployment, you specified that 80 port of the pod should be exposed, right? So you specify 80:, 80. Why 80? Because Nginx works on port 80, right? You specify this, you hit enter, and now your service has been created, right? So to see your service, all you have to do is kubectl get service, you enter, and now you can see that a service has been created, which is of the type node port and is available on this particular port. Okay, so node port basically means that a port will be opened on the master and on basically on the cluster, and using this port you can access your pods, right? So if I copy this port, and now basically what I want to do is go to my master's IP address, which is this, and then open a new tab. Now specify the port, which is 31827 31827. I specify this, and now all I have to do is hit enter. So the moment I hit enter, I can now see my Nginx image, which basically means my service is working correctly. It is basically pointing to my pods. My request is being load balanced among all the pods which are running. So there are basically 5 pods which are running. So my request is being load balanced among these 5 pods. Okay, so now let us check if it's actually the service which is load balancing it. So let us try deleting the service. So kubectl delete service, and then specify the service name, which is Nginx. Hit enter, and now if I go over here and try to enter, I will not be able to access it. So let me just copy this once more and open it in a new tab. So as you can see, now I'm not able to access my cluster, right? So for the first 2 minutes, it was basically accessing my website from the cache, right? What I did was I opened an incognito window, and when I entered the IP address now, it is not able to access the website, right? Similarly, if I do a refresh here, it is still able to access because it is accessing this from the cache of this system, right? That's why it is able to access. But in an incognito window, you can clearly see it is not able to access this service. Okay, now again, if I create a service, it will be able to access. So kubectl create service, which is Nginx, and the type of the service is node port, right? And I want this service to be available on port 80. So I specify that. Okay, so it has been created, and if I do a kubectl get service now, I can see that this is the port it is available on. I copy this port number, I paste it over here, and I'm able to access the Nginx service. So it is that simple, guys. Also, like I told you guys, that my port, this port is also available throughout the cluster, right? It's not just on the master. So if I copy the node's IP address, which is this, and come back here and basically just change the IP address to the node's IP address, you can still access the service, right? As you can see, you can still access the service. Reason being, this port is available throughout the cluster. Any IP address that is of the master or the node I specify with this port, I'll be able to access the Nginx. Puppet is nothing but a configuration management tool which is open source in nature, right? And it helps us in basically keeping configurations consistent with what we require and what is there on our production, on our test, and our developer environments. Right now, the awesome thing about Puppet is that it can basically be installed on various platforms like Microsoft Windows, various Linux platforms, etc. Right, so it is very versatile in terms of its working on different platforms, and also it basically does not use any programming language. It has its own declarative format in which you have to specify what basically, if you want to install any type of or any set of configuration on any node or any group of nodes, the way to declare that is not dependent on any programming language. So Puppet has its own declarative language using which you can describe what kind of configurations you want on your slave nodes. Okay, so this is what Puppet is all about. Now, there are some key features of Puppet which we are going to discuss next. So what makes Puppet so special? Why is Puppet so popular? So the first and foremost reason that companies adopt Puppet is because a lot of other companies have also adopted Puppet, and basically it is a tried and tested tool which helps every company in its configuration management needs, right? So Puppet has established itself in providing the configuration management needs, and therefore companies who are newly coming up and are trying to adopt configuration management, they prefer Puppet because a lot of other companies are also using it. The second point is that there is a lot of, Puppet being an open source tool, there's a very big community for Puppet which constantly keeps working on Puppet and keeps on adding features, keeps on resolving bugs, which makes the Puppet tool in itself very mature, right? Why mature? Because if there is a tool which is privately owned by a company, obviously the kind of work which will happen on that tool versus what is happening on Puppet, it's going to be slow. Reason being, there are a lot of people who are working on Puppet, there are a lot of people who are enthusiasts, right, who are not being paid, they're just doing it because they love working on, or they love the profession and they love working on this tool which is Puppet, right? And out of that love they create features, they resolve bugs. So the quality of features and the quality that this tool has to offer is more than what a private company can produce, right? So therefore this is a key feature of Puppet, that there's a large open source community for Puppet which basically keeps on adding features, keeps on resolving bugs, and keeps the Puppet software in its most optimal state, right? The third thing is documentation. So documentation is very important for anyone who is trying to learn this tool, and there is an extensive documentation available for Puppet on their official website, right? So if you don't understand Puppet, you don't have to take help from your colleague, you don't have to search for tutorials. Just go to the Puppet online website and they have an extensive documentation on literally anything that you want to do with the Puppet software, okay? And the fourth thing, which we have already discussed but is very crucial for its success, is platform support, right? So Puppet can be used on Unix based systems, it can be used on Mac OS, it can be used on Microsoft Windows, it can be used anywhere. And because of this versatility of it being installed anywhere, it is very popular among companies where the fleet of servers are on different platforms, right? Their web server could be on CentOS, their DB servers could be on Ubuntu, so on and so forth. You could have multiple environments or multiple platforms in your company which are basically serving different purposes, but Puppet as a software can be installed on all of them, and your configuration management need is solved because of that, right? So these were some of the key features of Puppet, why Puppet is so popular, right? So now enough of bragging about why Puppet is so great. In our next session, we're going to start with the core part of Puppet, right, which is the Puppet architecture. So before dwelling into how Puppet actually works, or getting our hands onto the Puppet software, we're going to look at how the Puppet architecture basically works, or how Puppet internally works, with this slide which talks about the master and the slave. So the core part of the architecture of Puppet is the master-slave architecture. So there is one master and there could be numerous slaves which are being served by the master, right? So what happens basically, because Puppet is a pull configuration type of configuration management tool, so everything is initialized by the slave, right? So the way Puppet works is, so first the slave basically sends its state to the master, right? So when the master slave architecture is set up and everything is set, if there is any change on the master or if there is no change on the master also, the slave of Puppet, it time and again sends its state information to the master, and what master does is it checks whether the state sent by the slave is what is required from the slave or not, right? So there is a state for that particular slave which is defined on the master, right? So it checks against the state defined on the master whether the state is same or not. If the state is not same, if there is a change in the state, what master does is it sends the change catalog to their slave and tells the slave, okay, so these are the softwares and these are the versions that you have to install on yourself, right? So the Puppet agent then installs all these tools on itself or on the Puppet slave. And once it installs everything, it sends back a report to the master saying that, everything has been installed. Please check whether your requirements are now being met with my state or my metadata, which I'm sending it to you, right? So in the third and final step, master checks whether all the state is matching with what the requirements have been specified in its manifests, right? So this is a 3-step working of how the Puppet master and slave interact when there is a change which is supposed to happen on the slave. Similarly, now because there's a lot of communication or there's a lot of back and forth which happens between the Puppet master and Puppet slave, the communication which happens between these nodes is encrypted, and it is encrypted using SSL certificates, right? So there's an SSL connection which is established between the Puppet master and the Puppet slave, and the way it works is something like this, right? Now for SSL connection, we need certificates, right? So the first thing which happens is, because Puppet being a pull configuration type of tool, the Puppet slave first requests for the master certificate from the Puppet master, right? And which in turn the Puppet master, it sends the certificate back to the Puppet slave. So this happens instantaneously. Any slave which asks the Puppet master about its certificate, the master sends its certificate to the slave. But this is not where the connection has been established. Now what happens is, the moment master sends its certificate to slave, master also requests for the slave certificate, right? It requests a slave node to give master the certificate, and the slave obliges for this request and sends the slave certificate to the master, right? But still at this point, the communication has not been established, although the certificates have been exchanged, right? Now for the master to authenticate the slave, there is a manual step of signing the certificate that the Puppet slave is sending to the master, right? And in this step, basically the administrator or the DevOps engineer will go to the Puppet master, and he shall sign the certificates of the nodes which basically he wants to attach to the Puppet master, right? Once the Puppet master signs the certificates of the slave, only then a secure connection is established, right? An encrypted connection is established, and then the exchange of data takes place. So this is how the SSL connection is basically set up between Puppet master and Puppet slave, and this will be more clear to you when we'll be setting up Puppet, which is basically our next session, where we'll be setting up a Puppet master and a Puppet slave on AWS, and we'll try to establish connection between them, and then I'll show you how you guys can basically sign certificates on Puppet master so that the connection becomes encrypted. So in this session, we're going to start with setting up Puppet master slave on the AWS management console. All right, so let's go ahead and start with this session. So I'll quickly jump on to my AWS management console. So guys, here is my AWS management console. The first thing that I'll do is I'll have to launch an instance, right? So I'll select the Ubuntu AMI, Ubuntu 18.04. I'll select this. I'll select the t2.micro, which falls under the free tier. I'll click on next. I'll select the number of instances as 2 because I want to create one node Puppet master server setup. So I'll mention the number of instances as 2. I'll click on next, add storage, and then I'll come to security group, right? So in the security group, what you have to do is you will have to have a security group which basically will allow TCP connection, all TCP connections from the IP address of your slave, right? Either you can do this, or what you can do is you can allow a TCP connection on the port 8140 from your this particular IP address, which is of the slave, if you want to be more specific, right? But for now, what I'm going to do is I'm going to open all TCP ports, and I'll say it can come from anywhere, and I'll click on review and launch. The moment you click on launch, you will be asked to specify the private key that you want to use. So I have one private key already there on my system, so I've specified that. Now basically your instances are getting launched. So let's label these instances as master, and the next one would become slave. Okay, so we've specified this. And now while they are launching, let's have a look at all the commands that we're going to use to basically install my Puppet master and slave. So guys, these are all the commands. So these commands will basically run on my master, and then these commands will run on my Puppet agent, right? And in the end, we are also going to verify if our master and agent connection is successful by basically creating a file from the master on the agent with this particular content. So don't worry about it. We'll come to this part and I'll explain you what this file basically means when we get to this part of having the file ready on our system. Okay, so for now, let's start with the master. Let's start installing master. So let's see if our instances are ready. So yes, they are in the running state. So let's connect to our master first. So this is the master IP address. I'll connect through putty, specify the private key. Now this will basically let me enter my master server. So let me just change the font settings so it becomes more clear for you. And let me choose a color for the master as well so that we don't get confused between the master and the slave. So this is my master server. All right, so while I connect to my slave, let me just update this machine. So while this machine is getting updated, what I can do is I can connect to my slave. So this is my slave, guys. Let's connect to it using putty. So this is my IP address. Let's specify the private key as well. And now we are connected to our slave as well. Awesome. Let's change the font setting for this. Let's make it a little bigger so that you guys can also see this. All right. So now we are on our slave machine. Let's update this machine as well. All right. So meanwhile, our master is now updated. Now let's go back to our notepad to see what we have to do next. So we have to install wget first. So wget is pre-installed on AWS. We don't have to do this. Next step is basically to download this particular file. Let's do that using wget on the master. So the file is downloaded, and now let's unzip the file using this command. So the file is unzipped. Now let's install Puppet master here. So we are installing Puppet master. Puppet master is now being installed. Once it's successfully installed, we can check the installation status by going to the policy. So Puppet master is nearly installed now. And now let's check the content of the policy. So yes, Puppet master has been successfully installed. And now what I can do is I can check the status of the Puppet master service. So this is the service status. So it is active and running. So that's awesome. So that's what we wanted. So our Puppet master is now installed on our system. Next thing is to basically fine tune some settings. So let's do that. So we'll edit this file, which basically are the defaults for our Puppet master for running. Right, here we are. So basically your Puppet master by default would use 1 GB of memory, but since our system is also 1 GB, what we are going to do, we are going to mention that the Puppet master can only use 512 MB of the memory. So Puppet master can work in a 512 MB memory as well if you are dealing with less number of nodes. So since this particular setup is for our demo purpose, so we can mention 512 MB for our Puppet master, which should be enough. So we'll save the file, and now the defaults are ready. And now for applying the defaults, we'll just restart the Puppet master over here. So Puppet master is now restarted, and now we'll open port 8140 through which basically Puppet communicates with the slave through the firewall of the OS as well. So that's done, and we're set. So Puppet master is successfully set. Now let's go to our slave and start setting up our slave as well. So on a slave, we have updated the machine. wget is pre-installed. We'll first download this particular file. So the file is downloaded. Let's unzip the file. The file has been unzipped. Now let's install Puppet. So earlier we installed Puppet master. Over here we're installing Puppet, which is nothing but Puppet agent, right? So once Puppet agent is installed, I have to manually start it, and we can do that using this command. But before writing this command, what we have to do is we have to go to each machine and change the host file, right? So in the host file, I have to mention the IP address of the master. So we'll have to do this for both the machines. So let's specify the IP address like this, and let's specify the master's IP address in the master as well, and in the slave as well too. So we'll do a sudo nano /etc/host, specify the IP address, write puppet in front of it, and save the file. Alright, so now we're ready to start the puppet agent. So let's do that. So puppet agent has now been started. Let's enable puppet as well, which basically means on restart also puppet will be started automatically. So this is done as well. Alright, so now some steps happened in the background which we were not able to see. What were those steps? So that was basically what we discussed. So the moment puppet slave starts, it basically sends a request for the master certificate. How does the puppet slave know where the master is? We just specify the IP address in the host file, right? So it knows where the puppet master is. So it sends the request to the master. The master in turn sends the master certificate, and at the same time it also requests for the slave certificate. So this when the master requests for the slave certificate, the puppet slave basically sends the slave certificate, and now we have to go to puppet master basically. So we are here, we'll say sudo puppet cert list, right? So this should basically list any certificates which have been sent to the master. So let's check if we have any. So as you can see, we have a request from the puppet slave on the master. So how do we know it's the puppet slave? You see this IP address 172.31.44.167, and if we compare it with our slave, it's 172.31.44.167, right? So that's the slave's certificate which has been sent to the master. So we'll have to sign it now. So for that, the command is sign. And if there are more than one certificate or more than 2 or 3 certificates and you want to sign them all you have to do is sudo puppet sign and then -- all. Specify this and your certificate is now signed, right? So my puppet master and puppet slave can now interact with each other. So our next step is to verify this. So what we are going to do is we're going to come back over here, and now basically we are going to create a manifest. Now, what is a manifest? A manifest basically specifies what all changes have to be made on the agent or on the slave, and these are the changes that we are going to do. So basically we are creating a file which exists in this particular directory, right? So the puppet master has to ensure that this file is present on this directory, and the permissions, the read write permissions of this file is this, which is the user should be able to read write and the other users of the OS should be able to read this particular file. Okay, and what should be the content of this file? The content should basically be it works on, and then the IP address of the slave. All right, so this IP address is going to change with every machine on which this file is going to exist. So this is going to be the content. So let's create this particular file. So for that, first I'll have to create a path on the master. So this is my master. Let's create a path. Path is created. Now let's edit the manifest file on the master. So this is the manifest file, and the content of the file should be this. Let's copy it, paste it over here, save the file, and once the file has been saved, all you have to do is restart Puppet Master. So I'll restart Puppet Master like this. So my Puppet Master has now been restarted, and all I have to do is go to the Puppet, and since Puppet is a full configuration tool, the slave has to request for the changes. So I'll say puppet sudo puppet agent -- test, right? So before I run this command, I want to show you guys that basically there is no file inside temp which starts with I. So I'll go inside temp, and if I do an ls over here, you can see there's no file called it works. So now what we're going to do, I'm going to say sudo puppet agent -- test. So this command will basically ask the master for the is there any changes required for this particular server. The master will send the changes to the agent. The agent will make those changes and send the report back to the master. So I'll hit enter now, and now you can see that there has been some things which have been done, and you can see a file has been created in /temp. Let's verify this. So let's do an ls now. So I can see a file has been created, it works. And if I do a cat on this file, I can see the contents of this file is it works on, and then the IP address of the slave, which is this, right? So congratulations guys, your Puppet master slave setup is now complete, right? So now you can use the Puppet master slave to basically do configuration management. So you just have to specify the configuration on the master, and then it will be applied on the slave. Or the code basics for Puppet, which will enable you to basically get started in Puppet and start your own configuration management projects. All right, so without wasting any time, let's go ahead and start with this session. All right, so the most basic or the unit of coding in Puppet is basically a resource. So what is a resource? A resource could be a file, it could be a command, it could be a package, it could be anything, right? So this is the basic thing that you define in a Puppet catalog, which basically has to be executed or placed on the agents, right? And the way to define a resource is like this. So basically first you define the resource type. So like I said, it could be a package, it could be a file, it could be anything, right? And then you define the resource name. Okay, for example, if it's a file, you'll specify the path over here. If it's a package, you'll specify the package name over here, and then you specify the attributes, whether it has to be installed, whether it has to be present there, whether it does not have to be present there, what is the permissions of the file. So all that can be declared in the attribute and the value, and then you close the brackets, which basically means that, you know, this particular resource has been finished, this particular resource has been defined. Now don't worry if you get scared, don't worry if you are basically getting scared with the syntax. So let me go ahead and show you an example which will clear things out more than what we are understanding over here. So guys, this is a sample syntax for a resource. So over here we have basically defined a package. So say you want to install Nginx on agent, all you have to do is define this resource. So what is Nginx? Nginx is basically a package. So the resource type goes package, the package name is Nginx. And what do we want with Nginx? We basically want to ensure that it is installed on the system on which we are targeting on, right? So this is how you define a resource in Puppet, and through this you can basically configure your agent's configurations using the resources. So basically whatever resources you mention gets installed on the agent. All right, moving forward now guys, when you combine a bunch of resources, now of course when you're dealing with an agent, it's not just one resource that you will install. You could be installing hundreds or thousands of resources together, right? So all these resources combined, they have to be one entity, otherwise you'll have to define each and every resource separately, probably in a separate file. So to solve that problem, what we do is we come up with something called as manifests. So what are manifests? Manifests are nothing but a combination, or they basically group resources together, and they are defined inside one file, and that file is called the manifest file. Okay, so the manifest file can have multiple resources inside them, and once a manifest file is basically applied on an agent or on a slave, all those resources are installed one by one. All right, with this guys, let's go ahead and start by creating our first manifest in Puppet, right? So what we're going to do is, let me jump onto my master. So guys, this is my master. Now the first thing that I want to do is I want to create a manifest, so that basically if I want to install say Apache on my agent, how would I do that? So what I can do is I will go inside cd/etc/puppet. Here you go. And now inside this directory you will have something called as code, right? So you'll have to go inside code, Then there will be something called as environment. We'll go inside environment. Let me just do an ls over here. Okay, so we have to create a folder called environment. We do not have a folder called environment by default. So what we can do is you can create a path. So I'll do a sudo mkdir -p and let me specify the path now. So I want the environment folder, and inside the environment folder I want a folder called production. Now inside production I would need a folder called manifests, and inside manifests I will have to create a file. Alright, so let's first create this path. So this path is now created. Let's go inside this path. So we'll go inside environments, inside production, and inside manifests. Okay, so now we will create a file called site.pp. So let's do that. So what I'll do is I'll type in nano site.pp. Okay, and I'll hit enter. So this has to be backed up by a sudo nano site.pp. Awesome. Now the first thing that I would do is I'll have to specify the node. So right now we are not getting into which node we have to specify here. So we'll just specify node is default. That means that any agent who is basically requesting the master for an update, these whatever we are going to write over here is going to be applied on that agent automatically. Okay, so what we first want to do is say we want to install Nginx. Okay, so I'll say package. So first I have to specify the resource type. This I specified, and then I'll specify the resource name. So this is the package name Nginx. I've specified that, followed by a colon. Then I specify the attribute. So the attribute is ensure, which should be equal to installed, right? Followed by a comma, and now I'll close the package. That's it. So this is one resource that we have defined inside a manifest. Now let us define one more resource. So what basically I want to do is I also want to create a file, and the file should exist in /tmp, and the file name should be say status.txt, right? So again it will be followed by a colon. Then I'll specify the attribute. Now the attribute for a file would be, the first thing that I would say is content. What should be inside that file? So inside that file there should be a text which says Nginx installed. Okay, followed by the mode, which would basically specify the permissions of this file. So say I want the permissions to be 0644 followed by a comma. Okay, so everything seems fine till over here. So what I'll do now, I'll do a control X, Y, enter. So my file site.pp is now saved inside the manifest folder, which exists inside the environment production. Okay, so this is done. Now what I'll do, I'll go to any of my slaves. So let's go to slave 1. This is my slave 1, guys. So what I'll do, I'll just type in puppet agent -test, right? And I'll specify it with a sudo. So let's hit enter. Okay, so we'll have to specify -test, and we'll hit enter. And now it says applied catalog in 0.01 seconds. All right, so let's check if we have the tmp file over here, which should have a status file. So the status file is not there. Okay, I think the name of the folder should be manifest. Let's check that. Alright, so I think, guys, I got the problem. The folder name has to be environments. Okay, so if you look over here, alright, so let's try this. So let's try to change this folder name. So for that I'll have to come out, again come out, and now let's just copy this folder, cp-r, let's call it sudo, change the environment folder to environments, and let's move it so that it gets renamed itself. So let's do a cp here. Okay, that's done. And now let's just remove environment. Done. So if I go inside environments now, let's just check if everything is there. So production is there, manifest is there, and site.pp is there. So let's try to do a test again. So it says there is an syntax error at the end of the site.pp file. Let's check what syntax error are we dealing with. So it's a good thing that we're getting a new error now. So I'll do a sudo nano on site.pp, and okay, so here's the problem, guys. We didn't close the bracket. So let's close it, save the file, come back over here again and do a puppet agent test. So now I think we are progressing. Okay, so the catalog has been applied, and now let's check if the software was indeed installed or not. So how we can check that? We can basically just go to our EC2 management console. We did this on slave 1 test, right? And let's just go over here and paste this IP address. So yes, Nginx has been installed on slave 2 automatically. Again, if we want to check, so what we can do is we also wanted a file, right? So what we'll do, we'll do a cat on /temp with the status. So yes, status.txt file also has been created, and if you do a cat on that, it says Nginx is installed. Awesome, guys. So we have successfully implemented one manifest on your slave, which has basically installed Nginx, and it has created a file on the agent itself as well, right? So congratulations, guys, on your first manifest. Let's see what is next in our slides. All right, so we've basically created a manifest. Let's go ahead and see the different things we can do with the manifest, right? So there are 3 components of manifest. Basically, we can call these components, which can be used inside manifest for greater functionality. The first component would be variables, right? So you can use variables inside a manifest file to basically store values and then pass them on to the body, or you can basically create variables inside any or at any place inside the manifest, and then that variable can be called inside any resource, right? So let's try and check this. So if you can see of the example over here, the example says that it creates a variable called $text and it saves the value hello world inside it, and then it creates a file, right? And the content, it says hello world over here, but basically what we're going to do is instead of this, we are just going to put $text. Let's see what happens. So if I go to my terminal, so this is my master. So let me just change the site.pp. So what I'll do, I'll create, so like the slide says, you can create the variable anywhere. So what I'm going to do is I'm going to create a variable called text, and let's say the text says Intellipaat DevOps course. Okay, let's say it says this, and the content would basically be changed, and the content would go something like this. It will be $text. Okay, let's try to save it, and let's go to our slave 1 and let's see if we can do something with it. So what I'm gonna do is I'm gonna try and do the test again. So sudo puppet agent -- test. Let's hit enter. All right, so something happened. Let's check. So cat /tmp, the file name would be same, status.txt. Let's see what it says now. So as you can see, the text has changed to Intellipaat DevOps course, and this basically value was taken from the variable. As you can clearly see that I defined the text inside the variable, and that variable was called over here, and this content was basically added to status.txt, and this is exactly what we wanted. Awesome. So you have seen how variables work, but now let's make it a little more interesting. So let's talk about loops, right? So what are loops? So whenever you want to run something iteratively without having the need to write the code again and again, that's basically the main use of loops, right? Now, how can you use loops in manifest is something like this. So say you want to install multiple packages inside your slave, right? Say I want to install Nginx and I want to install MySQL Server. So how can I do that? Now, in order to do that, what I'll do is in my variable, I'll basically create an array. So basically I've created an array which contains two values. One is Nginx and one is MySQL Server, right? And then inside the packages, what I've done, while I'm naming the package, I've basically called the variable $package, and then I've ensured that these packages are installed, right? So let's try this code out. So what I'm going to do is let me switch to my terminal, and this is my master, guys. So let us remove some code from over here, and this is what we want to deal with. So what I'm going to do is I'm going to create a variable called packages, and let's give the values inside packages. The first value that I want to give is, say, Nginx is installed on slave 1. Let's try to install Apache 2, right? And let's try to install MySQL Server. Okay, so I'm gonna show you guys that if you see right now inside my slave 1, if I check, do I have Apache 2 installed to service, Apache 2 status, you can see it says the Apache 2 service could not be found. So once we run this test, let's see what happens, right? So first I want Nginx to be removed. So what I can do is sudo apt get purge Nginx. So I'll just remove it manually from over here, and then this should remove Nginx. Yes, so Nginx has been removed. So I can just verify that by going over here and refreshing on the IP address. Let me just see if the service is also down. Service Nginx status. Service is running, so let's stop the service. So service Nginx stop. So we'll have to add a sudo. Yes, so Nginx service is now stopped. So if I refresh it, I can see that the website says the site can't be reached. Awesome, this is what we wanted. Now what we are going to do is I'm installing Apache 2 and I'm installing MySQL Server on my agent. So I have specified the site.pp on the master. And now let me go to my slave 1. So this is my slave 1, guys. And what I'm going to do now is I'm going to test. So sudo puppet agent -- test. I'll hit enter. And now it's basically applying the catalog. So my Apache, so first let's check if Apache is installed. So if I go to the browser and if I hit refresh, let's see what happens. Okay, so it still says it can't be reached. So let's check where the problem is. So if I do a service Apache 2 status, it says the Apache 2 service could not be found. That could basically mean that probably there's some problem in my site.pp. Okay, so here it is. Here is the problem. So I did not change the value of the packages over here. So I just have to specify packages, and I'll have to save the catalog, and that's it. If I come back here, if I again do a puppet agent test, let's see what happens now. All right, so Apache 2 has been installed, and as you can see in the browser, it automatically refreshed, and now you can see the Apache page. It is now installing MySQL Server. So let's wait for it to install MySQL Server as well. Okay, so MySQL Server is also created. Awesome. So Apache 2 service is now installed. So we can also check it on the browser, on the terminal. Service Apache 2 status, and you can see Apache is now running on this slave. Similarly, if I want to check service MySQL Server status, so MySQL D status, I'm not sure what the name of the service is. Service MySQL status. Yes. So MySQL service is also active and it's running. So we successfully installed two packages, two softwares on this machine using loops in manifests. All right. So let's come back to our slides. So we are done with variables. We're done with loops. Now let's go ahead and understand what are conditions. All right. So now let's discuss conditions. So conditions are basically statements which helps us to take a decision based on a particular output. For example, over here, we say we are basically making use of the keyword only if, right? So only if this command is successful, only then it will basically run this particular command, which is Apache 2 is installed, right? Otherwise it will not run this particular command. And what this command is basically doing, this command is basically putting this text which is Apache 2 is installed inside this particular text file, which is /tmp/status.txt. okay, so this command says only if this particular command goes true, it should execute this particular command, right? And what is this command doing? This is basically saying, is Apache 2 present or not? So if Apache 2 is present, it will return something on the command line, otherwise it will not. So only if command ensures that if this command goes successful, this will return a code which is 0, and only if the code returned 0 is seen by this command, only then it will run this particular command which is written over here, right? If this returns the value false or 1, in that case this command will not run. So let's try this out. So let me go to my master terminal. So let's clear the screen first. So sudo nano init and sudo nano site.pp. all right, so what I want to do is I want to execute a command. So let's do that. So let's remove everything first. Okay, so basically I want to define a resource called exec, which basically deals in passing commands to the agent. So I want to do exec, and I want to name this thing as, say, conditions, right? I want to name it something. Let us name it like this. So conditions. And what I want to do is I want to pass a command which basically says that /bin/echo. Say we are checking if Apache is present or not. So we'll say Apache 2 is installed. So we'll say this, and this has to go inside /tmp/status_apache.txt. this will go over there. So this command should run only if the command /bin/ the command would be /bin/which Apache 2, and only if this command is successful, it should run this particular command, right? So, and now we'll just close the resource, and that's it. Let's save the file, and now let's come to our slave, which is this. Let us try to run the test. So sudo puppet agent -test. This basically has now created a file. So let's see if the file has been created or not. cd/tmp/status underscore. So we don't have a file over here. So let's see status underscore. Okay, so let us go inside tmp first and then do an ls. So I can see status underscore apache file is present. So I'll just cat it status underscore apache.txt. So it says Apache 2 is installed. Reason being, over here do have Apache installed. But let us go to another slave which I have connected to my master. Let's see if we have Apache 2 over here. So service Apache 2 status. So Apache 2 is installed over here. Reason being, okay, so it has been a lot of time. So this basically, because Apache 2 manifest was present on the master, this slave also requested master for the manifest or for any change, and the master told this slave to install Apache 2 on itself. No worries. So what I'm gonna do is I'm gonna sudo apt-get and I'm gonna purge Apache 2. Okay, so this will uninstall Apache 2. And now if I do a sudo service Apache 2 status, so it says Apache service is not found. Now what I'll do a sudo puppet agent -test. So in this case there should be no file which should be created. Okay, so if I hit enter now, let's see what happens. So it says executed successfully. Now let's check what just happened. So I'll go inside /tmp. I'll do an ls over here. It has a file called status underscore apache. Let's check that. So status underscore apache. What we can do is, probably this could have been created earlier. Let us remove this file first. Status underscore Apache we have removed. We'll have to add a sudo here. So it's removed now, right?
Let's check out our quiz question, guys. How do you specify a Docker file other than the default Docker file during the build process? The options are A. Use file name option. Option B. Use source option. Option C. Use file option. And option D. Use DockerFile option. Hope you have written the answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Let me just check if this command actually works or not. So /bin/which Apache 2. So it is running service Apache 2 status. That's not there. So we'll have to remove this particular file. So we can do that. So sudo rm /user /sbin/apache 2. Either we can do this or okay, let's first do this and then we can probably try something else as well. So user sbin/apache 2. Okay, so now if I do /bin/which apache 2, yes, it's not returning anything now. So what I'll do is I'll just do an ls here. Okay, so my status file is not present, and now I'll do a sudo puppet agent -test. I'll hit enter. Alright, so the catalog has been applied. Now let's check inside tmp file. So cd tmp, we are inside, and now let's check by doing an ll, or let me do an ls. Okay, so we don't have the status underscore apache file over here. Now it can be present over here. All I have to do is change the content. So we just learned about only if, right? Now let's learn about unless. So what unless means is until and unless this file or this command is not sending me 1 or is not false or is not executing properly, till then do not run this command. The moment it does not or is not successful, run this command. Okay, so now what we will do is, because our Apache 2 is not present on slave 2, I can just change this to unless, right? And I can say Apache 2 is not installed. And now in this case, what will happen is if I go to my slave 2, I'll just do a puppet agent test again. And in this case, it should create a file inside the temp folder. So if I do an ls, it has the status underscore Apache file. Let's do a cat on that. And it says Apache 2 is not installed. So basically we just made use of unless. So again, just for revision, what we just saw, unless basically deals with a command which it is waiting to become false. The moment that command becomes false, it will run this command. It will run this particular command which has been specified. Whereas the opposite of this is only if. Only if waits for this command to be successful, and only if this command is successful, this command will run. Unless this command is successful, this command will not run. Okay, so you can remember it like this. So with this, guys, we end the topic of basic coding in Puppet with the first slide, which will basically tell us what Ansible is. So Ansible, like Puppet, is just another configuration management tool. And what is configuration management? As we have already learned, It's nothing but installing softwares on multiple systems. For example, if you have a fleet of 150 or 200 servers and you want to do a particular software install on all those servers, if you do that manually, that will take a lot of time, right? And for that, we needed something which could automate the installation of softwares on multiple systems. And the way forward was configuration management, right? And now what happens is any software that you want to install, you can do that on a single click of a button on all the servers which exist in your fleet using the master slave configuration, where on your master you would have the Ansible or Puppet master installed, and then on the slaves you just have to specify on which machine what to install, and everything will be done automatically, right? This basically solves two things. The first thing is that the softwares which were installed, they were taking a lot of time if it were done manually, and now with Ansible or Puppet in the picture, where everything is happening automatically, it does not take that much time. Second thing is there is no room for error because everything happens automatically, right? So if there was any error which could be committed while installing softwares, that is not the case now because everything is automated. So that is why, you know, configuration management as a concept became so popular, and that is why so many tools have been developed. And we have basically learned Puppet, and today we're going to learn Ansible, which yet again just solves the configuration management problem. Right now, some few facts about Ansible. So it was written by a person called Michael Dehan, right? And the name Ansible actually came from a fictional novel which was written by Ursula K. Le Guin in 1966, right? That's like 50 years before this novel was written. And there was a communication device in this novel, right? And the name of that configuration device was Ansible. So it is the name Ansible has been taken from there by Michael Dehan, right? And again, this software was acquired in the year 2015 by Red Hat. So now any updates or any features that are added to the software would basically be directed by the Red Hat company. But in its true nature, right now as well, Ansible software is open source and anybody can download it for free. Anybody can make changes to it because it is open source, right? So guys, as we discussed that Ansible playbook is the core part of what Ansible does in its day-to-day activity, right? So whatever you write inside the Ansible playbook is actually executed on all the servers which are basically connected to the Ansible server. All right. Now, how do you write the Ansible playbooks? You write it in the YAML language, which is YAML int markup language, right? And this is the full form for that. And as we move along, I'm going to show you guys how you can start writing an Ansible playbook, right? So guys, Ansible playbook, let's focus on the word playbook first. Like, what is a playbook? A playbook means a book of plays, right? So a playbook essentially should have a lot of plays. So guys, you have the first level in the tree of playbook comes a play, right? And you can have multiple plays inside a playbook. Now, what is a play? A play is a combination of tasks that you want to do on a particular host, right? So you define a play, and inside the play you define the tasks that has to be done, and each task has something called as module, it has something called as notify, it has something called as handler, and a lot of other things as well, right? We will discuss these things in detail when we'll be talking about Ansible roles. For now, let's just focus on the word playbook. So like I said, playbooks has a lot of plays and each play has a lot of tasks, right? Now let us see how we can define a play in a playbook. So guys, in a play, you can have 2 or 3 tasks or 4 tasks or 10 tasks or any number of tasks written, and these tasks are executed on a particular host using a particular condition, right? And that's why it's called a play. What has to be played on a host? This is one play that is being played, which is it is executing a command in host 1, and then it is also executing a script in host 1. This is just an example, although we will be doing this in this session, but let us take an example that these are the 2 tasks which have to be done on a particular host. So they can be combined inside one play and then they can be executed. Similarly, if I want to execute a script on host 2 and install nginx on host 2, this would become play 2. Okay, now how do you write, or how would this particular playbook look like on screen? This is how it will look like. Okay, now out of these, which are plays, what are plays, and what are tasks? Let's look at that one by one, right? So guys, this particular block of code is one play wherein you have defined the hosts, right? So whenever you define the host, you start with a new line wherein you are defining the host. That becomes the starting of your second play. Okay, now the next thing is inside a play you have tasks. So as you can see, you have tasks over here, and the first task that we have is execute command date. This is the descriptive name of the task, right? So this does not get executed. This could be any string that you want to give, right? Second thing is you'll have to pass the command. Now what command has to be executed on the terminal? That same exact command you have to mention here. Okay, then the second name is execute script on server, right? So what is the script that you want to run? Test underscore script dot sh. This is the script that I want to run. So in this I have two tasks. One is execute command date. The next task is execute script on server. Every task will start with a name and has to be followed by a hyphen. Okay, hyphen marks the beginning of a new task. You specify the name of that task, and then you specify how that task will be executed. All right, for example, in this case there should be a command which is being executed. In the next case there should be a script which has to be executed. The syntax will remain like this, right? Now whenever you're starting a new play, in that case also you have to begin with a hyphen. You specify the host name, that is this hosts colon and then host1. Then whether that particular command or whether that particular play has to use sudo, we mentioned that. So if you want to use sudo in these commands, all you have to do is type in sudo colon and then say yes. Okay, then you give the name of the play. So the name of the play, it could be anything. Like I said, it's just a string. You can pass in anything over here. And once you've specified all these info, you start with the tasks, right? So this is play 1, guys. Similarly, now if you have to write play 2, I'll have to begin with hosts again, which I've done over here. Now where I want to run this particular play, I want to run it on host 2. What is the name that I want to give this play? I am calling it play 2. Do I want the sudo to run? Yes, I want the sudo to run. Then what are the tasks that I'm executing in this play? I want to execute script on server. This is the name. It could be anything. And then I specify the script which has to run on that particular host. Then I want to install a particular package. So I'll say the name of the task is install nginx, and the task that I have to do is installation. So that's why apt is written over here. So when you're dealing with Ubuntu systems, you'll have to type in apt over here. If you're dealing with CentOS or Amazon Linux, the command over here would be yum. Okay, so apt colon and then the package name, which is nginx, that I want to install, and the state is latest. So over here you basically specify the version that you want to install. So I want to install the latest version. So this is how you write a play. Now let us summarize what we just discussed. So we missed out on this thing that we always start a YAML file with 3 hyphens, right? So any time when you are starting with a YAML file, specify these 3 hyphens and only then begin with your playbook. So I start with specifying these 3 hyphens. Next thing I do is that I have to create a play. So for creating a play, I'll have to start with a hyphen. And the next thing that I'll have to specify are hosts, right? And the name that you're specifying for the hosts over here has to exactly match with the /etc/ansible hosts file. So whatever IP address you have mapped to the host name over there, right? That host name only you will be using over here. You cannot use some other host name. Okay, once you have specified that, the next step was to specify the tasks. So each play is like a dictionary and has name, host, tasks, and the order doesn't matter, right? So you have the name, you have the hosts, you have the tasks. So it becomes a dictionary. So it has all these information, each play, and once you define that and execute that, then it executes according to what is asked inside that particular play. All right. So when you're writing a playbook, that becomes a list of dictionaries. So if this is one dictionary where you have hosts, name, and tasks, and this is some other dictionary where you have the separate version of host, name, and tasks, When you combine them together inside a playbook, it become a list of dictionary. Okay, so again, seeing what tasks are nothing but they are basically commands that we want or tasks, or I can say things that we want to do on the remote server from the Ansible master. Those are termed as tasks. Then the next step would be to basically creating a playbook. How can we create a playbook? So first, let me just move on to my Ansible master. So guys, this is my Ansible master. What I want to do is I'll create a directory called Ansible. Okay, so this is my directory. Now I'll go inside Ansible. This is my Ansible directory, guys. Now the first thing that I'll do is I'll create a playbook. Okay, so let's create a playbook called sudo nano play dot yaml. Okay, this is my playbook. Now I want to create a playbook wherein I will be installing the Apache software on my host 1, which I defined in my host file. Now how can I do that? The first step that you have to do in creating an Ansible playbook is define these 3 hyphens. Once you have done that, now you have to start with a play. How can you create a play? Start with a hyphen and specify the hosts. So I want to do this particular play on host 1. Okay, then do I want sudo? Yes, I want sudo. The name of this play, let's call it play 1. Okay, and now let's specify the tasks. Okay, now inside the task, guys, the first thing that you would do is you'll have to define a task. So let's name the task something. So let's call it install Apache. Okay, let's call it this. Then what I'm gonna do is I'm gonna give the package name apt, and let's say the so if you want to see the syntax for that, the syntax is actually available here. So apt, and then you specify the name of the package that you want to install. So the name would be Apache 2, and the state is going to be latest. Okay, this is all you have to do when you're creating a play. All right, let's start by this. Let's see if this is working or not. So my play is now ready, right? Let's check if I can ping my host 1. So Ansible -m ping host 1. So it says could not match supplied host pattern. Okay, so I think that's because the name is slave 1. Yes, so the name is slave 1. So let's change that in our YAML file as well. So sudo nano play dot YAML, and the host name is slave 1. Okay, now let's try to run this playbook. Now how can I run this playbook? Type in Ansible hyphen playbook space play dot YAML. Once you specify this playbook will start executing. Now before I execute this playbook, guys, let me quickly show you on my management console that if I go to slave 1 right now, and if I go to this IP address, nothing is visible over here, right? It says the site can't be reached. Okay, now let me come back to my master. I'll execute this playbook. So now it is installing Apache. It will take some time, guys, because software installations take some time. So you can expect around 15 to 20 seconds it will take to basically install or do this particular task. And once this task is done, what I can do is, so as you can see, it says task, the change has been successfully done, and OK is equal to 2, changed equal to 1, and nothing has been failed. Now if I want to do this, all I have to do is come back here, refresh it, and as you can see, the Apache software is now successfully installed on my slave 1. Awesome. So I have successfully done something on a remote system, right, which is this. So now what I'm going to do is, let me just uninstall Apache. Sudo apt get purge Apache 2. I'll just uninstall the package, and I'll tell you why I'm doing that. So my package is being uninstalled. Now if I do a refresh here, you can see I'll again not be able to reach to this particular server. Now what I want to do is I want to add one more host to my Ansible cluster. So let us do that. Let us launch an instance. It has to be an Ubuntu instance, and the processor is t2.micro. Security group, I'll select an existing one. Review and launch. I'll launch it with my key pair, and now it's ready. Okay, so my server is being launched. Let's call it Ansible 3.1. Okay, and now if I go to my running instances, I can see that a new instance is now being launched. Now what is the IP address of this instance? It's this. So let's copy this and launch a putty terminal. Let's select the color to be white so that we can differentiate it easily. Okay, let's click on open, and now let's log into our instance. Alright, so I've successfully logged in. Now how do you add a host? All you have to do is update the machine, sudo apt get update, and the next step would be to install Python, sudo apt get install Python. Once this is done, I'll just have to go back to my master. I'll have to make the keyless SSH possible, and for that I'll have to do an cd into the SSH directory, and then I'll have to do a cat on id_rsa. Okay, this is the code that I'll be copying on my slave 2. Okay, so this is my slave 2, guys. Now I'll be going inside the SSH directory, and I'll be going inside the authorized key file, and now let's add this entry over here, save the file, and now let's try to SSH from over here. SSH ubuntu @ this is the IP address that I'm going to connect on, and yes, I'm able to log into my slave. So to verify, this is the IP address 172.31.29.34, and if I check it over here, it's 172.31.29.34. Awesome. So let us remove this. So let us exit the SSH connection, and now I'll have to add this host in the Ansible host file. So in order to do that, I'll have to do a nano on /etc/ansible/hosts. Okay, and now let's just scroll down and add one more slave over here with this name, Ansible_SSH_host is equal to this IP address that is of the slave. I'll add this, I'll save the file, and now if I do a Ansible-m ping all, I should get 2 servers ready over here. Okay, awesome. Now why did I do this? Alright, so now let us go to inside Ansible, right, and let's try to edit our playbook. Let's try to add one more play inside this. So I'll add a play, and let's say I am doing it for slave 2. Okay, I want sudo to be there. I want the name of the play should be play 2. Okay, the tasks that I want to execute are as follows. So the first of all, the name of the task would be to install, let's say I'm installing Apache on this system, and I want to install Nginx on my slave 1. Okay, so let's change all the things accordingly. So I'm installing Nginx on my slave 1 now, and I'm installing Apache on my slave 2. Okay, so name is equal to Apache 2, state is equal to latest. Alright, seems cool. Now I will be executing this playbook, and let's see how it goes. So basically with one command, what we are doing is we're installing software on 2 different systems, right? And the software that we're installing are also different, right? So this is the IP address for my slave 2. So as you can see, if I'm going to the IP address, I can't reach anywhere. Similarly, if I'm going to this IP address, I can't reach anywhere. Okay, now let's come back to our master. Alright, now let me execute this command. So it is Ansible-playbook and then play.yaml. Okay, so let's execute this. So it is executing play 1. It is installing Nginx on my slave 1. Alright, okay, so it has been done. Now we are executing play 2, and I'm installing Apache. So as you can clearly see right now, if I show you the browser, my server 1 is already ready, and it says welcome to Nginx. Awesome. And my slave 2 is also done. So if I go here and if I refresh, I can see the Apache page. Alright, So I've configured two different servers from my master, right, at the click of one button, right? I just executed one playbook which configured two servers of mine, installed two different softwares on it based on the name that I specified. All right, so awesome guys. I think we have almost begin we are almost a beginner now with the playbooks. I'm sure you guys can also write your playbooks, but let's take it a notch up. Let's try to do something else as well. Now if you have to execute scripts on remote system, how can you do that? Okay, so in order to do that, all you have to do is you'll have to create a script first in the same directory where your playbook is present. So I have my playbook present in this directory, that is uh, Ansible, right? So in this, let me create a script. So let's say I create a script called hello.sh. And what I want to do in this particular script is I want to create a file. Let's call it let the content be hello world for that particular file, and I want to put it in /var/www/html. Okay, I want to put it over here. Let's see how it goes. So and the file name has to be one.html. So in this case, what is going to happen is that I'm going to execute this on slave 2 where my Apache is basically installed, and that should basically create a website automatically. And if I go to this particular IP address and I go to /1.html, if I hit enter, it should basically show me the web page over here. Let's see how we can do that. So I've created this script guys. So let's save the script, and now let's try to make it an executable file. So let me make it executable. So I'm just changing the permissions for this file, right? And this has to run in sudo. Alright, so my script is now ready. Now I'll go inside my playbook guys. So I'll go to sudo nano play.yaml, and I want to do this task on my Apache server, right? So I'm inside my Apache play, and I'm adding a new task now, which is adding website. Okay, and what I want to do is I want to run that script. So I'll type in script colon, and what is the name of the script? hello.sh. That's all I have to do. Now let's save this play, and now let's try to run this play. So I'll do a Ansible hyphen playbook, and I want to run this play. Okay, let's see how it goes. Nginx is installed. Okay, so on slave 1 everything was executed, everything is same. So it says okay equal to 2, changed equal to 0. On my slave 2 there's one file that got changed. Now let's try to do a refresh over here. Can you see? Automatically a website was created which is now called hello world. Now let me show you one more awesome thing over here. Now I'm not going to any of those servers, right? This is my slave 2. I'm not going over here. I'm still on my master. Now what I can do is I can just simply change the script file. So if I change the script file to be say I'll go inside the script file, I change the text to hello world 12. Okay, mind you, I'm not going to any other server. I'm just running the same command again. Right, again the commands will run. As you can see, it says on slave 2 there's one change, and if I refresh it now, can you see the website has changed automatically, right? And this has changed without me going onto this server. And this is the power of configuration management guys. Now imagine you have 100 servers and you have to change a file in all those 100 servers. How do you do that? It is impossible to do it manually. I'm saying it is impossible because time is of the essence when you're working in businesses, right? So you can do it using Ansible in this kind of way, right? Now let us come back to a slide guys. So if I'll come back to my slide, all right, so now we created our first playbook. In this particular example also, they're basically running a command and then they are running a script. So we did similar thing, right? But when you're executing a command, basically you cannot see the output. That's why I changed this particular demo, but you can also try this demo also. So the syntax is clearly visible over here. You can just write the syntax in a YAML file and then try to execute it and see how it works for you. You can also create a demo for your own self as well and see how things work out. All right, so we created the first playbook using this particular command, and we created this shell file or the script file like this, right? And then we change the permissions for that script file. Once everything was ready, we executed the Ansible playbook, and the script file was automatically taken up and shifted, or basically copied to the slave that I want to execute it on, and then my playbook was basically executed. All right. So guys, this is how you.
So you will have a problem statement that you have hired as a senior DevOps engineer in Adobe software. They want to implement DevOps lifecycle in their company. So you have asked to implement this lifecycle as fast as possible. Adobe software is a product-based company, and their product is available on this GitHub. So what exactly the specifications are there? You need to set up the Git workflow. That means you as a developer, your code is going to be developed on the development branch, and then you have to take a pull request. That request is going to be merged to the master, and then whatever the master code has, it is going to be built, and that is going to be pushed to the production environment. Okay, so this is your problem statement. Now for that, what you require, first of all, a Jenkins server. Okay, a Jenkins server where you can create your job. So what type of job you are going to create for this problem statement? What type of job we require? Freestyle job, Maven nice job, or what? So if I set up with a Maven job, I have to create total 3 jobs to create a pipeline. But I'm not going to use Mavenize job. I'm going to create the Jenkins pipeline job where I'm going to use whatever build tool you have. So let's see first of all what exactly the code is. Okay, I'm not aware of the code. Let me check what code they provide us. I've opened that link. Okay, it's just a simple index.html. That means you don't need to require any build tool. Okay, for Apache. Let's implement this. Then I will show you how Maven is going to work with your Jenkins pipeline. That is in another use case. What I'm going to show you from my side. Okay. So I have written some Jenkins file. Okay. So this is one Jenkins file. I'm just copying this Jenkins file for our work, and we will modify it according to our requirement. So first of all, you have to go into the new item, demo project 1. I'm going to build the pipeline job. Okay, this is my script. So let's modify it a little bit so that we can work on this. So I don't want this Maven right away because it is not a Mavenized job. I have to just clone this repository, or better to click here. Okay, after, so there is no building such thing. Okay, so we don't need any build stage. We need directly a deploy stage. But the problem is here, my Apache is not going to be run on this server master. Okay, let me show you. So this is my Jenkins master. This is one server. Okay, and this is my another server. Where is my Apache is running? Note down the IP address. Let's check whether my Apache is up or not. So my Apache is not running. So what I have to do that first, I have to set up my Apache properly so that my deployment can happen successfully. So what you need to do, we have to log in into that server, which is going to be your Jenkins slave. Check whether your Apache process is running or not. It's CentOS, so it should be HTTPD. Okay. So how to install Apache? Yum install httpd-y. Okay, so my Apache installed. Now I have to start the service. Okay, so my Apache is installed. Let's see. Yeah, so I'm able to get the HTML content whatever I have put over there. So it's confirmed my Apache is running. Now guys, you tell me, do I need to install Git on this server or not? Okay, so nothing is there right now in my Apache server. Just a testing page by default. This is a default page Apache provides you. Okay, so right now I'm not installing anything. Let's see what will happen. Before that, what you need to do that we have to set up the SSH keys so that you can make this server Apache server as a Jenkins slave. So how to do that? You have to see what are your keys available here. First of all, you need to create one user called Jenkins. Provide a password to that user. Sorry. But this Jenkins user is a normal user. It doesn't have any admin rights. But you need to provide the admin rights to this user so that it can do the admin work. Otherwise, your job will get failed. So how to do that? You have to go into the sudo file, and you have to make an entry that you are giving admin rights. That means whatever the command your Jenkins user is going to run, it will run with the root privilege. No password subroutine means it won't ask for any password. So this is my user has been created. Now you have to add public key of Jenkins master in the home directory of Jenkins user. Okay, where you need to copy, you have to create one file called authorize key and enter the content of this public key. Okay, let's see whether I'm able to do the passwordless SSH to the Apache server or not. Yes. Oh, sorry. It gives you permission denied. Why? I will tell you. Because the permission of this authorized key file is open for others. So you have to change those permission. Let's try again. This time I'm able to SSH to the slave machine successfully. Okay. So this is done. But still on the Jenkins server, you won't see any slave machine. Where you can check it out that whether you have that slave machine or not? You have to go into the manage Jenkins under manage node. Right now you can see there is no slave available for that, means Apache slave is available. So how to add that slave? Create new node, give any name, Apache slave permanent agent. Let's copy the IP address of this machine. Okay, root directory will be home Jenkins. You can give a label Apache slave host. You have to provide IP address. Credential, right now nothing is there. I'm going to put this credential because I have already configured. A known host verification, no, I don't want. Otherwise it will ask for that unnecessary. Okay, let's see whether my Jenkins slave will come up or not. I know might be it is going to fail. Let's see. Launch agent. Now it fails. Java is not there. That's why my client, my slave process is failed. Let's see Java is there or not. There is no Java. So you have to install Java first. Search open JDK show. And we have to install Java 1.8 because we are using Jenkins 2. So this is the prerequisite. Just you have to remember. It always requires Java 1.8. So don't install Java 1.6 or Java 1.7. Okay, my Java has been installed. Let's try to bring that slave again. Let's go launch. Again it is failing. Why? SSH host key are not being verified. This time SSH key is creating issue. Okay, I got why it is creating issue. Key exchange was not finished. Okay, let's try from here. But it was running successfully here. Okay, got it. I will tell you what was the issue. The problem is we are using here username and password, and we have to configure keys and what we did wrong. So let's configure keys first. SSH username with private key, Jenkins SSH keys. Username is Jenkins. Okay, enter directly what is my private key. We have to put the content of this file. Okay, and add. Let's try with this. I don't want any verification. Launch agent. Public key authentication failed. SSH Jenkins Apache 1. Here it is working. Okay, got it. ADC SSH. So some restrictions are there. Let's see whether those restrictions are up or not. 422 should listen from everywhere. Should be open. Public key authentication. Password authentication is also, it should work, but it was not working because all these options was disabled. And you will face these issues because these are the cloud machines, and every cloud machines will come up with these restrictions. So you have to remember all these settings, guys. Okay, still I am facing this issue. Fine. What we will do this time, I will go with this launch. Yeah, okay. So it is taking my username and password properly. So you can see what it is trying to do. It is trying to download or simply run this remoting.jar under this directory. So if you go here under Jenkins home directory, you will see that jar was there and it is executed. Now my slave is up and running successfully. You can see here. Now what we need to do? We have to tell the job that bro, you have to run on this machine. So how you can tell that job? You have to configure it, your Jenkins file or Jenkins script. So this is the node parameter and you have to provide that slave name. So it is going to run on that machine. It will download this website.get, okay, with this content. Okay, what we next we have to do? Let's see how it looks like. It's throwing error. Let's first check what error it is. So it is closing here, it is closing here, extra spaces. Okay. See, it fails, but it is running on Apache slave. Now, guys, you tell me why it is failed. It's giving you the proper, see the logs, understand the logs. You can understand why it is failed. So you have to make sure whatever the things you are writing in your Jenkins file, the prerequisites for those things should be it successfully run this time. Now let's try to deploy your index.html and images folder into the proper location. So I told you as it's going to be run with the Jenkins user, we have to use sudo. Everything needs to be copied under HTML folder. So this is my deployment step. Okay, let's try and run this time. What will happen? Let's see. Failed. Why? Images. So understand this is a folder. So folder never be run with cp command. So what you need to do, you have to write the proper command, what exactly that command should work with the folder. So we have to use -r recursive copy. Okay, this time it ran successfully. Okay, it copied everything. Let's see whether this time I will get my page or not. Hello world. Okay, if I type images, so this is one use case. This is a small Jenkins file. You have to write the multiple Jenkins file for multiple type of work, or it can be in another way. You have to write a generic Jenkins file which can handle any type of work. So that generic Jenkins file is going to be long sometimes. So you have to make yourself comfortable in writing the Jenkins script or Jenkins file. I can do the same thing. I can copy this stuff into the Jenkins file and call that Jenkins file. Okay. So this is one use case where I'm just downloading everything and just deploying. There is no compilation is happening. Let's see with the compilation using Maven. So I have one job. Let's go in CI/CD. If you want to do some R&D without making changes in your main script, just click on the job which is run successfully. You can go into the replay. You can see the script change as per your requirement and do whatever you want to do. You can easily do that stuff also. Okay. So it is running on my master machine. Let me check whether my Tomcat is installed or not on in this machine. Okay, so my Tomcat is up and running on this machine. So I am going to run everything on master only. So this master job is what it is trying to do. It is fetching some code. Okay, using Maven, I am building the package and I am deploying that package to this Tomcat server. Okay, let's see. Build now. So you can see Maven, it using Maven to compile my code, and it is deployed successfully in my destination folder. So if I go and run, let me check on which port my Tomcat is running. Okay, it's running on port 8081. So if I copy this same, I have to provide the context root. See, my application is up and running. I will go to the destination folder. I will remove everything from here. Okay, nothing is there. If I refresh this page, nothing is found. Okay, it throws an error that your context root called a hello world var 1.0.0 is not available. Let's try to rebuild this pipeline again. Okay, let's refresh this page. See, if I show you the contents, now it is getting copied right away. Who is doing this, all this thing? My pipeline. My pipeline will compile the code, clone the code, build the code, and deploy the code. So this is the way your work is going to be happen in any of the organization. You have to write this type of Jenkins file. So there are two type of Jenkins file are present in the market. One is declarative and another is scriptive. I hope guys you are aware of this type of Jenkins file. Okay, so this is the way you can write your own pipelines. Let me check if I have any example of big pipelines so that I can show you something. So you can see this is little bit big pipeline. So this is scriptive. Okay, so I will show you again. If you see, to understand whether it is a scriptive or declarative, if you try to use the if command on top of stage, then that is a scriptive. Just for understanding purpose. Another purpose is that that declarative always start from pipelines. Pipeline. This all these are scriptives. Okay, declarative are start from pipeline. Let me show you if I have that pipeline. No, all are scriptive. Okay, I can show you from here. Okay, so the best way is on the Jenkins doc. So if you go here, so you can see all the declarative pipelines start from pipeline. Okay, and all the scriptive will start from node like this. So this is the difference between declarative and scriptive, because there is no node parameter available in declarative. Node is just a parameter which you can find from the Groovy, and it can be written in scriptive very easily. If you try to use node in declarative, it will throw error, because here in declarative agent is there. Okay, so this is the way you can compare the things or figure it out whether you are working on a declarative or you are working on a scriptive, because still a lot of people I found that they don't know the difference between declarative and scriptive. Okay, so this is one of the declarative pipeline, scriptive pipeline I was returning. So it depends on, so these stages will call on the basis of environment variable. That means dynamically stages is going to be added if that variable is there. For example, if my pipeline params.checkout variable is yes, then only this stage is going to be included in my pipeline, otherwise it won't include. So this is a scriptive pipeline. Dynamically your stages is going to be added on the basis of your simple if condition in all the stages. Okay, so this pipeline is totally tested and it is running in production environment. Okay, so try to understand this pipeline. Okay, so you can just go and read this pipeline, try to modify if you're able to modify yourself. You can modify it, provide your server names, and it can work in your pipeline also. Okay, so this is regarding your project revision, or I can say project demonstration, how it looks like. Definitely you are not going to write us this type of small Jenkins file. You have to work on the big Jenkins file, because people wants that whatever things you are writing, it should be repeatable with any kind of requirement. That's why this pipeline has lot of tendency to handle any kind of requirement. I have to just pass the environment variables and it will do according to the requirement. So it will just run only for the building purpose. It will also run till from the end to end. That means it will build the code and deploy the code to the production also. So everything is going to be maintained from here. If it fails, it will send email notification to the required team in each stage. And if it is passed, successfully run, then it will send the required email to the required team. So this is the way this pipeline works. Okay. So this is about your project.
This is the capstone project configuration management tool. Basically help us to maintain the standard version on all the clusters. And someone is asking about the usage of Docker. Let's suppose take an example. You want to create a particular container where your code is deployed, or you want to create a particular mission. Then what it happens? Or you want to buy a server. It will take a lot of time, data, lot of money, and also you need to maintain the space as well. But here comes a container orchestration tool called Docker, which will provide us with the containers. In the containers, what we'll have is we'll have a minimal image size. We'll have the operating system with a minimal size. The size will be minimum. Let's suppose take an example. If you are getting a Ubuntu server, or if you want to launch a Ubuntu server, it will take a lot of GB, or even ISO file of Ubuntu will take 2 GB approximately. But usage of Docker, which is a container orchestration tool, which will reduce the data to 200 MB or 300 MB, where I can deploy my application in the form of container instead of launching a new server. This is how we'll use Docker inside it. And also we have microservices called Kubernetes, where we'll be testing the health checks as well. But as of now, we'll see into this particular topic. And finally, we'll monitor the website or the application that we are building with the help of a monitoring tool called NagOS. NagOS is a monitoring tool. And with the help of this all tools, we'll implement an architecture and we'll show you what exactly will happen if some developer modified a code, how the automation process is going on. Let me read out the problem statement for you guys. Then we'll start out the implementation. The very first thing they are saying is, let's suppose you are hired as a senior DevOps engineer in some XYZ company. They want to implement DevOps lifecycle in their company, as previously they might be using some other functionalities or some other methodologies. Right now, the company is looking to implement a DevOps lifecycle. You have been asked to implement a lifecycle as fast as possible. They are asking you to implement a lifecycle for this website or for this product which the company is using. And they also given with us the product in a GitHub link. GitHub is nothing but Git is a version controlling tool. GitHub is the UI, web user interface, where the remote people can access. You can access from your own laptop or your own computer instead of going into the on-premise data centers and all. Over here, the product is a product-based company. The product is available on this GitHub link. We'll see what exactly it consists of. Let me open this. We'll see what exactly it consists of. This is the GitHub UI, guys, where we have a file called images and index.html. Images will have an image file and index.html is the sample thing. And there is a query for me. How about agile methodology different from waterfall mode methodology? You can refer to the document or you can do that, but the basic difference over there is in the waterfall model, it is a continuous process. It will take a lot of time when compared to agile methodology. Agile methodology, whenever the process is not completed or anything, we can easily come back to it. CI/CD pipeline will be useful. CI/CD pipeline is helpful, guys, where exactly we'll integrate our deployment or our code, whatever we are using. You can go through the video, whatever we are trying to do today, or you can listen to what I am doing today. Then you can go ahead and practice it later. But as of now, your concentration should be what exactly going on inside the session and how exactly we can implement it. So I prefer you to listen it first, then you can go ahead and write it. Here is a sample website with me, which they given as a product, a sample HTML page. I want to deploy using this. I want to deploy this particular website on our browser, on our website, sorry, on our internet, and that particular website need to be followed with a DevOps lifecycle. We'll see that, but there are certain things that they are asking us to do. The specifications of life cycle. We'll see the specifications, what exactly. Over here, if you see, there are certain points mentioned after the GitHub link. Following are the specifications of the life cycle. What are the specifications for this life cycle? We'll see one by one and we'll try to implement it. There it is showing clearly mentioned that Git workflow has to be implemented. Basically, Git is a version controlling tool which will help us to control the versions of our code file. Let's suppose take an example. I have a code file index.html with me. I have given some other modification to a developer. He did the changes and then he want to push it to us, or he want to push it back to the GitHub. Then what happens? It will be the new version, right? When I upload a file, even though in the Google Drive, if you take an example of a Google Drive, simpler example, and the Google Drive, if you upload an image of same file name, then what happens? It will be become as a version part. The first one will be the older version. The second one will be the latest version. Likewise, if I was checking my code, if I was checking into my code, then the previous code file will be referred to as older version and the newest file should be of newer version. But I don't want to use every single time. If I suppose I want to comment some line and if I save it, it does not require to save all the data, because the reason for that is if I add some single line which I need to modify in the code while debugging, it will also become a new version. But I don't want to create these many versions. How to do it, how to implement it, that will do it. For practicing simultaneously, there are certain prerequisites of AWS console and all, and also there are certain things that will take, as obviously it is a time constraint for us as well. So first we need to implement Git workflow. There are three types of workflows in Git. One is centralized workflow, the second one is feature branching, and the third one is Git flow workflow. There are three different specifications for each. Centralized workflow will directly go ahead and merge with the master or directly merge it in the public server. And the second one, which is feature branching, will create separate branches for each and every developer. So that developer will be sending one by one, which we can merge it to the master. And finally, Git flow workflow, where we'll not directly merge it to the master back again. Master is a branch where we'll be using to deploy on a production environment, or simply we can say that is a mainstream where we'll save the data. So here they did not mention any specific workflow. I'll be using a feature branching workflow where I'll assume I have a developer. I'll give the developer to write certain file. Right now I'm going through the problem statement, guys. Once it is done, we'll start with the implementation. And then the second point which they are mentioning, the code should be triggered once commit is made to master branch or develop branch. What they are saying, there are two branches, master and develop. Right now you need to push, or it need to be triggered once it is committed, or once it is pushed to that branch, remote branch. GitHub will have the data. We can use a webhook option, which will basically help us to trigger. Git as the tool and GitHub is the user interface. There are a question, what is difference between Git and GitHub? Git is a tool and GitHub is the user interface where you can get the data, where you can save the data and manage its versions. Then you can also use option called webhook to build it automatically. Then there are certain conditions. We'll see how to achieve these conditions as well. Then finally, the third point comes in place. The code should be containerized with the help of a DockerFile. What exactly the DockerFile is? As I already said, Why we use a container? I have a question. Let me see. What is webhook? Webhook is nothing but a triggering point which is helpful to trigger when you made some changes. Let's suppose I'm a developer, I made some changes and I pushed it to GitHub. Then I want to specify that change. I want to tell someone to build it automatically. For that, I need to have some trigger point. So for that, webhook from Git is a trigger point which will start building a website. You need to containerize with the help of a Docker file. What exactly the Docker file is? Docker file is something which will help us to give the command or write in the form of a script file. When I execute that script file, automatically the required task needs to be done. But before everything, what I need to do is I need to have an integration tool. Then only I can go ahead and do the integration part. So let us go ahead and create two instances inside my AWS console. Instances are nothing but a missions, virtual missions. I'll be launching inside my AWS. When we need to use webhook, exactly how we know that is place to use webhook. I'll show you guys. I'll show you. Don't worry. When we need to use webhook, exactly how we know this is the place to use webhook. I'll show that. I think I have read the question twice. Let me click on launch instance. Instance are nothing but the virtual missions which we are using. Yes, I'm using Linux for the readability. EC2 is an instance name, the service name. Elastic Cloud Compute, where we'll be launching our VM. I'll be selecting a Ubuntu virtual machine or Ubuntu server. If I scroll down, I'll have a Ubuntu server, which I'll be selecting Ubuntu 18.04. And here there will be certain types once you select it. Once you select that particular AMI is nothing but Amazon Machine Image. There are certain types. So I'll be using T2.micro, which is free type. But for the purpose, right now I'll be using T2.small. You can use T2.micro, which is a free type one. You can use it. Then we'll go ahead and configure the. Over here, I want two instances to be launched. One is for my master. I'll show you where exactly. And there is a query. Can we use Docker Hub Ubuntu images too? Yes, we'll do that also. We'll use Docker Hub and the images which is given in the problem statement. For one AWS account, how many T2.micro can be used? You can use n number of instances, but your free tier limit is 750 hours.
Let's check our quiz question, guys. What are the different ways to make a REST API call in microservices? Option A, using REST template. Option B, using web client. Option C, using Spring Cloud OpenFan. And option D, all of the above. I hope you have written the answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Per month, you need to do it. If you have already created, don't worry, but next time when you are practicing, kindly terminate it or else it will charge you. You need to be aware of that charges. Then everything I'll be keeping default. I'll be going in a place where called as security groups. I'll be giving as the name as test project, and I'll add a rule anywhere, and also I'll add all traffic enabled so that I'll not get any issues with the ports or the firewalls. I'm opening up all the firewalls and I'm launching the instance. But before launching, there will be the key pair. Key pair is nothing but which we'll use as a entry point to our instance. version 18.04 Ubuntu machine I'm using. I'm selecting a key pair directly, which I have already inside my system, and I'm launching the instance. Once I created the instance, then we'll go ahead and see what else we need to do it. Right now, the instance is in the creation process and it is in the running state or in the pending state. So we'll name it, we'll tag it. Just I'm giving the name. I'm not doing anything. I'm naming it as test server. SSH key, yes, obviously key pair is nothing but the SSH key which we are using. And over here, hshar/web app, or this is the website. What I'll do is I'll click on fork. What exactly this will do is it will poke the website. It will get complete details of the website into your own website. Let's suppose this is my H1 Intelli as the name of my GitHub account. Why two instances? Someone is asking. One is for my master server. The second one is for my testing server. That is the reason I'm using two instances. But before that, I have done a fork over here. What exactly fork will do is it will copy the complete content from the website or the GitHub link which they have provided to your personal GitHub link. From there, you can go ahead and work on it. I have the data entered into my website, H1 Intelli, which is the name of my GitHub account, and where we'll be using this particular GitHub account to create or to use this data and enter it. But before going ahead, I'll start with the installation of Jenkins in my servers. We can clone it also, right? Yes, you can clone it, but whenever you want to push it, you need to have the credential. So instead of cloning, you can do a fork. If you clone it, no issues, you can go ahead and modify the changes. But instead of cloning, the better or the best practice to do it is by going forking that repository. If you are working on the repository, then you need to fork it. And over here, let me show you with the instances whether it's active or not. My master server is active and my test server is also active. Let me copy the IP address and I'll open a tool called SSH tool called Putty. What exactly this Putty will do is it will help us to enter my website. Over here, if you see the dialog box that is open for Putty, it will be open. Once the Putty is open, what we'll do is we'll go ahead and add our IP address which we copied just now. We'll be adding with the IP address, then followed by the key pair, whichever we have created. It should be in the PBK format. Over here under SSH drop down, you have an option called authorization on the right left hand side. Once you click on it, there will be an option called browse, which will help you to browse the key pair to your instance. I have already browsed it. I have saved the settings, so I'm opening it directly. I want to enter, click on open. It will ask for yes or no, which basically asking whether you want to continue or not. Then I'll be giving the username. The username will be Ubuntu. The username will be Ubuntu. When I get the instance will be of minimal image. So for getting updated, what I'll do is there is a command in Linux to update the machine, that is sudo apt get update. What exactly it will do is it will update my machine. It will make my machine update. Will we be using AWS and Putty and got Git in professional environment? Over there depends upon the company. We'll get different environments. Let's suppose your company adopted AWS as a cloud platform or a server provider, then you can get it. And Putty is also provided to you because if you need to work on it, then obviously you need to enter into that machine. That will be given to you. Once I entered and updated my machine, the very first thing that I need to do for installing Jenkins. Jenkins is a continuous integration tool, which I'll be installing it first. How to do that? First, I need to install Java. Like normal cases in Windows, we'll be downloading the package, extracting it and doing it. But over here in the Linux, there is a simple command sudo apt get install openjdk -8 -jdk. I'm installing Java 8 over here, and it will ask for yes or no. Once I click on enter, you need to type yes, basically Y, click on Y, then click on enter. Right now, Java is installed. Java is being installed. Once Java is installed, what we need to do is we need to go ahead and add the packages. There are certain packages which are required for the installation, which I already saved for a time constraint. I have saved this details over here on my notepad. On my notepad, I saved it. Let me show you. This is the key pair or the key that we need to add it. These are the three commands as a prerequisite. In this, we'll be using this particular keys over here once we install Java successfully. Over here, Java is being installed. Once it is installed, we'll get to a normal font. Let me clear the screen and let me paste it. Sorry. For pasting it, right click on it. It will show me okay. Whatever the notepad info I'll be sharing with you. Don't worry on that, guys. I'll be sharing with you only the three commands. The very first thing will add the key pair, add the key for which is required for Jenkins, and then the second command will be used to add the package, Jenkins package. Then finally, if I try to update it, it will throw me an error. Let me show you. Sudo apt get update. If I run this update command, there is an error showing GPG error. Basically, GPG error is happened because of the key pair. So we do not need to download Java. This will be like command. The command that we have used will install Java. Depend for the Maven dependencies, we need to download it, but most probably we'll use Eclipse. And using Eclipse, we'll go ahead and create a runnable jar file. For installing Java as a prerequisite for Jenkins, we need to do it. Over here, there is a key error that occurs. So what we'll do is we'll import that key as well. This is the key due to the recent updates with Jenkins. This key got updated. So we need to import that key as well. Once we import it successfully, if we run it, if we go ahead and update my mission again, what happens is it will successfully updated. Right now my mission got updated successfully. Then what I'll do, I'll go ahead and install Jenkins. And what this wget will do, it will get the package. Wget will get the package from the browser. Sudo apt get install Jenkins. This is the name of the package which will be installing Jenkins. It will ask for yes or no. Yes, it is similar. What I mean was this is similar to how it works in Maven. Yes, it is similar. There are slight bit of changes, but it is similar. Maven will write the dependencies over there. Here we'll directly give the image name so that we can go ahead and download. And we are installing Jenkins. Once we got installed with Jenkins, we'll start the Jenkins and then we'll see our web UI of Jenkins on the browser. The key that I have downloaded from online itself, that is a command pool.sks.keyserver.net, which is officially given by Jenkins. From there I got it. Then I'll run systemctl command. Systemctl is a command that will be helpful for us to go ahead and check the status and start Jenkins, enable or restart any other services. It will be helpful. Over here, sudo systemctl start Jenkins, and then we'll write enable Jenkins. Jenkins got enabled and executed successfully. For getting the key, I have run a command. Let me show you the command again. Over here, this is the command which is in the notepad, the third command inside the notepad which I am showing you. There I got the key. Using this command, I got the key which is added. Once I got the key, I can go ahead and update. Right now, my master server which I have launched is successfully installed with Jenkins. We'll see what other things we need to configure right now. Right now, I have copied this particular IP address, which is the public IP. I'll be opening a new tab, pasting it along with the port 8080, which is the default port for Jenkins. 8080 is the default port for Jenkins. When I execute it, what exactly it is showing is, it is loading some other page. It is loading a page. We'll see what exactly the page is. It is the landing page of our Jenkins, guys. Basically, I'm using my local mission or the mission that I launched from AWS. I'm using that particular mission, and from there, I'm launching a tool called Jenkins. where right now I have certain link for me over here, which basically means the initial admin password. Initial admin password because I have installed Jenkins. For that, it will have an initial admin password, which we'll be seeing right now. So let's go into my terminal back again. And in the terminal, sudo cat. Sudo is used to give the super user permission, just like a run as administrator in your Windows machine. And if I click on enter, sudo cat and the location that I copied from the browser, I'll get a code over here, A799, something like that. In your case, it might be a different number. But what exactly this is the admin password. It will differ from one machine to another. I have copied it right now and I'll be pasting it on the browser. Once I paste it, I'll click on continue. So that what happened, my Jenkins will be unlocked. Jenkins will be unlocked. And over here we'll have other further, which basically install suggested plugins or select plugins to install. What exactly these are? These are nothing but the plugins. Jenkins basically use certain plugins. That plugins will help us to have a web UI where I can go ahead and use it. Over here, these are the plugins that are suggested directly by the Jenkins. I'm installing the suggestions that is given by Jenkins to me. Then once I completed with that, it will open a new page. It will open a new page where exactly I need to configure my details. This is the page I need to configure my details. Let me give my name as admin and password admin@intellipaat.com. This is the name I am configuring. You can give your name and you can click on save and continue. Once you click on save and continue, it will be redirecting into a page. Over here, it is asking for the Jenkins URL. Currently, I have no names called intellipaat.com or google.com like that. There are no domain names for me. So I'm using the same URL and I'm clicking on finish. Save and finish. What happened? It is showing Jenkins setup is ready. So you can use it. Let me use the Jenkins. Clicking on start using Chrome that I open in my machine is not inside the virtual machine. It is directly outside. It is directly from the local machine. Private IP address will not display on the browser. Someone is asking that can I use private IP address? That will not display, but you are using a local VM, then you need to display run it as localhost at the rate inside the VM. Over here, before that, let me configure the credentials. Go to admin over here, click on configure, and if you scroll down, you'll get a password where you'll be giving your name. Jenkins default port is 8080. So the browser will be open on 8080 only. Once I modify the password, I'll click on save. Once I save it, it will go to the redirect page over here. If you did not configure and it is in this particular page, then you need to use the initial admin password. But I have already configured it. So I'm using my own credentials and username and I'm clicking on sign in. Right now, my Jenkins is saved or Jenkins is UI is created successfully. Over here, I need to attach a node because Jenkins needs a clustering part. Then only we can attach a node and using that node, I can send the data. So over here, I'll go to manage Jenkins as it is updated. So you need not to use any global security settings and all. We'll directly go to manage nodes where we'll be adding a new node, clicking on new node. There I'll give a name as test server. Previously we launched our machine called test server, but that need to be configured inside Jenkins. Then only we can go ahead and make some changes in the test server. Once I click on OK, it will be open this particular location where I need to define the remote directory. Remote directory is nothing but the starting page or the starting landing page where I want to have the log files and all. So for that, let me create /home/ubuntu/jenkins. This will be the name I'll be creating. /jenkins is a directory which I need to create. And launch method is launch agent by connecting it to master. Yes, I am using the same. And this WebSocket will allow you to have TCP bounds. What exactly this TCP bounds and all? Let's suppose you are launching two machines on AWS. it will be on different availability zone or different data center. You need not to be in the same availability zone. That can be possible. At that time, to allow the nodes, we need to use this WebSocket and save it. Once we save it, the node test server is created, but it is showing a cross symbol, which basically means it is not active. So for that, to making that active, we need to download two files which is present inside it. Once you click on test server, you'll have two files. One is launch, which is JNLP, and the other one is agent.jar. Let me keep this both files. Once it is downloaded, what we need to do is, I need to copy this file. I need to copy these files into my node machine to connect it to Jenkins cluster. I need to copy it to the node machine. Then only I can do that. How to copy it? Let me open a tool called FileZilla. It is a tool that is used to copy the data from our local machine to the node machine. Over here, my test server IP address is required. The public IP address, guys. What's the public IP address? I got it. I'll paste it on the host, and the username for that host is Ubuntu, and there is no password, but the port is 22. And right now I can click on Quick Connect. But the thing is, you need to add the key pair. My system has a key pair. So for adding the key pair, go to Edit, click on Settings, and it will open a pop-up where you have an option called SFTP. There you need to browse the key pair from Add Key option. I have already browsed my key pair. Already a key pair is present. So I am clicking on OK and clicking on Quick Connect. What exactly it will do is, it will connect my local machine and my node machine. I'll click on OK. Then we'll wait for some time. My node machine will be connected, and it will list the files. On the right hand side, if you see, there are certain files are listing. Those are nothing but the location of my host node machine. What I'll do right now, I'll copy that files which I have downloaded from the browser. I'll drag and drop inside my FileZilla. Let me do that. Let me drag and drop it. Then I'll do the same for agent2.jar. Let me drag and drop it, both the files. Once I drag and drop it, there is a file created, slaveagent.jnlp. I'll rename it. There is an additional number called 2 because I have downloaded some other files previously. So it is giving that name. I'll modify or rename that file over here itself. And then finally the other agent.jar. It will take a bit of time. Once it is completed, then we can go ahead and see it. Over here you can get the status. It is 60-70% or something like that. Once it is completed, we can go ahead and modify the name as agent.jar. Right now the file transfer is successful. So let me rename it as well. The reason for renaming this particular command, because there is a command that is given to us on the browser, which will help us to run the join this node. For that, we need to have Java installed on our machine, and the directory need to be created. Then we can go ahead and implement Git on the test server. But before that, let me go into the node machine first. These are the setting up of Jenkins. It may take some time, but the thing is that will be helpful for you. That will be helpful for you to go ahead and get the opportunity to connect to the cluster. Then the cluster will have both master and test server, which will be helpful for us to implement the DevOps lifecycle. So let me open Putty and paste the IP address of node. I'll modify the colors to some other color other than green, and I'll click on open. Yes. Over here, this is the green yellow color which represent my node machine. I'll open it and I'll do an ls command before updating the machine. If you can see it, there is a two files called agent.jar slaveagent.jnlp. We are setting up the integration on testing server only. Every time the code will be coming from the testing server only, where the developer will be present. So from that only we'll get the code. So for that we need to set up the architecture. SFTP is for secure file transfer. Over there, you need to give the key pair for security purpose. And how about SCP? SCP also copy command only that you can use in the terminal. Mostly SCP will be used by the Mac users. They can go ahead and use it. Over here, let me update the mission. If we did get update. And for connecting it to the master, Java is required in the node mission as well. I'll do that. Sudo apt get install -y open jdk -y. What exactly it will do? Instead of giving yes or no, I'll be using -y. What is SFTP? Which is nothing but secure file transfer protocol, where I'll be adding the key pair. It will help us to transfer our file securely to that machine. Once my Java got completed, I'll create a directory called Jenkins, because I have mentioned in my remote directory as Jenkins. So I need to create a directory called Jenkins. Then only I can go ahead and run the command, so that my node machine will be connected to Jenkins. And then we'll start our implementation with the Git and its command. Then finally we create jobs, and at last we'll build it. That is the end of the session. But before that, we'll start with the implementation once it is connected. It is taking a bit of time to install it, but no issues. We'll wait for that time. Yes, it got installed. It is loading. And then what I'll do is, why again you are installing Java? This is another mission, guys. Someone is asking why I'm installing Java over here. Java in the node mission is a prerequisite for Jenkins. Meanwhile, summarize what we have done so far. We have gone through the understanding of Jenkins. What exactly Jenkins consists? Sorry, we've gone through DevOps, why we use in the software lifecycle, and then we started with the installation of Jenkins. Right now we are configuring the node. I'll go into a deep overview, then we'll go and see what exactly we have done so far. So Jenkins would be installed on both master and test server. No, Jenkins will only be installed on master server. On the test server, only Java will be installed, nothing else. Do we need sudo apt get update after every install to get your machine updated? Then yes, you need to do that. And also, if you want to install certain package, then the very first command you need to use is, you need to update your machine, then only you can get the latest packages. Over here, I'll run this command mkdir, which basically means creating a directory. Right now, Jenkins is a directory which I have created. If I do an ls, there are three files: agent.jar, slaveagent.jnlp, and Jenkins. Let me go ahead and copy the command and run it with its sudo privileges. Sudo privileges are nothing but the super user permission or the root permission. That will be helpful for us. And once I executed this command, what happens is, I'll get an output as connected. I'll get the info as connected. What exactly the info as connected means? My node machine is successfully configured to my Jenkins cluster. Right now it is connected. If I click on any other command right now, it will be exited. So instead of that, I'll open a duplicate session. On the top of the terminal, I'll select duplicate session. I'll use Ubuntu as a name. And over here, we'll start with the implementation of Git. But for doing it, what exactly we require? We require to have Git installed on our system, or we need to clone our repository first. So for that, sudo, I'll be initiating Git. For installing or starting Git, we need to run this command, sudo git init. It will initialize the Git inside your AWS machine. Can we use local system in AWS and work on this instead of public? You can use local system, but you need to make sure the firewalls are open, or else you cannot go ahead and see this process. And DevOps will be inside the organization. It is not exposed directly. So you can use it with the public IP address. There is no issue with that. It cannot be exposed. Over here, I have initiated the Git, and also I have created a Git repository by forking. So let me copy that link or let me clone that link. First, I fork from a different repository. Once it is in my system, I'm going ahead and cloning it. How to do it? There is a command sudo git clone and the URL under quotations. Close the quotations and click on enter. What happens is if I do an ls, there will be a new file called website. A new file is created named website inside our machine. What exactly that is? That is having complete remote origin inside website, which I can use it. But yes, Git is on the testing server. I'm not doing anything on the master. I'm directly entering into Git. What I'll do is I'll enter into website. I'll do an ls. I have two files. I'll move that file or I'll add that to the staging area because I have the files. I'll just modify it. I'll show you what exactly the contents. Nano is the text editor. Once I opened it, these are the contents of it. Basically, it used to display. I already have AWS master and slave. Can I create another slave or use it for this? You can use that. No issues. You can use that. Over here, this is the HTML website page, sample page, where I'll be displaying a title as Intellipaat and a sample website. So over here, let me modify some change and so that I can go ahead and add. And let me save it. Once I saved it in the Git, what else you need to do is you need to add it to the staging area. Sudo git add dot will help you to add it to the staging area. Staging area is nothing but the place where Git can track your files. You have created inside your local system, but Git need to track of these files, right? For that reason, sudo git add dot basically add all the files to staging area. Then I'll commit it. Sudo git commit -m and I'll write a commit name as initial commit. And this is the way we'll define the commit. Sudo git commit space -m quotations the commit message. Right now it is committed successfully. It is committed successfully inside my machine. Do we need to create two EC2 instance when you are using free-tier to T2.micro? Yes, you need to do it. Free-tier one. Are you installing Git on new instance? Already initiated Git. Sudo git init will be the installation command. So I have done it. Right now it is committed successfully. Let us see what else I can do. I'll go to my website. I'll go to my website and I'll show you how to create or how to integrate it when I change some or when I push some changes to GitHub. So my DevOps or my Jenkins will get it. For that, I already mentioned to you there is an option called webhook. For getting the webhook, I need to copy the IP address. I need to copy the location of my Jenkins. Then I'll go to settings, setting inside it, inside my GitHub. I was in then I can go ahead and add a webhook. Meanwhile, I have some questions. Are you running Git on another instance? Yes, which is the testing server. I'm using Git. Master server, I'm not using Git. Are you installing Git on a new instance? I'm using in the testing server. So are we are using testing server, right? Yes, we are using testing server only. I'm not directly entering into my master. I'll keep master to create Jenkins cluster, but over here on the testing server only, that is what it is shown inside the life cycle as well. There will be a continuous integration part where we'll integrate our testing server and production server. Here we have an option called webhook, and I need to add a webhook over here. Webhook is a name that will help us to trigger it by giving the Jenkins URL. We can trigger it. Once we click on add webhook, it will be opening. There is a little bit of delay, but don't worry. It will ask for the password. It will ask for the confirmation password. So here master is production server and test server is testing server. What is webhook? I hope I have already explained to you. It is a triggering point. We are using two EC2 free tier instance. Do we need to have any link between two? No, you need not to have any link between them. This is my Jenkins URL. Production server is different from testing server. Yes, it is different. And master is just to maintain just not only Jenkins cluster. There are certain other clusters which we need to maintain for monitoring for other purposes. So master will remain for that particular testing. This there will be a new production server tomorrow which I'll be launching. And over here, what I'll do is I'll go ahead and use GitHub hyphen webhook. Once I define the name like this in this particular format, it will be recognized as a payload URL or the webhook trigger. And I'll create for the push event. If something is pushed to my GitHub, then what happened? The changes will be triggered. The webhook will be triggered in my Jenkins location. Over here, my Jenkins is added, and you can see there is a tick mark which basically says last delivery was successful. Just we have created one. I'll start with implementing a job inside Jenkins so that you get a clear idea how exactly it is running. Okay. So for that, let me go ahead into Jenkins again, and I'll create a new item which we call as job git push or master or slave. Git push will be done from the master itself, from the master branch, if we call it as. But right now that is done all done inside the testing server itself. Over here, I'll write a test job, just test GitHub webhook. I'm just testing the webhook whether it's working fine or not. Then we will go ahead and see what exactly need to configure over here. For that, I need to have the URL of my GitHub. Let me copy it as a project. Payload URL is the Jenkins URL. Over here, the master IP along with the port, you need to use that. And under general settings, we need to define our project. Then I'll restrict it to be run only on the test because I'm not using any other thing. So I'm typing test server. I'll be working on the test server itself. What is the use of a payload? That will help us to have an idea. Let's suppose you have a GitHub, but where exactly it need to trigger? You have some changes that will happen on the GitHub, but GitHub also required to know on which particular URL it need to be triggered, right? The same way we are giving our Jenkins URL so that what happen in the Jenkins it will be triggered. And under source code management, I'll define the project URL of my GitHub, which I have downloaded it, and then I'll click. If I go scroll down, if I just scroll down, there is an option called build triggers where I'll be selecting GitHub hook trigger, which helpful for me to trigger it. And under the build steps, I'll create a sample command, sample execute shell command. What exactly it will do is, it will run the command. It will run the commands for us. Let me write some command, echo hello. What exactly it will do? Once the job is successful, it will print hello. It will type hello. So save the job. Once job got saved, what happens? We'll see this kind of output where there are no builds. You can directly build from here. But what they have mentioned to us is it should be enabled or it should be triggered once there is some changes to GitHub. I have modified some changes over here. Let me restart it. Due to some internet connectivity, it gone. So let me restart it. cd/website. There is no slash. cd website. And over here, what I'll do is sudo git push origin master. Don't confuse over here, guys, what exactly the master is. Master is a branch over here. It is not the server. It will ask for the username, and then there is I need to enter my password. Let me enter my password. Once I enter the password, it is successfully pushing it. And let me go ahead and see over here what exactly it has happened. After some time, there will be a build present over here. If you can see it right now, there is a build starting in the build history. It is showing that there is a build going on, which basically means our job is triggered automatically on my Jenkins. Under Jenkins, my job got triggered, and we'll wait for the output. What exactly it comes? If we get a blue color ball or a blue color at the ending of this particular thing, which means success, our job is executed successfully. SCM tab, do we need to add or get credentials? If you are using a private GitHub, right now I'm using a public GitHub, so I need not to give any credentials. But if you are using a private, yes, you need to give the credentials. Right now, my job is executed over here inside my Jenkins. I did not build anything directly. When I push the changes, automatically my job built, and it is printed hello. It is printed hello, which basically means my job is executing automatically when there is a push command to GitHub. Right now, I'll go ahead and implement the branching over here. As I mentioned to you already, we need to use a developer branch or the Git workflow, which I need to mention. So for that, I'll create a separate branch. Sudo git branch is a command to create a branch. Let me run it. There are no branches currently, only a single branch. So let me run a develop branch. I'll make it develop. Basically nothing but developer branch. You can call it as developer branch. There are two branches. One is master and develop right now. But to enter into develop, there is a command sudo git checkout develop. And right now you are inside the develop. If I do an ls, you have all the files, images and index.html present to you. But what exactly over here is in the develop branch, you have all the commands or the copy of your master right now when you created a branch. If you modify something over here, once you merge it, then only the changes will apply. We'll do one thing. Instead of creating some random file, I'll go ahead and create DockerFile itself. And meanwhile, I have created when we created develop branch now. Yes, we created develop branch now. This file got copied. Yes, when we created develop branch, whatever the branch that we are creating from, it will create a copy at that particular commit ID that will be created into a new branch. How git push automatically recognize github.com? What if client using Azure Repo or Bitbucket, etc.? For Bitbucket or Azure Repo, then automatically we'll give the triggering with the different location, right? Over here, as I clone my repository directly, I have the remote repository URL directly into my system. So it went directly. But when you use different locations, like Bitbucket is also version controlling tool, at that particular point, what it will happen is it will get a new way of implementing where you will have a different triggers and also adding the repository differently. As I cloned it in the GitHub, it got the credentials for me. Right now, I'll create a file called DockerFile. I'm creating DockerFile inside my develop guys, where basically developer is creating a DockerFile. What I'll do is I'll add some content and I'll explain the content. Don't worry. Let me add the contents first. Then I'll show you what exactly the content consists of. You might be wondering.
Let's check our quiz question, guys. Which one of the following can be considered as the primary data store for Kubernetes? Option A, pod. Option B, etcd. Option C, node. And option D, none of the above. I hope you have written the answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
What exactly this is? You might be wondering what exactly this contents are. Let me show you the problem statement once again. They asked us to create a Docker file where will be containerizing the code. And the third point, if you can see it, the Docker file should be built every time. If there is a push to GitHub, use the following pre-built container for your application. There is a pre-built container and it's not different. How is trigger different from poll SCM? It's not different, but trigger, what exactly this webhook will do is, it will inform or it will act as an alarm to our Jenkins so that it will be triggered. We call it as trigger, but there are different other triggers as well in that Jenkins. Over here, pre-built container, we need to use it. What is a pre-built container? It's just HAR/web app. This is the Docker container which we pre-built for our application. In the organization which you are working on, they'll provide you with the containers if you are working on a Docker or DevOps. What exactly the container consists of? Container will consist of the operating system and also the software that is required for. Let's suppose over here in this particular location, we require a software. We require a software to display it on the browser, right? I cannot directly display it on the browser. So for that purpose, we are using this HSHAR/web app, where Ubuntu is the operating system, and inside it, Apache is installed in it. Apache is installed and running in it. How to add condition based on branch in Jenkins? Yeah, I'll show you how these files copy here. Basically, is asking that files are copied. When we created a branch, then automatically the files will be copied. And right now, there is a command code should reside in this particular location, whereas /var/ww/html. This is the location where we need to save our code file. That is what I have added inside my terminal. If you can see my terminal from HSHAR/web app, which is a container. How do we create Docker container? Are we going to show that? Docker container right now will not be creating. We'll be using the Docker file directly, and from there we'll build the Docker file. It will create a separate container for us. At that time, I'll show you what exactly the container is, but we are not creating it. And let me save this particular file. This is inside my develop branch. I have saved it, and what I'll do is sudo git add. I'll add all the files and sudo git commit -m. Commit message I'll be giving Docker file added. I'm giving a commit message as Docker file added in the branch. Can you quickly give overview up to now till now? Yes, we have created a Jenkins cluster where we have master and test server, and inside that we are starting with Git jobs and all. The very first thing what I did, I cloned the repository. Then I made a commit for that changes. Then we went ahead and work on the webhook. Webhook will be used to trigger it inside my Jenkins using the payload URL. And inside Jenkins, we created a job which helps us to go ahead and create a job or execute some sort of command once there is changes made or once there is a push command run inside our server. That's what we have done. And then finally we go into a developer branch where developer is creating a Docker file, and that Docker file is created in the developer branch. We'll see how exactly it will trigger from the developer branch. Previously it is from the master branch only. Right now I'll also add the Docker developer branch. Then we'll go ahead and see how exactly it will be triggered. Over here I have added it and I have committed it. Let me go ahead and open Jenkins, go to this job which I have created, and in the job let me configure. Let me go ahead and configure. Once I entered into job, let me go ahead and click on configure, and inside the configure, under source code management, there are certain place where it is showing branches to build. Over here I'll specify the branch. It is showing master. I'll specify my branch which is develop. Through this way, whenever there is modifications happen from the develop branch also, it will trigger. This is how you can define the branches. Someone is asking in the question previously how to define the branches separately. Over here, I'm giving in the same job, but later on, I'll be creating a separate job. But as of now, I'll be creating in the same job. And then once I save it, I'll go ahead inside the mission of my node mission and I'll push it. Sudo git push origin develop. Develop is the name of my branch. So I'm pushing it. This is the username. I'll give my password. And once I enter the password, it is successfully done. It is going ahead. And over here, I'll jump onto my Jenkins. In the Jenkins, you can see there is a job pending. What exactly this job pending will do is, whenever I push the changes, it automatically triggered. Or else you can directly build it from here. Over here, there is an option called build now. But instead of that, we are doing this over here. And can you please share sample Docker file for adding new changes and building new Docker image with the version control? See, Docker file is something which is used to have a Docker image already, and that image will be using to build it, where we'll having adding some other data. For creating a new image from the existing image, we'll use DockerFile. In the real-time project, is this the way branching of Git maintained? No, in the real time, what happens is each and every point you have a separate collaborator and also a contributor. What happens is developer is mentioned as a contributor, and then the people who is managing this particular thing, a DevOps person, is called as a collaborator. They'll check the code. They'll check the code whether it is suitable for it or not. Then they'll generate a pull request. From there, you'll get it. As we are doing in an organization, this way we'll merge the changes. Right now, the build is successful and it is showing a blue wall, which basically means the build is successful. Right now, a Docker file is created, but on the master, we don't have any Docker file. So what I'll do, I'll go to Jenkins back again and I'll go ahead and create a new job. I'll go ahead and create a new job, which will build my website, because I want to build my website using the Docker file that I have created by the developer. So for that, what I'll do is I'll give a website or a build website job. I'll type it as build-website. Is a job name which I'm giving, and it is a freestyle project. And I click on OK. Then we'll start with the implementing or creating a new job. In Jenkins, we'll run it by jobs. Using the jobs, we can go ahead and do that or require tasks. So what I did is I copied the URL just, and after copying the URL, I'm pasting it over here. Then again, I'm still restricting it in my master, inside my test server. But you might be wondering, I did not install any kind of Docker, right? How can I go ahead and run it? I'll do that once I created or once I configured this job. I'll go ahead and install Docker. Right now, I'm currently giving only master. And also, if I want to give, I'll also give it develop as well. Let me give it develop. Let's suppose my developer branch completed. Have you enabled auto refresh in Jenkins? No, with the recent update, it is already enabled. It will work on automatically. And I have enabled the trigger. Or else I can do one more thing. I can define the first job and then I can give the post build action. But instead of that, I'm creating a new one. I'll create a execute shell where I'll be running the Docker command. What all we did in this job we have just created, and inside that I have described my project URL or the GitHub repository. Then I restricted to test server. Once I restricted to test server, then I'll go ahead and add inside my source code management, where my Git repository is added, and also as well as the branches. Then finally I enable the trigger. That is what we have done so far. And right now I'll be going ahead and doing some command, some execute shell command. What exactly we'll do in the execute shell is we'll write some Docker command, sudo docker build /home. I'll giving the location /ubuntu /website /dot. Dot basically means it will pick the Docker file automatically. Then I'll give a tag to it -t test. This is the name I have given for the website, the image that we are building. And then we'll run it on certain port. Sudo docker run -it, which is nothing but an interactive mode. And then I'll give a port. I'll specify a port as 82. And then I'll close it with the destructive mode. And the name of the file is test. Basically what I'm doing is I'm running the Docker file. I'm building the Docker file and running on a port 82. We'll see whether we are able to build it up. But before building it, we need to install Docker on both machines. Why I'm saying here both? Because I'm in a cluster. I need to have access to both machines where Docker should be installed. Do we need to create a second slave to have more than one job? No, you need not to create any other slaves for other jobs. You can directly use it. Right now I'll be in the master. I'll go ahead and start installing Docker in it. A simple command sudo apt get install docker.io, which is a command useful for us to install Docker. As we are in the cluster, we need to install on both the machines. Sudo apt get install docker.io. You might be wondering why I'm doing this on the master, because on the cluster we have restricted it to test server, but that does not mean that master server is not at all using over here. We'll have both master and this server where we need to install Docker in it. Let me restart this as well. Don't worry about this restarting problem. That happens when there is an internet issue. How job restriction work and multiple branches given master and develop job definition. I have defined the jobs multiply over here, but for explaining you how to trigger on both the machines, I have done that. But tomorrow or when we are going further, I'll not give all these jobs. I'll create a separate job for each other branches. I'll not do the C. So for the starting understanding over here, we have done it. So I'll install apt get install docker.io. Docker.io will be installing. Once Docker got installed, what we'll do, we'll go ahead and push the changes from my branch, from my develop branch. We'll see whether it is building or not. If it is not building, then we'll go ahead and check what are the possible reasons for it. As I install Docker on machine, I'm not installing on separate branches. The packages will always be installed on the machine. Can we use docker.c? Yes, you can use docker.c as the community edition of Docker. There is no issues. You can use that as well. Over here, let me enter into my website, which is the directory. And over here, let me run the command ls. Right now, there is a DockerFile present. So I'll check the branch. Once I run the branch, right now I am inside the develop branch where I commit is made it. So what I'll do is sudo git push origin develop. I'm pushing develop and we'll see what exactly happens. Once I enter the password, everything is up to date. So let me check the status. On branch develop, everything is clean. Let me go ahead and check this particular branch. Let me refresh over here. On the GitHub, I'll going into GitHub. I'll be changing the GitHub URL over here. Over here, DockerFile is updated. So once DockerFile is updated, what I'll do, I'll enter into master sudo git checkout. Basically, this is the command That will be helpful for me to enter my master machine. Once I was in the master, if I do an ls, there is only 2 files. So I'll merge it. Sudo git merge develop. What exactly it happened? If I merged it, there is DockerFile that is present inside the develop branch directly merged into my system. So once I'll check the status, everything is clean. So let me add it once again. Sudo git commit -m docker file in master, and working directory is clean, no issues. Now I'll push this changes. Sudo git push origin master. This is my ID and this is my username password I have given. Right now it is entering into data. What I'll do, I'll wait for the build website to be executed and I'll see the output, what exactly the output will be. I'll wait over here. A new job is starting, which is of build number 1, because this is a new job. It is building for the first time. It is automatically building. If you can see it, it is automatically building. Over here, it is showing a success. Let me check whether it is a success. To the IP address, copy the test IP address on port 82. I'll paste it on a new tab with a port 82 and I'll see the output what exactly I'm getting. This is the website, guys. This is the website that we want to build it. See, developer has sent some data to us, which we merged it. Once we push it to the Docker, once we push it to the GitHub, then automatically the job which I initialized in the Jenkins got triggered, and this particular website is created with the help of the index.html, which we have used. Why port 82? I have given port as 82 while creating the job, so it is opened in the port 82. That is the reason. That's it. There is no specific reason. You can use any port. That is fine. Right now, this website is built successful. But what else I need to do? I need to go ahead and see the problem statement. There it clearly mentioned when there is a push, it should be built every time. Over here in the third point, the Docker file should be built every time. But what happens if I try to build it again? If I try to build it again, it will throw me an error. The reason for the error is already port 82, which I mentioned, is using already. I cannot use the same port because a container will be running inside the machine and I cannot use the same port. Let me show you the container docker ps. Once you run this command docker ps, a container is running with this particular container ID on port 82. If you can see the ports over here, it is showing port 82 mapped to 80. On this particular port, a container is running so that my website is opening. But I cannot go ahead and build every time if I don't remove this container ID or I don't remove the previous container ID. I cannot use it because port 82 is the only port that will be present, right? If you use different port, then it is a different scenario. But every time you cannot go ahead and do the changes of the port, right? You'll be directly using, or you'll be directly building it. So for that, there is an option for us. What the option will be is basically we'll remove the container before building it. How to do that? On the Jenkins under build website, if I try to build now again, if I click on build now from here in this location, what happens is the build will be started, but it will throw us an error. The red ball clearly mentions as an error. The reason for that build is basically it is showing that error response from daemon connectivity issue already allocated. The port is already allocated. So I cannot build on the same port. So for that reason, what I'll do is I'll remove the previous container whenever I'm going ahead to build this particular project. So I'll go to configure section and under configure, I'll modify the execute shell command. I'll add one more command which basically remove the containers before starting its build. How to do that? To remove it, sudo Docker rm -f, and I'm writing the location. I need to give the container ID, right? For that, I'll be writing sudo docker ps -a and -q. This is the command, guys. What exactly this command will do is, it will remove the previous container and it will be used for building the new container. Let me save this job. So Docker container is a lightweight image where website will be hosted every time we push something into the master. Yes. After pushing in develop branch, why it did not build? We did not push it from the develop branch. For that develop branch, we already tested for the first time with the first job. And second time when we are doing, nothing is pushed to GitHub, so it is not triggered. Can there be more than one Git job in a slave? Yes, you can have n number of jobs. After pushing in develop branch, why it did not build? Again, the same answer. Basically, that push is saying everything is up to date. It does not push or modify any changes into the GitHub, so that does not work. Why can't we use Docker Compose then? Bring down the container using Docker Compose down, and then bring it up using Docker Compose up -. You can use it, but for that you need to have a container or image that is built, right? Over here we are building our image and copying the files into the image using a Docker file. So that is the reason we are not using Docker Compose. Instead of that, we are creating, or we are adding this command to remove it. And right now, instead of going back, what I'll do, I'll build it right now over here. I'll build it over here. The output will be successful. Why? The reason for it is, I already given removed the containers earlier before starting it. I have removed the container. Docker rm removes my container, and then new container is built on the same port, and it is displaying on it. So that what happens, if there is any modifications happens in the file, it will be done, but there won't be any change in the port number. Where we have a product, a basic sample website, static website, that we want to keep in a DevOps process or the methodology. We want to implement a DevOps methodology using its tools. The very first thing is a version controlling. Whenever you start something or developing inside the code, you'll start with the version controlling of its versions, which we will be executing with the help of an open source tool, which is widely used, that is Git. And then we have used a concept called webhook, which will trigger our changes from different branches on Jenkins job. Whenever there is some changes, the code is automatically triggering. And finally, we have built a Docker file. Docker file is nothing but it is helpful to create an image which is already present with some other additional features. Let's suppose I want to copy my code. Using the Docker file, I can build an image and I can run the container from it. We have created an image with a pre-built container called hshar/webapp, where in this container, Ubuntu is the operating system, and then we have Apache is installed in it. Then we'll add our code that will be displaying on our code. But for that, we have created a cluster in Jenkins, and using that cluster, we have built our website. Let me show you the website. I'll be giving the IP address along with the code. We'll run it. We'll see what exactly the output is. This is our website which is running on, which is we created yesterday with the IP address along with the port 82 using continuous integration. But this is created normally and we can see it, which basically means we know that website is running. But as per the process, we need to test it. The developer team or the operation. Here it is a sample website, so I can get to know whether it's displaying correctly or not. But let's take an example of a larger application where you have more functionalities. Then you need to test it. Over here, this website need to be tested. What are the testing processes? There are two kinds of testing. One is manual testing. The second one is automated testing. Once we have, and over here, I want to test it. As I mentioned just before, there are two kinds of testing. One is manual testing and automated testing. Manual testing, there are certain drawbacks. What happens is it cannot search or it cannot test every feature of it. It is not that efficient to test it. Whereas automated testing, we can write a test case which will be running either in Java or Python inside the Eclipse using the Maven dependencies and Selenium installed. Selenium is a tool. Selenium is a tool which will help us to test the websites or test the application. It is an automated testing platform, automated testing software that will help us to test the websites over here. We'll have this website, we need to create a test case for it. For that, what are the prerequisites for this test cases? There are certain prerequisites that you need to consider. And someone is, what is difference between Kubernetes and Docker? Both are container orchestration tools, but while come to the Kubernetes, we have certain other microservices like health checks of doc containers and all, which will be more efficient Kubernetes with the help of the microservices and all, and or else the both will be similar, but Kubernetes is more efficient with the microservices. And over here, while we running a test case, we need to create a code for that. For that, we have a prerequisite for it. The very first thing is we need to have Java installed on your local system. This code I am creating inside my local system, which is my laptop over here, and we'll convert it into a runnable jar file, which I already explained to you yesterday. We'll build a jar file with the help of our test case. Then we'll execute our jar file and continuous integration part. So that what happened, whenever it appears, whenever this test case executed, it will test the website it is running fine or not. Then if it is given with a success, then we can go ahead, and place it in the production server. That's what operations team will do. Don't worry if you are not good at coding, don't worry on it. But these are the test cases that will be written by the testers, and you will get a jar file which you need to execute. But over here, I'm the one who need to test this. I'll be writing a test case for it. For that, I have my Eclipse ready with me, and where there are certain test cases as well. Let me show you. Over here, this is my Eclipse where I have certain codes written over here. But what I'll do is I'll go ahead and create a new class. I'm not going into setup of Java or Eclipse again and again. Instead of that, I'll write a test case. The Java Eclipse setup, you can get it. Let me right click on the project and go to new, where I'll be selecting a class. And over here, I'll give the name of the class. Test1 is the name. I want to include my public main also. Let me open it. Yes, this is my class which I have created. Once it is started, what we'll do is we'll give the web driver. We'll define the web driver first. There is, we'll create it like this, web driver. The very first thing what we need to do is I need to import the package web driver, which I have done. Once I double click on it, I'll get the web driver for me. And inside that, I'll start with getting my web driver where exactly I have downloaded. For that, system dot, let me go ahead. We'll go ahead and start with a class method, and inside that, system dot set property. And under that, what will be the test? What is the Eclipse version, Kanan? My JDK is 13 and Eclipse is a latest version which I have downloaded it. This is my location which I am using for my driver. So I'll be using this particular location to do it. What exactly this is my driver which I have downloaded it. I'll show you where you need to download this driver. Let me first go ahead and show you the version of my Chrome. Then I'll show you how to download it. Over here, let me go to help and go to about settings, where I have 83.04 is a version, and for that I'll go to this location, which is chromedriver.chromium.org/download. This is an automated test, same as functional test. Yes, it is an automated test which we are creating. Here, this is my version of my Chrome, 83.0.4103. Let me click on it, where you'll get the downloadable files, which is nothing but your Chrome browser, which you can download as per your settings. Let's suppose you are using a Linux machine, you can go ahead and use Linux. If you are using a MacBook, then you can go ahead and use your MacBook Chrome driver, and as well as a Chrome driver for Windows. I already downloaded it. That is the location. And then what I'll do again is over here, I'll go ahead and add certain policy. First, what I want to do is driver dot get property. I'll give the location. What is my location over here? This is my Intellipaat website location. I'll be copying the location and I'll be pasting that particular location over here because I want to test this particular website. So I'm getting into the driver. Then what I'll do is I'll want to check whether website is displaying or not. For that, we have an option. We need to inspect our website and we need to check the XPath. For that, go to function F12 and I'll copy the XPath over here. It will be /home/Ubuntu only. But for that, we need to define it. We need to define what we need to search it. Yeah, we'll check it what exactly need to be tested. Over here, this testing cases is a part of your tester job. You need not to worry about this testing cases and all, returning of writing this testing cases and all. That will be taken care by your tester. But you need to understand how to run this particular thing. So don't worry on it. Here they are asking once the website is built, you have to design a test case which basically check if the website is opened or not. So for that we need to write the test case. For that I am using XPath. I'm pasting the XPath over here and let me remove the indentations issues. For this testing cases, testing knowledge need not to require for it. You need to understand how to run a jar file. Don't worry, instead of going ahead with the test cases, what I'll do is I'll show you this particular test case where I have written for Google. Let me modify it to my name, my website ID, URL. Let me show you and explain you with the code. Then you'll get a clear idea instead of writing code one by one and all.
Let's check out our quiz question, guys. Which of the following is a scalar data type in YAML? The options are A. List, B. Boolean, C. Dictionary, and the last option is D. Set. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
The very first thing we have defined our driver. Need to find XPath of the element. Yes, it is already get. We got the XPath which is /HTML/body because this is a sample website, so it will be there. If it is a web page opening means then driver.get is enough. Opening we can do that, but let me check with the XPath as well. The next thing I have defined a function hello, and inside that I have given my Chrome driver address. Then later on I have added some of the options. I'll tell you why exactly I have added this particular options. Basically I am running on the server, which basically means I have a Linux machine, but it does not have any user interface. If I execute the test case normally, it automatically opens our browser UI. I don't want to use it, so instead of that, it would help me if you get the project in GitHub. Sure, we'll inform the concerned team, and the GitHub path will be given. And what is XPath? XPath is something which is used to help finding elements inside the website. Here, no need for body XPath. Yeah, don't worry on this XPath issues. XPath is able to find the elements, but I'm just opening the website and I have written this XPath option, whether to check it is displaying or not. That's it. No need of worrying about it. Over here, I have defined my website address, and finally I have given an XPath address, which is HTML/HTML/body. This is my XPath address, which I am using for test cases. Over here, what I'll do is I'll show you without having any headless mode what exactly it is doing. Then we'll go ahead and check what need to be done. For that, let me comment this other section. I have removed the option and let me execute it over here. Let me remove the option and let me comment others and let me show you first whether it is displaying or not. We'll test it from here. Then it will be more clear for the people who are not from a technical background of coding and developing. Over here, I'll run it as a Java and we'll see what exactly happens. Over here, right now it is executing. It opened up the browser on my screen and it is executed my IP address and it opened website for me. This is what our test case basically do. Once we completed the test case, then we can go ahead and see the output once it is successful. We got this output as test runs 1 and there is no failures and skips, which basically means our test case has been executed and where the people of testers team or that particular testers group, they'll give you with this particular what is your task over here. Basic task of a DevOps engineer comes over here with the installation of Chrome driver on your machine. So let me open it and let me restart this terminal. Let me restart this session and then I'll download the Chrome driver along with the Chrome browser of Linux because I'm doing it inside the Linux. So for that I'm doing over here Ubuntu as the username. I'll show you how can we take actions on it once it is successful. We'll use the post build actions. Once it is successful, we can go ahead and push it on the production. That thing we'll do. How did you compile and run the Java program? For that, we went into the configuration on the Eclipse IDE where I have executed the code. Don't worry on it. Don't worry on it. I'll tell you what exactly a DevOps engineer job over here. We'll have some other session by Intellipaat regarding this Selenium and this test cases. Then you can get a clear picture what exactly of a Java code is. Over here, let me install sudo apt get. I'm installing in the test instances right now. I'm not installing in the master as of now. Once let me complete it. Let me install it. Type install sudo apt get install. This will help us me to install Chrome browser inside my machine, my Ubuntu machine. Right now my Chrome browser is installed. Right now what I'll do is I'll go ahead and install or I'll get the browser. I'm copying the link of Chrome driver Linux because I have a Linux machine with me. So I'm copying that link and let me clear the screen first. Once it is cleared, what I'll do is I'll first check whether I have wget or not. apt get install wget and it is showing already installed. So let me run this command wget and if I do an ls over here, there is a new file that is downloaded chrome driver underscore linux 64.zip. For that I need to unzip this Chrome driver. How to do that? I need to have unzip option sudo apt get install unzip. Once unzip is installed, I'll run this command unzip Chrome and if I do an ls, there is a Chrome driver present with me inside my system under the location pwd which is /home/ubuntu. Over here when I am running my test case in the Eclipse that is on my local machine. So I have given with the address of my local machine Chrome driver. But right now I want to run it inside this particular machine. So I want to have this Chrome driver address. Over here in the terminal, don't worry, I just installed my Chrome driver and Chrome browser so that I can test it. I can test my website inside the Linux. That's what we have done so far. We have installed a Chrome browser over here, then a Chrome driver according to that particular version is installed in the terminal. Now, what we'll do is we'll take the name or the address /home/ubuntu. I have already written in the comment section /home/ubuntu/chrome driver, because I want to execute this in that particular location. And also I don't have any GUI for my Ubuntu machine, which is running on the server or the on command line interface. For that, what I need to do is I need to execute in a headless mode. Headless mode is nothing but it will execute without opening any browser. It will execute without any opening any browser. If you want me to check, you can go ahead and add the browser again or the driver address over here. Then try to execute it. What happens is it will not open any other browser. Let me copy this address of my Chrome driver and let me show you first. Then I'll go ahead and copy with this particular home/ubuntu/chrome driver. Let me do that so that you'll get a clear picture what exactly is going on. Let me run as a test-ng test. Test-ng is a framework over here. Right now, my execution is started. Once I run as a test-ng test, my execution is started, but it is in the Chrome driver. Let me modify it. And also there is one more reason for it opening the Chrome driver. We have defined the options, but I did not mention the options over here. So once I define the options again, if I try to execute run as, right click run as test-ng test, we'll see what exactly happened over here. And then we'll go ahead with the rest of the other part. Yes, we need to change the path based on the location with where the Chrome driver is installed on the server. Right now, over here, my test case is executing, but there is no browser open. The reason for that is basically this headless options will help us not to open any kind of browser or any kind of interface in between. It automatically runs the test case in the background. So I want the same because I don't have any GUI for my Ubuntu machine. So let me type /home/ubuntu Chrome driver, which is the name. But before going ahead, what we need to do is we need to execute it as a normal application so that we'll get an error. The reason for the error is basically I have given this particular location, which is not acceptable inside the IDE of our own machine. But why did I run this particular code? Because to convert it into a runnable jar file, I need to execute for the configuration. For converting it, just we need to export it. Click on export, right click on the file test.java, export. Then go to runnable jar file. Over here, we'll select the configuration. This is the configuration. And this is the location where I'm saving my file with the name hello.jar. If you want to define your own name, sure, you can define your own name. Over here, I'm packaging all the libraries. Why I'm packaging all the libraries? Because when I am executing, I'm not added all the packages that are required for this test case out externally. So I'll package all the libraries inside the jar itself. Then once I click on finish, it will start creating it. Just override it, and I'll click on OK. Right now, a file called hello.jar that will be created on my local disk B. Let me show you. Let me show you with the over here. Okay, what I'll do is let me close it. I'll open command prompt. I'll show you how the test case will work. But over here, it will throw us an error. The reason for the error is I have given the address as /home/ubuntu, but this is the command that will help us to execute it. Hello.jar. It will start opening the browser, but it will directly throw me an error over here. Test run is 1 and failure is 1. The reason for this failure is basically I have given the location as /home/ubuntu. That is the reason for its failure. This is concept under Selenium, where we are writing a test case. Then we want to execute it on our browser. Basically, the test case for testing our website, which is created. Can you also use TestNG with this so we can utilize TestNG result via index.html? Sure, you can do that. Is this Eclipse? Yes, Eclipse. I have installed on it. How did you download that Chrome driver in your test instance? Using the wget command, Mohammed. Using the wget command, I have installed the test server or Chrome driver inside my machine. Right now, I'll connect to FileZilla. This is my FileZilla, which is already connected. So I'll enter into D drive where I have hello.jar. Let me scroll it down over here. This is the hello.jar. Let me double click on it. What happens is when I double click on it, it automatically transfer into the node machine, which I have connected already. Once it completed with the uploading, it will take a bit of time, but once it is completed with the uploading, we can go ahead and execute that particular test jar file. Currently, we'll test it on the browser first, or we'll test it on the terminal first. Then we'll go ahead and implement a new job in under Jenkins, which will create a post build action to push into the production server. Until now, we are using only two servers. One is for master. The second one is for the test server. But right now, once the test case is executed successfully, or once we get an output as success, then what we'll do is we'll go ahead and create a new server where we'll be executing our website once the test get got successful. But before that, let me go ahead into my AWS console and let me launch a new instance. Meanwhile, the other process will be going on. I can use my master server, but instead of showing you with the master server, what I'll do is I'll create a separate server for this. Then we can go ahead and discuss regarding this server as well. In the production server, I'll be keeping all my data. Over here in the AWS, I have opened it. Let me cancel it and let me reload. Let me click on running instances. Right now, there are some other instance. Let me create one more instance, which we call it as production server. Let me launch a Ubuntu server only. Can we use any other than Selenium? Why DevOps engineer need to know the Selenium? You can use different other tools as well, like Cucumber and other automated tools. But as a DevOps engineer, you need to understand why the testing is required, because whenever a product is created, we need to check whether the expectations are met or not for that particular product. Then only we can go ahead and check the application that is fine or not. For everything, the testing will be there inside in IT industry. Over here, you can use any other automated tools for testing purposes. There is no issue with that. But Selenium is one of the tool which widely used by the market. So that we have included in our course curriculum. Over here, I'll select the key pair. I'll select the group that I have created yesterday. Test project as a group. And under that, I'll launch this instance using the key pair that I have in my system and click on launch instance. Right now, a new instance is launching, which I'll be naming it as production server. After that, I'll add this production to the cluster of Jenkins. Then we'll go ahead and deploy the changes inside the server production. I'll give this as a name, but what I'll do is I'll use this particular server and I'll go ahead and install Java in it. I'll modify the colors so that you people will not confuse regarding this which server is. Orange color I'm giving it, which basically means my production environment. And also one more thing I need to tell you, as I already added my key pair which I shown you yesterday, I'm using the same key pair inside my putty. It'll ask for my username, which is Ubuntu. By default, for all Ubuntu machines that are launching in AWS, the username is Ubuntu. And then we'll update my machine whenever we get the machine first. We'll update it. Update. Once it is updated, we'll start with the installation of Java inside my machine. Sudo apt get, let me type it correctly, sudo apt get install openjdk -8 -jdk. And install Java for me, which is prerequisite for installing Jenkins or adding this node to a Jenkins cluster. Java is compulsory. So we have installed that Java, and also we'll go ahead and install some other things as well, which is nothing but my Docker, because as I want to execute my containers and all, which is created in the test server, I'll be using Java over here. Sorry, I'll be downloading Docker as well. Then we'll go ahead and create a new node inside or Jenkins console. Meanwhile, let me check where exactly my transfer is. It is 60%, no issues. Once it is completed, then we'll go ahead and run the test case. I'm doing it parallelly for the time constraint. Don't worry on it. Let me install Docker as well. Docker.io is the name of the image which I am installing for Docker. Once Docker got installed, what I'll do? What are the things that I'll do? I'll go to Jenkins. I'll click on Manage Jenkins. Here I'll be adding a new node, Manage Nodes and Cloud. I'll be entering into new node where I'll be adding a node called Production Server. I'll type it as production, that's it. And I'll click on OK. Then the location for this production is also I'll giving as /home/ubuntu/jenkins. Why are we creating new instance today, as we have created two instances? Basically two instances where I have created. One is for my master server. The second one I'm using for my testing purposes, where developer will be giving the code and all. But one server which is required to make it on live, right? Basically, in general terms, we call it as live server. From this live server, the website will be displaying to the internet. Testing server, only test cases will be run, or testing purposes we use the test cases. And over here, I'll click on save. I'll click on save. What happens once I saved it? I have created a new node called production, where the same JNLP connection agent.jar and slave agent.jnlp will be present, which we need to go ahead and transfer into my node machine. Previously, we have transferred into my test server, where testing is done. But right now, I have to copy it to new instance. Let me copy it first. Copy the IP address. I'll open FileZilla. It is completing over here. Once it is completed, I'll open new session and transfer is finished into that server. This is the new server where I have added my key pair under settings, and I'll show you edit settings and SFTP where I have added the key pair. So I'm able to SSH into the new instance as well. And then I'll drag and drop these two files. Then I'll rename it. I'll rename this file. Then I'll try to execute the command. Previously, we have launched two instances, but it does not have any static IP which I have provided. I have used the public IP provided by the AWS console. So what I'll do is I'll modify some of the names, but before that, let me drag and drop it into my FileZilla. Same for this. Meanwhile, we'll go into my test server, which is this. Let me restart the session. Are we using here today Ansible for configuration management? We are using Puppet for configuration management today. Mahesh, you asked this particular question. Over here, I have agent.jar and hello.jar present inside my machine. What I'll do is I'll execute this particular sudo java -jar hello.jar. Once I executed in this particular system, we'll see what exactly it is happening. It is showing some failure. We'll check the data again and we'll try to execute it over here. Why don't we use wget instead of FileZilla here? I want to copy the JNLP connection as well, so I am not using that. That is the only reason for it. Right now, I'll be entering into my node machine. It is my online browser, and let me do an ls. there is some other name. So what I'll do is I'll rename it from over here inside the FileZilla. You can use sudo mv command as well to renaming it, but this is quite easier for us. So let me rename it. What happens if I do an ls over here? The names are modified accordingly. Agent.jar and slave agent.jnlp. Right now, over here, if you can see the difference on the top, the IP address is different from the IP address that is present over here. The reason for that is I have not used any sort of elastic IPs. I don't have any elastic IPs, so I have used the same IPs which is provided by AWS. But right now, for the Jenkins cluster, we need to give the updated link. For that purpose, I'll be modifying the command over here a bit. Basically, I'll add the address of my master server, which I launched in AWS. Basically, when I restart the system on AWS, my IP address will be changed. So let me remove it. Let me copy the IP address of my master server, which is this. Then I'll execute the command. What happens once I execute the command? It will test whether the server is on the previous ID or the current ID, because I'm using both the IP addresses. Previously, I have used 100.26.247, which is the IP of yesterday's mission. The missions are same, but the IP is changed due to restarting of the instance. If I don't restart it, it will charge us a lot. That is the reason I have restarted it. Once it is confirmed over here with the new server, what happens? The info is again showing it as connected, which basically means my instance are connected to my Jenkins. And let me open a duplicate session over here. There is a new folder called Jenkins ls. There are remoting files and all. Let me run a sample test over here, sample application over here, sample job over here on the production environment, so that you'll get all the code back to your system. But before that, what you need to do is you need to execute your test case. How to do that? I'll show you. Click on new item. I'll write it as test job, and it is a freestyle project. Once I click on OK, I'll go ahead. That I need to have the GitHub URL. Let me copy the GitHub URL for me. Let me click on clone to get the repository URL, which basically defines our GitHub project under the settings of a job. Previously, until now, what we have done, we have restricted it to the test server. But right now, I'll be moving into the production. And over here, I'll not add any webhook, but I'll add the source code management because I need to define the source code. Let me add the trigger as well. In the execute shell, first I'll write only echo command. Then once it is executed, what happens is I'll get the data. I'll get the data from my GitHub where I have defined project. Once I get the data, I can go ahead and build it. Let me save it. Once I saved it, what I'll do is I'll just go ahead and build it from here in the console, and we'll see what exactly the build it will show. The output, once it is successful, then we'll go ahead and see inside my production environment what are the things that is added currently. Right now it is a success. Let me go ahead and go back to the root directory. Let me list the details over here. Let me enter into Jenkins. Under Jenkins, we have a place called workspace. We'll be entering into workspace. And inside the workspace, we have test job. We'll be entering into test job. Inside the test job, you'll have the all files that are related, that are currently present inside your GitHub. If I update something, it will be updated over here. Right now, we'll go ahead and create a test job. Once the test job is executed, then we'll go ahead and run the other jobs as well. Let me create a test job. Create a new item over here. Test website. I'm testing the website with the freestyle project. And the same GitHub URL will be given over here. GitHub project where the URL is this. And over here, the testing will always done inside the test server. So it will be present inside the test server only. I'm not defining any other production environment over here. I'll be defining the test server. And once it is completed, what I'll do, I'll go ahead and add other steps for executing this particular file. I need to be inside /home/ubuntu where my Chrome driver is present. For that, let me copy the file sudo cp ./hello.jar to /home/ubuntu, and then I'll execute it. I'll execute this particular jar file command sudo java -jar /home/ubuntu/jenkins. Sorry, it will be inside ubuntu only. Hello.jar. This is the jar file which we want to execute it. I'll save this command. First, I'll be copying. Why I'm doing this? Because I want to enter this jar file inside my website directory where I'm pushing into my GitHub. Through GitHub where our versions are handled. Jenkins will get the data from GitHub. So we need to copy it and push it to GitHub using the website directory. But there is a problem with that. What exactly the problem over here is, when we executed it like that, my Chrome driver will be present inside /home/ubuntu, which is not inside the website. So what I'm doing, I'm copying the hello.jar. Then I'll show you the post build actions, how exactly a post build actions will be happen. Once I configured the post build actions, once there is any update with the master link, one particular job will be executed and followed by the rest other jobs. For that, we'll go to the post build actions and build other projects where we'll be adding other project. The next project is -website, and I'll save it. Under the test GitHub webhook job, I'm adding a post build action as build website, and I'll go into build website job. And inside the build website job, what I'll do is I'll remove the trigger point. And I'll add the rest other jobs. What are the other job that I have in my system, which is test website job? We'll add that. I'll remove the build trigger first. Then in the post build action and build other projects, what I'll do is I'll go ahead and add test-website. I'll save this test website job. We'll come back and see whether it's added. Yes, downstream project is test website. Let me enter into test website. From there, once it is success, let me configure it. Once it is success, then automatically we'll push into the production where the name is given different. We'll check into that name. Don't worry on it. Build other projects, and there is an option trigger only if build is stable. If build is failed, here we'll give the conditions as well. If you want to give any other condition, then you can do that. If a build is unstable, then also if you want to continue ahead, then you can give that job like this. But let's suppose you want to do it only if the build is stable, then trigger only if the build is stable. Right now I've created the post build actions already with me, and I'll add a pipeline plugin for my Jenkins, so that what happens, I can see this all jobs in a pipeline. For creating that, I need to install a plugin for manage Jenkins. Click on manage plugins under manage Jenkins, where I'll have the plugins which I'll be installing in it. I'll be checking on available. Once it is refreshed, I can go ahead and check the available plugin. Let me type it. Let me type the complete name of the plugin. This is the plugin which is build pipeline. I'm selecting it and installing without restart. What happens is my build plugin will be installed. Using this plugin, build plugin, I can define a job initial job inside the view, which will follow up the stream. Let's suppose take an example. My first job is testing of webhook. Once the webhook got testing done, then automatically it will go with the next job in a sequential order under pipeline. I'll show you the continuous integration pipeline. Let me create a new job. Over here in the view, I'll add a name, CI/CD, and a pipeline view I'm creating. Under the pipeline view, what exactly the task you need to do is, you need to define the initial job. That's it. The next job will be taken or other will be taken with the help of the post build action. Let me click on OK after selecting the initial job, and we'll see what are the other jobs that we are configured according to this particular, which is our first job. If you can see the pipeline, test website copying jar to test job. Test website will copy the jar file, but that is not required in the production. In the production, we'll never do a testing. In the production, we'll not do any kind of testing. There we'll just build it. Hook, build website, test website, and test job. Is this the flow of pipeline? Yes, sir. It is the flow of the pipeline. You can see on the screen right away. This is the pipeline, but let me do it from the instance itself, my node machine. Let me restart it. Right now, let me clear the screen and do an ls. Right now, hello.jar is present outside the website. Let me copy it, sudo, let me move it, hello.jar to /home/ubuntu/website. Why I'm copying into this particular location? Because there is a place where I have initiated my GitHub. If I do an ls, there is hello.jar file present. Right now, what I'll do is I'll add all the files to the staging area, and I'll commit it sudo git commit -m test jar added. Then let me push it sudo git push origin master. I'm pushing it from the master. This is the username, and I'm giving my password. Once it started pushing, I'll go here in the pipeline. Once it is completed, then automatically this build pipeline job will start. It will refresh, don't worry. Once it is refreshed, you'll get to know what exactly job is building first. It will take a bit of time, but don't worry, let me refresh it. Yeah, previously we used to have an enable description of enable refresh option. Let me show you. First job is executed. Right now build website is going on. This is how you can check the pipeline. Then test job will be created. Test job will be executed. When the test job is executed, then test website job is executed. Then it went to test job, which also we can call it as push to production job, which I given with a wrong name, but don't worry on it. We'll modify that particular name. Over here, test job is also executed, but this test job is something, the name will become different. So what I'll do is I'll make it to push to production. Let me configure it. Let me configure the name. Here I cannot configure the name, basically, which I have already given. But what I'll do is I'll add the execute shell. Previously it is only echo hello, but our task is to build. If it is successful, what we need to do is we need to build this particular website on the production server. For that, what I'll do is sudo docker build, and DockerFile will be present inside /home/ubuntu/jenkins and /workspace. Because in the production environment, once we directly join the cluster, it will be saved inside this particular name, test-job. Inside it, if you want to check it, verify it, you can go over here. This is the location. Let me restart it and show you again. Then we'll go ahead and create a job, whatever the website that is running on. We'll create on port 80 this time, so that we can create a monitoring service to that as well. now from now onwards, what we'll do is we'll use our master server for the configuration management and all. Testing server will be completely dedicated to developers and the operations team. Master server will be handled by the DevOps engineers, where you'll be looking after this particular servers and all with the configuration management and its maintenance. Right now, this is Jenkins, CD Jenkins, and once inside the Jenkins, CD workspace and CD test job. And once inside the, let me do an ls. These are the files which are present. So let me do a pwd. Pwd, what will do is it will give me the location. Let me copy this location and which I'll be pasting over here. Or this is the same name, but let me do it where I have my Docker file, which will be giving it as prod, nothing but production. Then sudo docker rm, run -it, and the port will be 80 map to 80, and then -d. The name of the image will be prod, which I am giving over here. I'll be executing the pipeline again. Once I executed the pipeline, we'll see whether the website is built or not. Let me go to CI/CD. Instead of from my test server, what I do is instead of making a new commit again and again, I can run it directly from here. What happens? The test case will be executed. It will not create a multiple commits. You can directly use this. When exactly, which means when we executed this job, this command line will be executed. And over there, if you have the certain files that are required for this shell script, it will be executed while running the job. In the job, nothing but in the execute shell, what are the commands that will be executed once we executed the job. Let me do a refresh again. And it is building the website. Can we export our Jenkins jobs and re-import it again? Where you want to export it? Over here, the test job is built successfully, but it want to be a continuous process. It should be a continuous process. I cannot directly use once because it should be a continuous process when there is changes, which will automate the complete process, which will automate the complete process of continuous integration and deployment. For that, what I'll do, I'll remove the previous container once there is a build. And also you can do for the efficiency, what you can also do is after completing it, you can pull this particular image. You can pull the image to Docker Hub if you want to retrieve it previous versions. Previous versions, what exactly it is executed. If there is any crash, if you want to retrieve the older version, then it will work for you. If you push the image to Docker Hub. For that, there are certain plugins inside Jenkins. You can use it. Sudo docker rm -f dollar sudo docker ps -a-q. What exactly it will do is this will list sudo docker ps -a-q will list all the containers that are running inside the machine, and rm command will remove the container. Basically, we are removing the previous containers and we are creating it. Suppose today I created 4 jobs, then I want to take job backup, then use it after 1 month. You can do it by taking the image of it. Once you take the image inside the Docker Hub, you can build the image again. After it, for that you need to write a separate job. Right now, if I execute again from here, what happened? My Jenkins jobs will be executed successfully, and it create a process to automate the changes. Due to the network, this issue occurred. Don't worry on it. It will not cause any issues for us. Due to network, this error occurs, previous error. Right now, this run process is started. Once it is executed successfully, what we can do is we can check the status. We can check the status by getting the IP of production. Previously, I have used IP of test server, but currently I'll be using the IP of production because this is the new server which will be running on port 80. So I'll be using that. Let me refresh it over here as well. Over here, if you see the IP address, it is displaying a website. It will take a bit of time, but it is displaying a website on the production server. The IP address is a production environment 54.146.95.118. This is the IP address of the production server where the website is deployed. If I modify this changes, let's suppose here a hello world is there. Let me modify to something inside my test server. I'm not using anything on my production environment. Whatever the changes, it will be done inside the test server only. And once it is modified, we'll see whether the changes happen in the production server or not. I'm modifying it inside my test server. Then I'll check it whether it is applied in the production server or not with the process that we have created for Jenkins. Use test website copying jar to test job. It will not copy basically whatever the file that is present inside the GitHub URL. It will copy Muhammad. And over here, this is a test server. Let me enter into website, and inside the website, let me enter into index.html, and let me modify the test heading to, I'll make it as hello simply, and I'll save it. Right now there is a modification. When there is any modification, what I need to do is I need to add it to the staging area. Then I need to commit it. Sudo git commit -m final test. Finally, I am testing this particular thing and I'm pushing it from the master. Sudo git push origin master. I'm giving my username, and once it is started, we'll wait over here. We'll see what exactly happened. Let me refresh it. Or else we can do one more thing as well. We'll go to the production server IP address and we'll wait for the changes. Until then, we'll refresh it. The change should be modified to hello. Over here, if you can see it, my production server data is modified to hello. The reason for that is my job is executed successfully over here the fifth time, and it is modified the name. If any developer has modified some changes in problem statement, it says that if you push and develop, then test only without pushing to the production. Mohammed, what exactly we have done just now is we pushed it from the master, right? From the master, when we are pushing, it is built successfully. But for the develop branch, what we need to do is we need to create a separate job for it, where exactly we'll be writing a command, we'll be adding all the commands for building that job, but it will only be builded and tested. It will not go ahead and do any other jobs. It will not push it. It is a separate job which we are creating. And yesterday I have already explained to you how to define a branch separately. If you want to define it separately, how to do it, I have explained it, but no issues. We'll do that. We'll create a new item where it is a repetition process. That's the reason which I'm showing you. Let me do for develop branch. It's a freestyle project. Click on OK. Yes, we'll use Puppet as well. Don't worry, Dheeraj. Puppet on that, what we'll do is we'll use the configurations which are pushed. There are certain conditions as well. We'll check the conditions and we'll write a manifest file for it. Over here, I'll be restricting it to test server. I don't want to do it in the production server because it is clearly mentioned as it should be done inside the test server only. And the branch over here is develop, and it has a GitHub trigger. And under the execute shell, what we'll do is we'll go ahead and write the commands for building it. Sudo docker rm-f $sudo docker ps -a-q, and then I'll be building it. Sudo docker build /home /ubuntu #dot -t test1 sudo docker run -it -p. I'll give a port, different port for the testing or for developers to check. I'll make it as 85 port and I'll name it as test1. Then finally for executing it, sudo copy. We did not add it inside my docker branch file. Don't worry when you are practicing what these two commands to do. These two commands will build the Docker file with the tag test1, and test1 image is executed on a particular port. Over here, you'll be adding the hello.jar for the test case as well, where you can go ahead and check the output. All these commands, the very first command basically used to remove the previous containers if there is any. Because if I give port 85 and I'm building continuously, what happens? First time port 85 will be allocated, and the second time when you try to add, it will throw us an error. The reason for the error is port 85 is already utilizing by the previous container. So that purposes we need to remove the container first, then we'll build the Docker file again. Then finally it will execute for the continuous process. And right now we'll go ahead and see other things. Let me save it as of now. If you execute or if you try to build it from the production server or from the develop branch right now, what in the test server, if you commit some changes in the develop branch, then automatically this job will be executed separately. This is what they mentioned in the problem statement, Mohammed, which you have seen previously. Problem statement says that when there is a develop branch, if you want to trigger that develop branch from this particular location, you can define it separately. So the changes made inside the develop branch will be executed, and it's only build it, the website, and it will be tested. This is what the problem statement means. Over here, let me go ahead and show you something in the problem statement. We need to have both test and production server with this following location. The file will be used by the third party tool. This should basically have the info whether Apache is installed in the system or not, whether it is installed in the system or not. But for that, we'll use the configuration management tool called Puppet. For that, what I'll do is first I'll go ahead and create Puppet master inside my master server. From yesterday, we are not using the master server. Here we will be using the master server for creating the Puppet master and as well as the Agile master. You can also go through the architecture advice that is given inside the problem statement, that we need to have an Agile master and also a Puppet master inside the master server, so that you can create any configuration once it is completed with the deployment and all. Continuous integration and development, if it is done, then we can go ahead and add the changes from the master. Let me update it, sudo apt get update. And for Puppet, there are certain prerequisites which I have saved in my system. Let me show you. These are the installation steps, guys. You can get it. You can get this particular document from the mail, which will be sending to you. And wget is also already installed. This is the package of Puppet, which we need to add this package with the help of wget. What exactly wget will do is, it will get the package and will unzip this particular package, pkg-i. This will use the Debian package, and apt will go ahead and check whether there is any master installed or not. First, we need to update the machine. Then only we will get the policy. Apt policy. Puppet master. What exactly this command will do is, it will check whether there is anything installed or not. It is clearly showing installation is none, because Puppet master, the rest packages, whatever we have downloaded, that remains the same. Only difference between the Puppet master and Puppet node is, on Puppet master will be installing master, and other nodes will be installing node system. And we'll sign the certificate. For that, we will need to add the IP address of master. Before that, let me install apt get install puppet -master. They'll ask for yes or no. Once I type it, there are certain other prerequisites. What exactly it will do is it will add some data to the puppet master. It will allocate some data to puppet master, which I need to add inside the following file. I have saved the command as well, where I'm giving 512 MB, and I have saved it. Once I saved it, what I'll do is I'll go ahead and restart the puppet master. Sudo systemctl restart puppet-master. These all are the setup for the puppet. And then finally what we'll do is we'll open up some of the ports. As I have already opened up inside my AWS console, I need not to do it, but let me do that. It will open the port 80. Then finally we'll define the host sudo nano /etc/puppet. Sorry, this is a wrong file. We need to open in host /etc/host. Over here, we need to define our public IP of the master. Here, I'll be using the master server, not any production or server. Master server IP address along with the name puppet. So that what happens. Then finally, what we'll do is we'll save it and restart it. Finally, that's it. From the master end, we'll be adding a file to create the manifest file. This is the location for that. Let me do that. What exactly I am going over here is these are nothing but the installation steps of Puppet. I'll do the same in the node missions as well. First, I'll enter into. Then once after restarting it, we need to get the package of Puppet. Over here, instead of Puppet Master, what we'll do is we'll install Puppet directly. Puppet Master will be act as a master. Puppet will be used to get the agents like sudo puppet agent test. For that, first let me update the machine. Sudo apt get update, and right now my machine is updated. What I'll do is I'll go ahead and install apt get install. Before what I'll do is I'll install wget. I hope it is already installed, but let me install it again. And then once after installing, we'll get the package. This is the package. Once I got the package, I'll be unzipping this Debian package, dpkg, which is the Debian package -i. It will install it. And over here, I don't have any Puppet Master, so I'll directly go ahead and install apt get update, and then I'll install Puppet. Sudo apt get install Puppet. Puppet will be installed. Here we need not to give any other permission. Only other thing what we need to do over here is we need to define the location, like the IP address sudo nano /etc/host. Here I'll be mentioning the host address, which is my master IP, along with the name Puppet. And someone is asking how the developer will get to know if there is any changes. For that, we have a plugins inside Jenkins. Basically, we'll use a mail notification server, which is present inside after post build actions that can be done. You can go through it. That will help you to understand better. But as for today's session, we'll go ahead and see what are the other monitoring tools and configuration management tools. Is this a test mission or master? It is a test mission, but in the test mission, I need to install Puppet. Then only I can do the changes. Sudo systemctl restart Puppet. Right now, Puppet is restarted. I need to do the same for the node mission. which is a production environment, because they asked us to do for both servers. Then after it, what I'll do is I'll go ahead and do the installation first, and I'll run the test case which I have written. Not test case, basically the manifest file will have the manifest file where it will define the condition. First sudo apt get update. Then I'll copy this package and sudo debian package install -i puppet. Right now what I'll do is sudo nano /etc/force. Inside this particular file, I'll be adding the IP address with the name puppet, and let me save it, and let me restart puppet. Sudo systemctl restart puppet. Failed to restart puppet. Basically, we just given it, but we did not updated anything. What I'll do is sudo apt get update. Then I install puppet. I did not install puppet. I just removed the package. Sudo apt get install puppet -y. Puppet is being installed. Then I'll run the restart command again. Right now puppet got restarted, but there is this puppet you use for health monitoring. No, Mohammed, puppet is a configuration management tool. As per the problem statement, we need to give this particular server to a third party tool where they does not know what is installed in it. So for them, we'll inform what exactly the file is present. For that reason, from the master server, we'll push all the changes, or we'll update we'll create a manifest file so that the test server will be updated if they execute this command sudo puppet agent -test. So right now, I'll create a new restart the session, and over here sudo puppet search, basically the certificate. There are certain certificates which are present inside our system as we have added our IP addresses. What I'll do is I'll assign all the certificates puppet search sign -all. It will sign all the certificates. Once certificate is signed successfully, which basically means if I write something in the manifest file, if the node machine executed the following command sudo puppet agent -test, this configuration will be executed, which is nothing but signing of certificate is nothing but configuring the cluster. Right now, let me go to location which I have created for my manifest file, which is this. Let me copy it, cd, which will enter the location. If I do an ls, there are nothing. So let me create a file, sudo nano site.cp. What exactly we'll write over here is, we'll write the manifest file. I have written a manifest file for you. Let me show you the conditions, what exactly it consists of. Over here, node is defined as default because I want to do it on the both nodes. I did not create it separately. I have defined default. Whereas in the conditions, I have conditioned that there is an echo command whether Apache is installed or not. Only if there is bin/which/apache2 is present. But there is one more condition which we need to write it over here, which is nothing but we'll be executing conditions again. And inside the condition, what I'll write is I'll give a command where I'll be writing Apache is not installed. bin/echo Apache is not installed. and I'll give the location. Over here it is written as /tmc, but we'll go as per the problem statement. We'll go with this particular location, status.txt. Let me copy it and let me paste it. And there is a close of quotation and as well as a comma. I'll do the same over here in the top, this assignment as well, where I'll be defining the location of my status.txt. Here, instead of only if, what I'll do is I'll use unless statement. What exactly this unless statement will do is only if will add the data.
Let's check our quiz question, guys. Identify the simplest model of SDLC. Option A, Agile. Option B, RAD. Option C, Waterfall. And option D, Spiral. I hope you have written the answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
If Apache is installed, but unless, what exactly it will do is it will wait until Apache is executed, which basically means if Apache is not installed, then automatically unless command will add the data over here /bin /which Apache 2, and we need to close the bracket. Right now, what you can say is there are something which is written over here in the condition, and this is the location of the file config management /status.txt. We'll see whether it is executed or not. Let me save the file in the master. Let me enter into any of the node machine. Let me restart it and let me show you if there is any file previously exist or not. Then we'll go ahead and do a sudo puppet agent test. Right now, if I do an ls, there are only files for agent.jar, Jenkins. These are the files that are present. Let me do the command sudo puppet agent -test. I have not given the complete command. Make it puppet. We'll see what exactly it will happen. There is an error over here. Flat EGB in the site 7th line. There is already an issue. What it's showing is file manifest already declared it. Conditions is already declared over here, but no issues which we have written. Let me go ahead and modify it. Let me test it. And not using catch fail catalog. There is a command attribute which is missing. Let me modify it once again. Let me do one more thing so that it will be clear for us. Instead of checking the status and all, let me go ahead and close this quotation. Let me do it. Node default. I'll write separate manifest inside it. Exec conditions. And let me close it. And let me save it. And once it is executed, we'll see what exactly the local files is showing. Let me check it. Let me modify it. Over here, the catalog is applying over here. The reason for that is we have declaring twice. What I'll do is I'll create one more file. And over here, I'll write the unless statement. Once we executed it, we'll see what exactly happened. It is showing the default server name is already defined. So we need not to define the default server again. Let me check it. Let me remove it. Sudo rm -rf test.pp, and let me enter into sudo nano site.pp. Over here /bin/with Apache2 is present, and let me paste it once again. Outside it, I'll not defining any node, and /bin is present inside it also, which should be unless as I define the node, I'll not define it again. Let me modify it. Let me execute it. And over here, basically what happens is I'm copying that particular code where the conditions, execute conditions is already present. Right now, exec conditions, I have modified the capital letter. I have modified the name convention, that's it. And everything is fine. Let me do an ls over here. Let me enter into directory, whatever the directory which we have mentioned over here, which is cd/tmp ls. There is a software.txt, sudo cat software.txt. Let me run it, sudo cat software.txt. And if I enter it, it's showing Apache is not installed because I have used a container where it is running on Docker, but I did not install Apache on my system directly. So what I'll do is I'll install it and I'll check the command again. apt get install Apache 2, which is Apache 2. I'll be installing it on my system, and then I'll execute the puppet. Then I'll execute the puppet and I'll see what exactly the changes happen. Then what I'll do is I'll go ahead and run puppet agent test again. Once I executed the puppet agent test again, it is executed, but there is a non-written code existed. The reason for it is basically is my Apache is not starting successfully. I'll tell you the reason, but before that, let me test on the node mission as well. Let me create a duplicate session directly, Ubuntu, and I'll run the puppet agent test again, sudo puppet agent -test. You might be wondering why I'm doing this puppet agent test. You'll get to know when you are having a cluster of 100 to 250 missions in your cluster. Then what happens? That 100 missions need to have this file updated. Instead of you entering each and every mission and creating it, the script file that is already written inside master mission, you'll ask the people who is working on this particular server to run this following command, which will install or it will have the file added to your cluster where you have the configuration management. Right now we are adding a simple file, but in the real time you can also install certain packages. Right now if I do an ls, what happens is there are the files that are present, but let me do cd/tmp, and if I do an ls, there is software.txt, but sudo apt get install Apache 2. I am doing this installation again. The reason for that is previously I am running website on port 80. Over here there is no port 80 is utilized. If I install Apache, then directly it will utilize the first 80 address for the default page of Apache. Previously in the other mission, what happened? It is not created. It is not created. The Apache server is not started. Over here, it is not creating this particular location. Directory does not exist. So what I'll do is I'll come back to this particular nano site.pp. I'll modify the location. Why I'm using this /temp? Because every time when the configuration comes into place, it will not be in a visible format. It should be searched by the people who are working on it. So it will be in this locations only. Where right now, if I enter or if I inside.pp text file, path should be changed or unless condition for unless condition. No, it is not required. You can give this location also. The major thing that you need to understand over here is not about the location, whether the directory is creating, whether the file is creating or not. In order to go about the names, Mohammed, let's suppose take an example. I have given a name as software.txt. Whether we'll see whether it is installed or not. Software.txt is showing not installed. If I do an ls, what happens? There is one more file called status.txt. What exactly it will define is sudo cat status.txt, which is showing Apache is installed. The reason for that happened because I have given two names. Let me modify to single name, which is status.txt. Then we'll change the difference. If I executed it on the production environment, what happens over here is in the production environment, it creates a status.txt ls. If I run an ls over here, there is a status.txt present. Sudo cat status.txt. It will throw me an error. Sudo cat status.txt. It will show Apache is installed because I have installed Apache in this particular machine. This is how you'll modify the configuration. Don't worry about the names. You can give your own name, your personal name, but as per the order, if the people are looking into that particular file, then you need to give the same name. But as of now, we are using status.txt. I have created inside the /tmp folder. And then finally, we need to create a monitoring service for the website on the production server. There is a website that is running on the production server. For that, we need to create a monitoring. When it comes to a monitoring service, what it will do is it will give us the continuous feedback. It will take a bit of time. Today, we'll cover it up with the installation of NagOS, and then we'll show you how to create, how to do it, how to monitor the website. I'll not do much delay. Let's start with the installation. Let's start with the installation of NagOS. Under master, what I'll do is I'll start with the installation of NagOS. These are the commands that are the prerequisites for installing NagOS. I'll be doing a quick thing. You can get the commands, no issues. These commands are basically the installation step. It will take a bit of time for adding the installation. And as we are running on NagOS server, it needs to create a separate user for it. Let me execute this command one by one. What exactly this will do, I'll tell you. First thing is I'm installing the prerequisites where GCC library, and there are certain libraries which I am installing. Then over here there are PHP, Apache 2, everything is installing inside this node machine. Sorry, this is my master machine where I'll be adding a user called NagOS. I'll be adding this NagOS into a group where it has the permission. Why I'm creating this separate group for it? Because I need to display, I need to get the NagOS web UI, which should be on a different user. It cannot use a normal user. For that, I'm creating separate user NagOS. I'll give the name and I'll give the password. You can give anything. It will ask for yes or no for the information whether it is correct or not. Then you'll modify the NagOS. I'll paste the user group. We need to create a group first. Then we need to execute the other command. Then finally we'll add www-data, which is basically load our Apache website. And once it is done, we'll start with the installation. We'll start with the installation of NagOS. It will take 5 to 10 more minutes for the installation. That will help us to monitor our website, where I'm downloading the package NagOS core on my master machine. And from there, I'll be unzipping or opening up the tar file, tarball, which we have. Then I'm entering into the zip file which I have opened. There are certain files. So what I'll do is I'll go ahead and configure it. Once it is configured, we'll make it all. Sudo make all, which will make all the packages available. sudo make all, I misspelled it, sorry, make all. What exactly it will do is it will prepare all the files for the installation. It will prepare all the files so that we can install it, which are present inside the Nagios core, which I have downloaded using wget. All files are getting ready. Right now it is showing this output, which will help us to install the packages. Yes, we need to run the following command with the super user privileges and the other 3 commands as well. Sudo and finally this one, sudo. And once it is completed, we'll install web configuration, sudo. Then we'll start with the rewriting permission. For the graphical interface. Then we'll allow Apache for the firewall. As we don't have the firewalls, but still we'll do that. Sudo efw reload. And then finally we'll set a password for it. The username I'm giving it as Nagios admin. And the password I'll be defining as Nagios. Here we have defined 2 passwords. One is for the Nagios user. Second one is for the Nagios admin, which will help us to have the service present. But once it is done, once Apache is restarted or the Nagios service is restarted, that will not complete our installation. We need to have Nagios core along with the Nagios NRP plugin. So for that, we have certain other things which we need to install. We'll install it at one go. Then we can go ahead and check the other packages plugin. Don't worry, I'm going ahead with the installation step. Nagios is a vast installation. It will have a lot of commands for installing it, which will help us to have all the plugins ready for us. And using that plugins, we can use the templates, already created templates. That template will be helpful for you to enter any kind of monitoring tool or data. Let's suppose you want to add some other services. For that also, it will have a template already with it, which you can use it. From where you are copying this code, basically this is from the official documentation. I have saved it for the purpose of installing Nagios in my system. From the official documentation, I have saved it. But don't worry, in the mail, as promised, I'll send you with the test case command and as well as the command to you in the main chain. Inform the team to send you with this all details. Then you can go ahead. You can also use this command for your practice purposes. Right now it is making all the directories. What exactly make will do is it will collect all the files, and whatever the files is collected, it will configure those files, which will make us ready for the installation. Then we'll use sudo make install. Sudo make install will install the packages. Then we'll start the Nagios service. We'll start it, restart it, and then we'll enable it. What exactly this will do? This will create a service. This will create the service, enable. Right now, my Nagios is enabled. What I'll need to do is I need to go into my production server. I'll create a duplicate session, Ubuntu, and I'll be entering into /temp cd/tmp, where I'll be installing the plugins on the node. For node, there is NRP plugin. Basically, what exactly this Nagios will do is, it is a monitoring tool. It is a monitoring tool, guys, which will monitor our website. What is the difference between start and enable? First, which server is this? This is a production server. Start will start the service and enable will create a separate link for it. System link. Right now, NRPS plugin is creating. And then what we need to do is, as it is a node machine, nothing else need to be installed, only this. And we need to add the configuration under a load host in this location /etc/nagios/nrp.config. What exactly this will do is, it will have the configuration of NRP where I need to allow my host master machine. This is my master machine. Sorry, this is my production environment where I'm adding the IP address of Nagios master, which is my master server IP address. Let me copy it and paste it. Once I pasted it, let me go ahead and save this particular file. I have saved the file and I need to restart it. Then only this changes will allow. And right now the changes is applied successfully. But to display all this on a UI, what we need to do is we need to go ahead into the following directory where we need to define the host. The directory is this on the master server. Let me enter into the directory. If I do an ls, there are certain files. I'll create a new file sudo nano prod.cfg. What is this prod.cfg? Which is nothing but a production environment for that for production machine. I'm creating it. The format for writing this is we are defining the host. Previously, I have allowed the master. Right now, I'm defining the host where I'll be adding the address of my production server. My production server address is this, which I'm copying right now. I'll be using this production server address and I'll save it. Once the production server is saved over here, but it needs to be enabled with the configuration of Nagios. Just now I have created separately, but it needs to be added. Where exactly it will be added is, it will be added in nagios.cfg, sudo nano nagios.cfg. In this particular file, if you just scroll down, you will get to go over this position, defining monitoring the local Linux host. Copy this particular command and paste it over here and modify the name, which basically means you are including that production.cfg as well. If you include it and once including is done, what you will do is you will restart the Nagios server. Sudo system ctl restart Nagios. So right now my Nagios is restarted. Let me go to master environment. I'll show you the GUI of Nagios, how exactly it will be there. Let me open a new tab /Nagios admin. I'll write it as Nagios because that is my user. And once I type it, it will ask for username and password. Nagios admin is my username and password I have set it as Nagios. And I'll click on sign. Similar to the Jenkins, it will open a UI, user interface for us, where we can check our node machines. This is the Nagios UI, Nagios code dashboard, where you can go ahead and check the host machines, whether it is up or not. Right now, if you can see, there are two host machines. One is local host, the other one is Nagios host, which we have defined. It is successful right now, but this does not complete the complete project. What they asked us to do, they asked us to create a monitoring service to this particular website. Basically, my website is running on HTTP, so monitoring service is need to check that HTTP only. For that, what we'll do is we need to enter into object and we'll open sudo nano prod.cfg, basically the production.cfg. Here I'll define the service. In the place of defining host previously, I'll be defining the service. For defining the service, you can go ahead and check this particular data from the template. As I have already saved it, I'll show you where you can get the template. Here I'm checking for HTTPD. Check command is for HTTPD. with an interval time of 1 minute, and retry interval is also 1 minute. Let me save this file and let me restart system CTL, restart NagOS. Sorry, I misspelled it. Now it is restarted. We'll go to the services this time. Previously we went to NagOS. Right now we'll went to services. We'll see what exactly the services are there. Right now HTTP is in a pending state because I have given the interval as 1 minute. So after 1 minute, this will be executed and it will give us the data, whether it is giving successful output or not, or whether the service is up and running or not. Thus, we can create our monitoring service. This is what project that in DevOps or the architecture, the flow that will follow inside the DevOps. The very first thing will go to the version controlling. I'm going ahead with the recap until it gets started. First thing will be with the version controlling. Then after version controlling, what we'll do is we'll go ahead and build that website from the testing server with the help of continuous integration tool Jenkins. From there, once it is executed successfully, we use an automated test cases to test the website, with exact output or not. Then after testing that particular website, we'll push it to the production environment where it is a live server where the people can access. Currently, after doing that, we can manage the configurations. Basically, after making the release, this configuration management and monitoring comes into a place where configuration management helps us to define some of the passwords or any kind of packages that need to standardize in the cluster. That will be happen. And also NagOS as a monitoring tool, which we are using today for monitoring the service. Basically the website, my website is HTTP. If I stop the website, automatically it will ping us. Basically it is checking whether it is pinging or not, and for an interval of 1 minute time period. For every 1 minute it will check. You can modify the interval as well. So for every 1 minute it will check and it will let us know if there is any issue. So this is what our life cycle is. If you go ahead and see the life cycle state over here, developer will give the development, continuous development with the version control. Then with the continuous integration, we'll build the website with the help of container orchestration tool in the testing server. Then from the testing server, once continuous testing is completed, it will be in the production server. From the production server, we'll take the continuous feedback with the help of monitoring, continuous monitoring. This is what a DevOps engineer methodology is. This is a sample website, but you can use multiple tools, multiple type of plugins, depends upon the project, depends upon the application that your institute is using.
Now we know that software development is a very long process and it's a very arduous one. There's a lot of things that you need to consider when you're going ahead with software development. Even before you develop your software, there are some things you need to plan out, like how you're going to go ahead with the whole process, how you're going to schedule it, who you're going to distribute the tasks for a particular thing to. You'll have multiple teams that will be working under you. Then you have to define what that team is going to do at what time and when are the deadlines. You need to set benchmarks that you need to achieve. And there are a lot of things you need to consider. You'll need to figure out the requirements of your software. You'll need to do a risk assessment. You'll need to do a cost assessment. So there are many things that you can plan out there. And similarly, now to tackle all of those thoughts, all of those issues, you have software development methodologies. You have methodologies like waterfall, spiral, agile, scrum, lean. All these methodologies basically help you to plan out your whole software development lifecycle. And in the end, it basically helps you to have a clear mind because you planned everything and you get a quality product. Now, unlike those methodologies, DevOps is a culture. It's a philosophy of software development. You basically use this philosophy while you're working with your software, while you're producing your software. So DevOps basically aims to promote better communication between a development team and the operation team or the testing team. Now, better communication is very important because you're basically developing the software with this other team, but you don't have really good communication with them. So DevOps as a philosophy basically promotes a better communication within all the different teams that are responsible for creating the software. You'll have your infrastructure team, you'll have your development team, your testing team, your operations team. All of them need to have a really good communication between each other so that they can give each other the valid information that is required so that the software that is produced is of very high quality. And it also aims to automate every process of software development itself. Now, normally in the old methods, you would have your developer writing the code, giving it to the tester testing it, and then sending it for deployment. DevOps also aims for automation. It basically tries to introduce automation into every aspect of software development process. And this basically increases the productivity of the company. It increases the quality of the product that is being produced also. Now let's talk about the benefits of DevOps. Now previously, before DevOps was introduced, the whole software development took a lot of time. And after the introduction of DevOps, the whole deployment of the product is become much more faster. The frequency in which deployments are released these days is very high. And this is able to satiate the ever increasing demand of the market. And then you can basically achieve faster time to this market. If you have a product that's deployed very fast, it's tested very fast, then you can give this product to the consumer. And hence, basically you can reach the market faster than your competitor and capture the market and increase your profits. Then it also helps you to increase the recovery time. Now, you don't want your consumer to have a broken app, but we know that apps and software can break sometimes, they can crash, and we need time to fix them. So with DevOps, what we can do we can have automated rollbacks and decrease the recovery time of our software. And this can basically help maintain the reputation and increase profits again. And finally, it lowers the rate of failure of the new releases. If you release a new software every time, you know that that software is going to be stable because you have tested it thoroughly and you have pushed it through your automated code pipeline. All right, now let's talk about Agile. Now, Agile basically focuses on having multiple short-term development life cycles. Having shorter development life cycle improves the whole quality of the product. And these life cycles prioritize the feedback that you receive from your client side or your consumers. Once you've understood what the feedback is, you make the necessary changes and then go ahead and make those changes happen in your software. Now, if we looked at how Agile works, we would see that there is a whole spiral process. You have the planning phase in which you plan how you're going to be making your software. Then you have the design phase, then the development phase, then the testing phase, then the deployment phase, and then the reviewing phase. And then you launch it. Once you've launched it, you will get a feedback from your consumers or from your clients. Once you've known the feedback, you can go ahead and repeat the whole cycle until necessary. Now, this is much better compared to the older traditional methodologies like waterfall, where you first plan the whole thing out, every step of the process, and then you release the software after you did all the steps. But in Agile, you have very short software development life cycle. That basically means that you take a small microservice of your software, you create it, you first plan it, you design it, and you create it, and then you send it out so that the consumer or the customer can review it. And then you make the changes again. Now, you can have multiple of these shorter term life cycles and have your product out early. Now, remember, these life cycles are very short compared to your old traditional methodologies like waterfall, where you had a very long software development life cycle. You first planned it out, then you did a risk analysis, then you executed all of the steps, and then finally you got a feedback. You waited for a long time to get a feedback on your software. By that time, the market may have moved. Whereas with Agile, you have a very short-term life cycle, and hence you can basically release your product early, get a feedback early, and capture the market early. Now let's look at some of the benefits of Agile. Now, one of the first benefits is having transparency. Now, whether it be your customers or your client side, they know what you're developing. They have an idea of what you've developed so far. So they know what to expect from you. So if you have a good quality product, then they'll be loyal to you. They'll remain customers or they'll remain your clients. Then you can basically predict the costs and schedule tasks much more easily than in previous methodologies. Why? Because in previous methodologies, you have a very long duration and it's very difficult to predict the costs of this long duration, because there can be many variables that get involved later on that you can't predict early. But with shorter term life cycles, you know what to expect. You basically have a very short term, and you can calculate the costs much easier. You can schedule it much easier. You have lesser variables to worry about, and it allows for a lot of change. Now, we know that the market keeps on changing. The need of the market keeps on changing. And a software that may be relevant right now may not be relevant in future. To keep that in mind, we need to change the software. And Agile allows for this change to happen. It basically helps us to adapt to the market. And finally, it improves the quality of the product. If you have a continuous feedback loop, you get to know what are the errors or what are the faults in your software, and you change them to make your product much better. Now let's talk about the impact of DevOps. Now, DevOps has been a revolutionary thought. It's been a revolutionary philosophy to apply in software development. A lot of companies like Amazon, Walmart, Sony Pictures, Netflix, Adobe, all of these big enterprises are using DevOps to automate all of their processes, increase the collaboration between the developers and the other teams, etc. Even small startups and big startups in India like Ola, Flipkart, and Grofers are applying DevOps into the whole life cycle to improve the quality of their product. And this has generally been a precedent where once you start using DevOps, the whole quality of your product increases and the whole cost efficiency also increases. You are making your product more efficient and your profits are increasing. Now let's see the impact of Agile. Now, unlike for startups where they don't have to choose the old methods, the older companies that have already existed for a long time, they've been using the older traditional methodologies for a longer period of time. And because of that, the transition from them, the older methodologies, to the newer methodologies like Agile is very tough. It's a monumentous task because these companies are very expansive, very big. They have multiple teams working here and there. So after they've crossed that barrier of transitioning into a newer methodology like Agile, they have become much more prosperous. Companies like British Telecom, National Bank of Canada, Cisco, and Lego has seen a lot of increase in their profits and a lot of increase in their efficiency after they started to introduce Agile as a methodology to be used. Now that we've understood both of these methodologies or philosophy, we can go ahead and compare both of them. Meaning, now as we've discussed, DevOps is more concerned about the philosophy of software development, whereas Agile is a methodology that helps to increase the quality of the product and the efficiency in which it is produced. Now, when it comes to the implementation, DevOps does not have any different frameworks. It is more about the thought. When you are applying DevOps to your whole pipeline, you need to decide what are your own requirements. You need to find out your own requirements and use the tools that are necessary. Whereas in Agile, you have multiple frameworks that you can use or work with. You have Scrum, Lean, or feature-driven development. You can choose any of these frameworks and apply it to your software development process. The concept of team works a little different when you're talking about DevOps. Now, if you talked about traditional software development, in those methodologies or in traditional software development, you have silos or this problem of silos where you have different teams with different skills. And the blame game starts when you have different teams with different skills. If the software is not developed on time, then the teams will start blaming each other. Whereas in DevOps, all the members of this team are trained equally on the same skills. Now, how it helps is it basically shifts the mindset of an employee from departmental focus to organizational focus, where you focus on the organization's goal rather than your department's goal. Then we have emphasis. Now, if you talked about the emphasis in DevOps is for automating the whole process and creating a very understanding environment. You need to increase the morale of your employees, remove the siloing. Whereas in Agile, the whole focus is on delivering the product on a time based on relevant, perfectly on the deadline, and take the relevant feedback and use it to improve your product. Now, if we talk about evaluation, the whole evaluation concept is different again in DevOps, where in Agile, your evaluation is given by the customer's end or the client's end. In DevOps, the feedback is given by the employees themselves. They see how well their code pipeline is working, and if they see anything, with fault, they fix it by themselves. They don't look at the customer's feedback. Actually, there is no customer feedback in the case of DevOps. Then we talk about the tools used. Now, DevOps has many different tools that they can use in different combinations. Now, you have Jenkins, Kubernetes, Docker, Git, JFrog, Artifactory, Nagios, SonarQube, Puppet, Ansible. These are only a drop in the whole ocean of DevOps tools available. Unlike Agile, there are no special frameworks. It all depends on your need, and you can choose any of these tools in any combination based on their supportability. Whereas in Agile, you have different tools like Jira, Agile Bench, Pivotal Tracker, which help you to basically create an Agile environment. And finally, the goal of both of these concepts. DevOps goal is to decrease the gap between the dev and the ops team. Create an atmosphere where both of these teams do the same thing and work towards the organization's goal. Have a single goal, not departmental goal again. And again, increase the efficiency of the whole development process. Whereas in Agile, the whole aim is to decrease the gap between the understanding of the customer's need and the developers and the testers. So the Agile basically helps you to understand what the customer needs in depth. Whereas in DevOps, you're creating an environment for the employees to make the whole process of creating software more efficient. Now, if we were to discuss which one is better, DevOps or Agile? Now, this is a tricky question since it all depends on your need and the goal you're focusing on. You can use DevOps only or Agile only if that's what feels comfortable for you, or you can use DevOps in conjunction with Agile. Make the best of both of these concepts and make the best product.
Why should you become a DevOps engineer? I will be going through what are the things that you need to learn to become a DevOps engineer and why should you become one first of all. There are three things that you might think about whenever you're planning to apply for a particular profile or whenever you're planning to do a career change. And these are the three things that you should actually think about in that perspective. The first thing is job opportunities. You should think about how many job opportunities are there, right? If the kind of profile that you're applying for, is it really present in abundance? Second thing that you should think about is the salary, right? Obviously, the kind of profile that you're applying for, it should not be lower than what you're earning right now. So it should have a future. It should have its monetary benefits attached to it, and that's why the salary is also something that you should think about when you are applying for a certain profile. The third thing is who is hiring. What are companies that are actually making use of the technology, right? With that, what you get to know is what is the longevity of that technology actually existing in the world right now. Right? If Fortune 500 companies are using it, you can be rest assured that it's going to be there at least for the next 10, 15 to 20 years. All right. Now let's go ahead and get started with the salary part. Okay. So what are the kind of salaries or what are the kind of jobs? So let's talk about first job opportunities. So what are the kind of job opportunities which are there for a DevOps engineer in different countries? So I have taken the example of two countries over here. The first one is the Indian company, right? And the second one is the US company. So what we're going to talk about is, like for example, in India, if you search for DevOps engineer right now, you will find that there are 2,600 job positions which are just open on Indeed, right? I'm not taking into account the job profiles. There are Naukri, on Monster, or AngelList. There are a ton of websites where you can apply for jobs. I've just taken the data from Indeed and Glassdoor, and according to them, there are 2,600 job positions open right now in India, and 900 plus of them are present in Bangalore alone. Similarly, when we talk about US, so US has abundant job positions on Indeed for DevOps engineer. There are 21,000 plus jobs for you to become a DevOps engineer in the US. And in California alone, you will have 1,200 plus job positions to apply for. Right now, with this, I'm not trying to focus on any one country. What I'm trying to show you here is if you go to the most popular job portal in your country and search for the search term called DevOps engineer, you will get the kind of numbers which basically can boost your confidence in terms of whether I should actually go ahead and prepare for that profile or not, right? So this is the first point. Second point is the salary of a DevOps engineer. So if I talk about in India, the starting salary lies between 80,000 per month, right? And the average salary would be around 1 lakh per month, right? But that does not mean that, if you want to become a DevOps engineer, your salary would start from 80,000, or the average salary you will get 1 lakh, right? It can be well beyond this as well, right? I know people who are cloud and DevOps engineers and are earning upwards of 4 lakhs per month, right? So it all depends on what are the kind of skills that you have right now, what are the kind of experience that you're bringing to the table once you're, planning to shift to the DevOps domain by becoming a DevOps engineer. It all depends on your skill set. Second of all, if you talk about UX, right, the average salary is $11,250 per month, right? This is the starting salary, and it can go upwards to around $16,000 per month as well. But like I said, this would not be, you cannot say that this is the salary that you're gonna get. You can get more than this salary as well, and it all depends on your skill set, what you bring to the table. All right. With that said, now let's move on and talk about, how can you basically judge your salary, right? If you apply for a service-based company, in service-based company, usually the salaries are less when you compare it to a company which is product-based. So if salary is something that you are focusing on, then you can actually, you should think about what company you are applying for. If that company has its own product, the chances of that company paying you more automatically becomes more, right? Similarly, the kind of experience that you're bringing to the table, and this is relevant experience. Okay. For example, let's say you are in a different domain right now. Let's say you're in the banking sector or the financial sector, but you want to basically go ahead and do something in the tech space because that's what your interest lies in, right? So it could be that your starting salary would be less, but rest assured, once you progress in your career, your salary will become high because there is a lot of scope, at least in the cloud and DevOps domain in the coming years, because most of the companies now are making use of these practices and these technologies for getting their product up and ready on production systems, right? Similarly, when you talk about 5 to 10 years of experience, of relevant experience, obviously you will be sitting in a higher bracket of salary than the people who are 0 to 5 years of experience having relevant experience. Now, it's not like people who have 5 years of experience, they cannot surpass a guy who has 10 years of experience. You can do that. But like I said, it all depends on the skill set that you're bringing to the table, right? Now, let's talk about who is actually hiring. Which are the different companies who are hiring for DevOps engineers right now? So, guys, you can see there are a lot of big companies over here like Walmart, Amazon, Adobe, Dell, VMware, so Wells Fargo. So all these are companies which are very big names in the Fortune 500 list, and all of them are looking for DevOps engineers. And as far as I understand the IT space right now, if companies they have a tech team which is around 10 to 15 people, they will be making use of some of the other DevOps practices, and they would require a DevOps engineer in the time coming forward to them once they plan to expand their team. The moment it goes beyond 25 people, you need a cloud and DevOps engineer in your team who would be handling the work that these 25 people would be doing, right? So now that you have an idea about what companies are basically hiring for DevOps engineer, now let's talk about what a DevOps engineer basically does. So now let's move forward and talk about what does a DevOps engineer basically do, right? So guys, there are a lot of things that a DevOps engineer has to do in his day-to-day life, right? Let's discuss about that when we move forward. All right. So now let's take the example of job descriptions. Like, what are the various job descriptions which are out there, right? And what are the kind of skills that they have listed that they expect a DevOps engineer to do, right? For example, let's take the example of Oracle. So they have posted a job description for a DevOps engineer, and these are the skills that they expect. Now, the things which I've highlighted in yellow, now these are DevOps related skills, or these are skills that are mandate and would be found in most of the JDs when you're applying for the DevOps profile, right? For example, you are expected to know Unix or Linux operating system. That is a must.
when you want to become a DevOps engineer, right? Or when you are a DevOps engineer, these are the skills that you need to have, right? Similarly, you need to know about build tools like Gradle or Maven or Artifactory integration. Then you should have experience in working with tools like Git, TeamCity, Jenkins, and other CI/CD tools. Database knowledge is an added advantage, but it is not necessarily required. Similarly, you can also see that this company has also listed Java Web Services, REST, and SOAP APIs. So this is again an added thing which a DevOps engineer knows. It can fetch him a higher package, but these are not mandate skills, and this will become more clear when we talk about more job descriptions in the coming slide, right? So this is about Oracle. Now let's talk about VMware. So VMware as a company is expecting you to know Ansible, Terraform, Jenkins, Docker, etc. Right? So these are all configuration management tools that they expect, and this also coincides with what Oracle was asking, right? Then they expect you to know cloud automation software. So here, what you mean by cloud automation software is all the tools like Puppet and Ansible. These are open source tools, right? These are available as tools that you can apply on your local VMs or local servers that are there on on-premise. But when you talk about cloud has their own managed services with respect to configuration management, with respect to CI/CD pipelines. So all these things can be made use of on cloud, and that knowledge is also actually expected from a DevOps engineer when he's applying for a company. So I would suggest that you focus on open source tools first. And
let's check out our quiz question, guys. How do DevOps and Agile differ? Option A, DevOps integrates development and operations, while Agile prioritizes iterative development. Option B, DevOps emphasizes automation, while Agile focuses on collaboration. Option C, DevOps accelerates software delivery, while Agile improves project adaptability. And option D, DevOps manages infrastructure, while Agile manages project scope. I hope you have written the answers in the comment section. So now let's move on to our next session.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
The knowledge of how to basically implement the cloud tools will automatically come to you once your base is clear. That is about the open source technologies. Okay, but over here, as you can see, there is no mention about you knowing a lot of SOAP frameworks or REST APIs. That is not something which is expected in this job description. So job descriptions vary from company to company, right? But let's talk about the common things which all job descriptions has, right? So you can see that they are asking for DevOps tools like Jenkins, like Docker, like Git. So and here you will also see that they're asking for a cloud platform like AWS that you should know. Let's look at one more job description. Let's talk about Amazon. So here they are saying that you should have knowledge about Linux operating systems, right? You should have knowledge about Java or C++, right? You should have knowledge in databases like SQL or PLSQL, right? And at the same time, this would automatically expect you to also know about the different DevOps tools that a DevOps engineer should know. Right now, let's try to summarize everything that we have discussed so far by looking at three most important JDs from important companies which are looking for a DevOps engineer. So you should know about a cloud platform, right? You should know about a programming language. You should know about Unix or Linux operating system. You should know about all the DevOps tools which are part of the lifecycle like Ansible, Terraform, Jenkins, Docker, etc. Right? You should know about databases like SQL, PSQL. More focus is not there on NoSQL yet, but NoSQL databases also, the knowledge of them also would be an added advantage. when you think about how the future is going to progress with this particular profile. And at the same time, a scripting language is also important, right? So I would suggest you go ahead with Bash, because that would be covered in your Linux operating systems while you're trying to learn them, right? But if you want to learn Python as well, you can learn Python. And if you're learning Python, I think you can then skip the Java or C++ requirement, which is mentioned over here, right? Basically, what companies expect you to know is you should know how programming languages work. You would probably not be expected to code, but still, if there is a code which is not working, at least you should be able to see that code and understand what is wrong in it. So that is the kind of expectation which is basically there from a DevOps engineer when he's applying for jobs. Okay. Now, I've told you about a lot of things that you have to know. Now, some of you might have already, these skills that I just discussed about. Some of you might not have these skills or might have some skills in the list that I told you. And some of you might not have any clue as to, what skills I've just mentioned. But do not worry, guys, nothing is impossible. If you want to become a DevOps engineer and if you have the zeal to learn, and if you are really interested in this technology, you can go ahead and prepare for this profile. Now let's talk about what all are the things that you need to prepare for, and I'll also tell you how you can go ahead and prepare it in a sequential manner. Okay, so first of all, you need to learn about DevOps tools. So if you are applying for a DevOps engineer profile, the first thing that should be really clear in what you're doing is about knowing the major DevOps tools which are a part of the DevOps lifecycle, right? What are those major DevOps tools? I'll be talking about it in a little while. But first, you have to clear your knowledge about all the DevOps tools. You should know about how they work with each other. And only then you should move forward and understand about programming languages, right? So if you are planning to learn Python, this is the time. Once you have understood all the tools in DevOps, once you have a knowledge about how those tools can work together in conjunction with each other, now you go ahead and learn a programming language like Python, right? And in Python also, there are a specific set of things that you have to learn. It's not about, picking up a Python book with 1,000 pages and starting to read about it. It's not like that. There are specific things which are actually used in jobs that you can learn. And I'll be talking about that also in a little while. And once you have that knowledge, you should then, take a deep dive into understanding Linux operating system. Now, when you're implementing the DevOps tools, at the same time, you will also have the option of, learning about or using some commands in Linux operating system, but you will not get a deep dive of how Linux basically works. So once you have the knowledge about how all the DevOps tools, how they work, right, and then you have the knowledge about programming language, you understand loops, you understand if statements, conditional statements, you understand about variables, data types. Now is the time to go ahead and understand how the Linux operating systems basically work. Okay, and once you've understood that, then you have to go forward and basically familiarize yourself with other programming languages which are also out there, right? Why? Because let's say you understand how Python works. Now, it could be that your company is not using Python. They might be using C++, or they might be using .NET. But the concepts that you have learned in Python will all be the same in all programming languages, whether it be object-oriented programming languages or non-object-oriented programming languages as well. They will all have loops. They will all have conditional statements, and the logic is going to be the same in any skill that you pick up when it's related to programming language, right? So this I will recommend you all when you are applying for a specific company. Then probably it's better to learn about the language that they have specified in the JD. It's better to just refresh yourself by all the syntax which might be there, and understanding the key differences between the programming language that you know for sure, like Python, and then comparing it with that programming language and understanding what are the behavior differences between the two languages. Okay. After that, you have to learn about cloud. So learning about cloud is also very important, because most of the companies these days, they are now putting their infrastructure on cloud. So once you understand how DevOps tools basically work with each other, now is the time to implement them on a cloud provider like AWS or Azure or Google Cloud Platform. If you pick up one, I think that should be enough. So you can probably learn AWS because the chances of a company using AWS are more than Azure and Google Cloud Platform, because AWS is the largest cloud provider in the market right now. Right? Similarly, you should then go ahead and do a deep dive on tools like Ansible, which is a configuration management tool and it is very important. Right? Jenkins, which is the CI/CD tool, and it's probably the most important tools of all the tools which are there in the DevOps lifecycle. Right? So first is Jenkins, then comes Ansible, and then Docker, Git. All these things, all these tools are there, which it will not take much time of yours to learn these tools. But learning about Ansible, learning about Jenkins is a lot of scope, and you should focus more on these tools. And that's why companies specifically mention that you should be good at these particular tools. Okay. Then, like I said, cloud infrastructure is something that you need to go ahead and learn. Testing skills. So you're not expected to write test cases, but you should understand how a test basically works in a DevOps pipeline. So that is again something that you should go ahead and learn. So you should have passion, proactivity. So these are all soft skills that you need to learn. And finally, later, probably you can get to know about databases if you already don't know about them, right? But this should be the least on the list of things that you should learn, because databases is not something that you will be dealing with every day. And even if those companies have written it in the job descriptions, you will actually not be, asked about databases at all, right? You will be asked more about how, in different scenarios you can apply a different CI/CD rules, and what if a failure point happens in a CI/CD pipeline? What do you do then, or how do you handle that with the automation that you're implementing in the DevOps pipeline that you're creating?
So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right, so let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto or push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. And this is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right. So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. One second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes, and the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert, and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I have not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now, if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right. So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right, so let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto or push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in a remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. This is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. right? Now this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server, right? So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. One second. Yes. So we'll just copy this address and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes and the message should say changed background. All right. So the changes have been committed and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert, and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed, right? Now if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically a disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. and basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically, there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware, so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond, or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you've virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you have installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay. So we have come back to our AWS server. Let me clear the screen. All right. So if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a docker exec -it and then bash. Docker exec -it and then I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a ps-aux, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the dollar prompt. That we are outside the container right now. Now if I again do the same command, that is, again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a DockerFile used for? What do you basically use a DockerFile for? So a DockerFile is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Dockerfile, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it -p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's on exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a DockerFile. And what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, this is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor, and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon, and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So What is a DockerFile used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub, and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it, and we have to redeploy it if it goes down. And all of these activities which I just told you comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with. In those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system. You'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies, and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers. Which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes, and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took an example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right, but before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment my anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay. And what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm -f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the DockerFile as well. Okay, so we created a DockerFile inside okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right, so what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a DockerFile. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job. and that is it. So inside this, I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p, and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we're naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ, and let me do some changes in the code. So let's say I'll go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay, and I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to a remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master, enter the credentials, everything has been pushed, job is getting triggered, job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the three top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, It's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check, Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right. But if you talk about the architecture or the working or the life cycle of how this actually works, between on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is, I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/Ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here. I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the three dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically, I want to use the apt package to install Apache 2, the latest software. Okay. Now, what I will do, I will type in Ansible -playbook, and I'll type in Apache .yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now, what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows, or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.